Now let's see about this program. C program to calculate total and average by reading 6 subject marks. So we have to read 6 subject marks and we need to calculate total and average. So let the marks are like this. So how many subject marks we have to read? 6 subject marks. So let the marks are some 70, 70, 80, 80, 80. So these are 6 subject marks. Next we have to calculate total and average. So what is the total here? So 70 into 3 means 210. 80 into 3 means 210 plus 240. That is nothing but 450. So what is the average here? 450 by 6. That is nothing but so 6 sevens are 42. 65. Okay. So the average is equal to 75. Okay. 75. Okay. So here we can declare marks as some integer type, whereas total and average as some floating point type, or we can declare marks as also some floating point data type. Why? Because marks may be of type float, so we can get some marks as 70.5, 70.2 like that. Okay. So first we have to start from header file declaration. So in this program we have to use this hash include stdio.h. Why? Because here we are using printf and scanf functions. Printf and scanf functions are available in stdio.h. Next statement, int main. If the program is successfully executed, then it returns a value called 0. 0 is nothing but integer value. So if we want to return that value, we have to declare the return type as int. So how many subject marks are needed? 6 subject marks. So let us declare it as float. So float m1 comma m2 comma. So 6 subject marks, m3 comma m4 comma m5 comma m6. Okay. So 6 variables. Next we need total and average also. So total comma ABC. So in this program, what are the input variables? Marks are nothing but input variables. Input variable means we have to supply the marks. Whereas what are the output variables? Output variables means which values we have to display. So which values we have to display here? We have to display total and average. So input variables are nothing but marks, because we need to supply m1, m2, m3, m4, m5, m6. Whereas we need to display total and average. So total average means output variables. Okay. So let us write some printf statement. Printf enter. So how many subjects we need to read? 6 subjects. So enter 6 subject. Enter 6 subject marks. Enter 6 subject marks. Okay. Next is scanf. Here the format specifier for float is %f. So %f. F stands for float. So it specifies that we are entering some floating point number. We can enter integer number also, there is no problem. Okay. So %f. So how many %fs we have to use? 6 %fs, 3 %fs, 4th %f, 5th %f, 6th %f, comma, %. What is the first variable? m1 comma, %, m2 comma, %, m3 comma, %, m4 comma, %, m5 comma, m6. Okay. So reading is over. Next we have to do the calculations. So what is the formula for total? Total is equal to m1 plus m2 plus m3 plus m4 plus m5 plus m6. Next we have to calculate the average. So what is the formula for average? Average is equal to total. Here we have to use this forward slash. In C language or in any programming language, this forward slash specifies division. So we should not write like this. We should not write like this. Okay, this is wrong. So we have to write this. Average is equal to total comma. How many subjects we have? 6 subjects. Okay. Now display total and average. So printf slash n total is equal to. So what is the data type of the total here? Float. For float the format specifier is %f. %f, and next we have to display average also. The average is equal to, here we are printing here For printing we can use any name here. Okay, here there is no need to use ABC. It is our choice. We can write it as average or ABC or anything here. So average is equal to percentage f comma. For total, the variable name is total, whereas for average the variable name is ABC. So printing is over. Next we have to return 0. Why? Because if the program is successfully executed, then it returns a value called 0. Now let's see how the program will be executed. We know that execution starts from main function. So first we enter if subject mocks. This will be displayed on the monitor. So how many values we have to enter now? We have to use the 6 percentage f's. So we need to enter 6 values. Let the first value is some 70. Second value is some 70. Third value 70. Fourth 180. Fifth 180. Sixth 180. So 70 will be stored in M1. This 70 M2. This 70 M3. 80 M4. 80 M5. 80 M6. So these values are separated with either space bar or enter. Okay. So after entering the 70, we have to use either space bar. Okay. If you use space bar, then after 70, display 70 here. Okay. Don't write by don't giving any space. Okay. So we should not enter like this. Okay. So total is equal to M1 plus M2 plus M3 plus M4 plus M5 plus M6. So what is the total now? So 210 plus 240. That is nothing but 450. So 450.0 will be printed. Okay. Next, what is the formula for average? Average is equal to total by 6. So what is the average here? 75.0. So the output is total is equal to percentage f and average is equal to percentage f comma. So what is first percentage f? Total. What is the total? 450.0 will be printed. Average means 75.0 will be printed. Okay. So in this way we can calculate. Now let's see this program. C program to convert foreign heat temperature to centigrade temperature. So here the input is foreign heat temperature, whereas the output is centigrade temperature. The formula for converting foreign heat temperature to centigrade temperature is, the formula here is C is equal to F minus 32 into 5 by 9. 5 by 9. So let's start the program. So hash include stdio.h. Why? Because we are using printf and scanf functions. Those two are available in stdio. Next, void main. So this void specifies that main function doesn't return any value. Here we require two variables. The first variable is f. F stands for foreign heat temperature, whereas the second variable is c. C stands for centigrade temperature. Here what is the input? Foreign heat temperature is the input. So printf enter foreign heat temperature. Printf enter foreign heat temperature. So this message will be printed on the monitor. Next is scanf. Here f is of type float. For float the format specified is percentage f comma ampersand. For foreign heat temperature the name of the variable is f. So ampersand f. Next we have to convert that one into centigrade temperature. So C is equal to f minus 32 into 5 by 9. 5 by 9. Next to display the output. Printf centigrade temperature is equal to here centigrade temperature is nothing but C. So C is of type float. So the format specified is percentage f comma C. Next, to close the main function. Now let's see how this program will be executed. So we know that execution starts from main function. So enter foreign heat temperature. So this message will be printed on the monitor. Let me enter some 64. So this formula will be calculated. So 64 minus 32 means what? 32. So 32 into 5 by 9. Okay. So 32 into 5 by 9. So what is 5 by 9? First 32 into 5 by 9. So this expression will be calculated and the corresponding result will be printed on the monitor. So centigrade temperature is equal to that message will be printed on the monitor. Let us assume that our target is we would like to convert centigrade temperature to foreign heat temperature. So if you want to convert centigrade to foreign heat, then what is the input variable? C is the input variable, whereas F is the output variable. So here what is the formula here? So F minus 32 is equal to, from this equation we can write as F minus 32 is equal to, so 9 into C. 9 into C by 5. Okay, F minus 32 is equal to, so 9 into C by 5. So F is equal to, so what will happen? 9C by 5 plus 32. Okay, so by using this formula, we can convert centigrade temperature to Fahrenheit temperature. So we can write the program as printf enter centigrade temperature, scanner percentage F comma ampersand C. So here what is the formula? F is equal to 9 into C by 5 plus 32. Next to display the corresponding output message. Printf the Fahrenheit temperature is percentage F comma F. So in this way we can convert centigrade to Fahrenheit temperature as well as Fahrenheit to centigrade temperature. Now let's see a C program to swap two numbers without using temporary variable. Without using temporary variable. C program to swap two numbers without using temporary variable. Here temporary variable means third variable. Okay. So without using third variable, we have to perform the swapping. Okay. So let A is equal to 10, B is equal to 20. So after swapping, A value should be 20, B value should be 10. So initially A value is 10, B value is 20. After swapping, A value becomes 20 and B value becomes 10. So without using temporary variable, we have to perform the operation. Okay. Here we have two logics. In the first logic, with the help of addition and multiplication, we will write the logic. Whereas in the second logic, with the help of multiplication and division operators, we will write the logic. So let's see the first logic with the help of addition and subtraction. So which operator will give larger value, plus or minus? We know that plus always gives larger value than minus. Okay. So here the first statement is A is equal to A plus B. Perform the addition operation. Okay. So what is A value now? A is equal to, what is A value? 10. What is B value? 20. Okay. So A will become 10 plus 20. So A will become 30. So now A value is 30. Okay. So after swapping, we have 30 in A, 20 in B. So after swapping, what is B value? 10 is the B value. So how to get 10 from 30 and 20? How to get 10 from 30 and 20? So 30 minus 20 is nothing but 10 only. So we can write as B is equal to A minus B. B is equal to A minus B. What is A value? 30. What is B value? 20. So 30 minus 20 means 10. Okay. Now B value contains 10. Okay. And now we have 30 in A, 10 in B. Okay. So how to get 20 from 30 and 10? That is nothing but 30 minus 10. So we can write as A is equal to A minus B. So A value is 30, B value is 10. So 30 minus 10 means 20. So this is our first logic. Okay. So let's write that program first. So main. So int A comma B. Let us perform initializations. A is equal to 10, B is equal to 20, A is equal to A plus B. Next B is equal to A minus B. A is equal to A minus B. Next display the output printf after swapping A is equal to percentage D and B is equal to percentage D comma A comma B. Now let's check whether our logic is correct or not. So what is A value? 10. What is B value? 20. What is the first statement? This is equal to operator. Is equal to operator assigns right hand side value to left hand side variable. So A plus B means 10 plus 20. So 10 plus 20 means 30. So 30 will be assigned to A. Next B is equal to A minus B. A value is 30. B value is 20. So 30 minus 20 means 10. So 10 will be assigned to B. Next A is equal to A minus B. A means 30. B means 10. 30 minus 10 means 20. So 20 is assigned to A. So after swapping A is 20, B is 10. So here it is very simple to write the logic here. So initially we have 10 in A. Initially we have 10 in A, 20 in B. So which operator will produce a larger value? Addition operator. Plus operator will produce a larger value. So the first statement is A is equal to A plus B. So 10 plus 20 means 30. So now A contains 30. So 30 minus 20 is nothing but 10. So 10 is nothing but the value of B after swapping. So we can write as B is equal to A minus B. So 30 minus 20 means 10. So now 10 is available in B. Now A contains 30, B contains 10. 30 minus 10 is nothing but 20. So A is equal to A minus B. Okay. Now likewise, let us write the logic with the help of multiplication and division operators. With the help of multiplication and division operators. Let A is equal to 10, B is equal to 20. So after swapping A value 20, B value 10. With the help of multiplication and division operators, we have to write the logic now. We know that multiplication will produce a larger value. So we can write the first statement as A is equal to A into B. So A value 10, B value 20. So 10 into 20 means 200. So 200 is stored in A. Okay. Next, we have 200 in A, 20 in B. So what is 200 by 20? So 20 200. Okay. So 20 tens are 200. Division operators will always produce quotient. Okay. The 10 is nothing but the value of B after swapping. So the next statement is B is equal to A by B. B is equal to A by B. What is A? 200. 200 by 20 means 10. So 10 is nothing but the value of B. Now B contains 10. Next, how to get 20 in A? A value is 200. B value is 10. 200 by 10 is nothing but 20. So B is equal to, what is the statement? A by B. So what is the first statement? A is equal to A into B. So A contains 200. Next statement, B is equal to A by B. B is equal to A by B. So 200 by 20 means 10. Next, A is equal to A by B. So 200 by 10 means what? 20. Okay. 200 by 10 means 20. So after swapping A, it becomes 20. B becomes 10. So in this way, we can swap two numbers with the help of, without using temporary variable. So without using third variable, we can swap two numbers like this. So we have two logics. Now let's see a C program for swapping two numbers. Here we can swap two numbers using temporary variable as well as without using temporary variable. That is nothing but using third variable as well as without using third variable. Now let's see the first program. A C program to swap two numbers using temporary variable. Using temporary variable. Okay. This temporary variable can also be called as third variable. Okay. Third variable. So let we have two variables like this. Let A is equal to 10, B is equal to 20. So after swapping, A value should be 10 and B value should be 10. Okay. So with the help of a temporary variable, we have to perform this operation. Let's see the logic here. Let name of the temporary variable is T. So T is equal to. So first store A value in T. So T is equal to A. So now T contains which value? So T is equal to, what is A value? So now T becomes 10. So now A value is available in 10. Now A value is available in 10. So what we can do now? We can directly store B value in A without worrying about A value. Why? Because A is already available in the temporary variable. So we can write the next statement as A is equal to B. A is equal to B. So what will happen now? A is equal to B. What is B value? 20. After swapping, what is the A value? A value should be 10 only. So A is equal to 10. Next, after swapping, what is B value? B value should be 10. But the 10 is available in T. So we can write as B is equal to T. B is equal to. So what is T value here? 10. So in this way we can swap two numbers. We know what is the use of is equal to operator. Is equal to is useful for assigning a right hand side value to left hand side variable. So whenever the statement is executed, A is assigned to T. Whenever the statement is executed, then B is assigned to A. Whenever the statement is executed, then T is assigned to B. This is the first logic here. Logic 1. Logic 2. Let us write logic 2. In the first logic, what we have done? We have stored A value in T. In the second logic, store B value in 10. Store B value in T, temporary variable. Okay. So now what will happen? T will become. So what are the initial values of A? A is equal to 10, B is equal to 20. So what is T value now? T value is 20 now. Then now B value is available in T. B value is available in T. So now we should not worry about B value. Okay. It is already available in what? Temporary variable. So we can store A value in B now. So B is equal to A. Why? Because b is already available in t. Okay. So if b value changes, then there is no problem. So b is equal to a. So whenever the statement is executed, then what will happen? A value will be assigned to b. So b is equal to, what is a value? 10. So 10 will be stored down. Next, what is the last statement? B contains 10. So after swapping, a contains 20. The 20 is already available in t. So we can write the statement as a is equal to t. So what is a value? A is equal to t. What is t here? 20. Okay. So after swapping, what is a? 20. B 10. Here also after swapping a 20, b 10. So by using these two logics, we can swap two numbers with the help of the temporary variable. Here we can write the logic very easily. So what is the first statement? Temp is equal to a. A is the first variable. So the second statement starts with this right hand side variable. What is the right hand side variable? A. A is equal to b. Here it is ending with b. So the next statement starts with b. So b is equal to t. So likewise we can write the second logic also very easily. So t is equal to b. So the first statement is ending with b. So the second statement starts with b. So b is equal to a. The second statement is ending with a. So the third statement starts with a. A is equal to t. So we can write the logic very easily. Okay. So this is the first logic. So we can write the program very easily now. So hash include. What is the first statement? Hash include stdio.h. Next, void main. It specifies that main function doesn't return any value. Next, let us perform initialization. First declare two variables int a comma b. Next, a is equal to 10, b is equal to 20. Here we need one more variable. What is that variable? T. So what is the first logic? T is equal to a is equal to b, b is equal to t. So printf after swapping a is equal to %d and b is equal to %d comma a comma b. So initially what is a value? 10. Initially what is a value? 10. What is b value? 20. So what is the first statement? Temp is equal to a. What is the is equal to operator? It assigns right hand side value to left hand side variable. So t is equal to a. What is a value? 10. Now t contains 10. Next, a is equal to b. What is b value? 20. So now 20 is assigned to a. So a value contains 20. Next, b is equal to t. What is t value? 10. So 10 is assigned to b. So now b contains 10. Okay. So after swapping, a is equal to %d, b is equal to %d. What is a value? 20. What is b value? 10. So likewise, we can write the logic also. The second logic also. What is the second logic? T is equal to b, b is equal to a is equal to t. Okay. So in this way, we can swap two numbers using temporary variable. Okay. Now let's see this program. C program to print sum of squares of first n natural numbers. We know the formula for calculating sum of squares of first n natural numbers. Here the formula is n into n plus 1 into 2n plus 1 by 6. So this is the formula for calculating sum of squares of first n natural numbers. So in this program, the input variable is n value, whereas the output variable is, let us assume that some sum. Okay. So let us write the program. So what is the first statement here? Hash include stdio.h. Why? Because in this program we are using printf and scanf functions. Those two are available in stdio.h. Next, void main. So this void specifies that the main function doesn't return any value. So what is the input variable here? N is the input variable. So int n. Next, what is the input variable? N is the input variable. So read the value. So printf enter n. Next, in order to read the value, we use a scanf. So scanf. Here n is of type integer. For integer, the format specified is %d, %d comma %n. Okay. Next, to calculate the sum. So in order to calculate the sum, it is better to declare one more variable, sum. So what is the formula here? Sum is equal to n into, we have to place n plus 1 within parenthesis. Okay. So n plus 1 into, next one, 2n plus 1. So 2n means we are performing multiplication operation. So 2 into n plus 1. So this is nothing but numerator. So we have to place numerator within parenthesis. So it will become an expression. So by 6. Okay. So we have to write like this. If you don't use parenthesis, then what will happen is, if you write like this, n into n plus 1 into 2n plus 1 by 6, then what will happen is, here we have a star operator, plus operator, star operator, and plus operator. So star operator has higher precedency. So first n into n will be calculated. So next what will happen, this 1 into 2 will be calculated. Next it will be multiplied with n. But we should not calculate like this. So we have to evaluate the equation as n into next n plus 1 into 2n plus 1. Okay, this is numerator. So it is better to enclose this in parenthesis, so that first this expression will be evaluated, and after that the corresponding result is divided with 6. Next to display the output. So printf sum is equal to percentage d comma. So what is the output here? Sum. So display sum. Next to close the main function curly brace. Now let's see how this program will be executed. So enter n value. So let n is 4. So scan of percentage d comma ampersand n. So 4 will be stored in n. Next to sum is equal to. So this formula will be calculated 4 into. So 4 plus 1. 4 plus 5 means 5 into. Next 2 into 4 means 8. 8 plus 1 means 9. So 9 by 6. So 4 into 5, 20. So 20 into 9 by 6. So 20 into 9 means 180. So 180 by 6 means 30. So 30 is the output. So sum is equal to percentage d comma sum. So what is the output here? 30 will be printed on the monitor. Okay. Let us assume that our program is like this. Sum of first and natural numbers. Sum of first and natural numbers. Then what is the modification that we have to do? Sum of first and natural numbers. We know the formula for sum of first and natural numbers. N into n plus 1 by 2. N into n plus 1 by 2. Okay. So here what is n value? Let n value is 4. Then 4 into 4 plus 1 means 5. So 4 into 5 by 2. So 2 2s. So 2 into 5 means 10 is the output. Okay. Let's our target is we want to find out sum of cubes of first and natural numbers. We know the formula for finding the sum of cubes of first and natural numbers. Here the formula is n square into n plus 1 whole square by 4. So n square can be written as n into n plus 1 whole square can be written as n plus 1 into n plus 1 into n plus 1. So this is one expression, this is one expression. Next this is nothing but numerator. So place this in parenthesis by 4. Okay. So likewise we can calculate sum of first and natural numbers, sum of squares of first and natural numbers, sum of cubes of first and natural numbers. For sum of first and natural numbers, the formula is n into n plus 1 by 2. For sum of squares of first and natural numbers, the formula is for squares, the formula is n into n plus 1 into 2n plus 1 by 6. Whereas for cubes, the formula is n square into n plus 1 whole square by 4. Now let's see this program. C program to print biggest of 4 numbers using simple if statement. So with the help of a simple if, we have to find out biggest of 4 numbers. Let the numbers are like this: 10, 20, 30, 40. So we have to find out biggest of 4 numbers. So if you take these 4 numbers, then the biggest number is 40. So 40 will be the output. Okay. Here we should not use if else. So which control statement we have to use? We have to use only simple if. Here the logic is very simple. So compare, let the variables are like this: A, B, C, D. So compare A with B, C, D. If A is greater than B and A is greater than C and A is greater than D, then we can say that A is the biggest number. Otherwise, compare B with A, C, D. If B is greater than A, C, D, then we can say that B is the biggest number. Otherwise, compare C with A, B, D. If C is greater than A, B, D, then we can say that C is big. So likewise, we have to make the comparisons. So let's write the program now. The first statement is hash include stdio.h. Why? Because in this program we are using printf and scanf functions. Printf and scanf functions are available in stdio.h. Next, main function. Execution of the C program will start from main function. Next, let us have 4 variables. So A, comma, B, comma, C, comma, D. Okay. Then read those variables. Before that, display some message. Printf enter 4 values. Printf enter 4 values. Next, scanf. Here those 4 values are of type integer. For integer, the format specifier is %d. So scanf %d. So how many %d's? Here we are reading 4 numbers. So 4 %d's. So comma, ampersand A, comma, ampersand B, comma, ampersand C, comma, ampersand D. Okay. Next, here the logic is very simple. We have to compare A with B, C, D. If A is greater than B, C, D, then we can say that A is the biggest number. So here the first condition is if A greater than B, double end, A greater than C, double end, A greater than D, then printf. So which is the biggest number? A is biggest number. So A is big. If, here we have to use only if, okay, don't use if else, okay. Why? Because here what is our target? We have to print biggest of 4 numbers using simple if, okay. So what is the second condition? Compare B with ACD. If B is greater than ACD, then we can say that B is the biggest number. So if B is greater than A, double end, B is greater than C, double end, B is greater than D, then we can say that B is the biggest number. So printf B is big. So next one. So what is the next one? Compare C with A, B, D. So if C is greater than A, double end, C is greater than B, double end, C is greater than D, then we can say that C is the biggest number. So printf C is big. C is big. Next we have one more condition. What is that one? Compare D with A and B. If D is greater than A, double end, D is greater than B, double end, D is greater than C, then we can say that D is the biggest number. So printf D is big. Okay. Next to close main function. Now let's see how this program will be executed. So printf enter 4 values. Let the values are 10, 20, 30, 40. So A value 10, B value 20, C value 30 and D value 40. So first condition, if A greater than B, so 10 greater than 20, so condition is false. So which operator we use here? Logical AND. What is logical AND? If both operands are true, then only the result is true. Otherwise the result is false. But here one of the operand is false. So we can say that the entire result is false. So what will happen? Next condition will be evaluated. If B greater than A, 20 greater than 10, very good, the condition is true. Next one, B greater than C, 20 is greater than 30, 20 is greater than 30, condition is false. Here we use logical AND. So if one of the expression is false, then the entire result is false. Okay, so that this body won't execute. So the next condition will be evaluated. C greater than A. So 30 greater than 10, condition is true. 30 greater than 20, condition is true. But 30 is greater than 40, condition is false. So one of the expression is false. So the entire result is false. So that the next condition will be evaluated. B greater than A. 40 greater than 10, true. 40 greater than 20, true. 40 greater than 30, true. So all the 3 conditions are true. So what will happen? D is big. This message will be printed on the monitor. Okay. So now let's see this program. C program to check whether a given number is positive or negative. So here input is n. So n means a number. So when we can say that a number is positive number, if n is greater than 0, then we can say that the number is positive number. If this condition is false, then we can say that the given number is a negative number. So now let's write the program. So hash include stdio.h. Next main function. Next what is the input variable? N is the input variable. Next, read n value. So before that, display the message. So printf enter n, printf enter n. Next, scanf percentage d comma ampersand n. So now n contains the corresponding value. So when we can say that a number is positive number, if n is greater than 0, if n is greater than 0, printf, then we can say that the given number is positive number. Suppose if this condition is false, then we can say that else printf, the given number is negative number. Okay, the given number is negative number. Next, we close the main function. Now let's see how this program will be executed. We know that execution of a program starts from the main function. So int n. So initially some memory will be allocated for n. Initially some garbage value will be stored in n. Let the address of the n is some 1000. So printf enter n, scan of percentage d comma ampersand n. Let the value is some -20. So that -20 will be stored in n. So first condition will be checked. If n greater than 0, so what is n here? -20. So -20 is greater than 0. -20 is greater than 0. Condition is false. So else block will be executed. So what is the message? Negative number will be printed. Let us execute this program one more time. Okay. Printf enter a number. Let the number is 5. So 5 is greater than 0. Condition is true. So printf positive number will be printed on the monitor. So in this way we can check whether a number is positive number or negative number. Now let's see this program. C program to check whether a given number is even or odd. So what are the even numbers? 2, 4, 6, 8. These are nothing but even numbers. What are the odd numbers? 1, 3, 5, 7. All these are nothing but odd numbers. So how can we say that a given number is even number? If it is divisible with 2, then we can say that it is even number. Suppose if the given number is not divisible with 2, then we can say that it is not a even number. That means it is an odd number. Here divisible means we have to perform modulo operation with 2. If we get remainder value as 0, then we can say that it is even number. Suppose if we get other than 0, then we can say that it is odd number. Okay. Let us take 4 here. So 4 modulo 2. So what is the result of 4 modulo 2? So 2, 4. So 2 2s are 4. So modulo will always gives remainder. So what is the result here? 0 is the result. So we can say that 4 is even number. Let's take 3 here. So 3 modulo 2. So 2, 3. So 2 1s are 2. So 3 minus 2 means 1. So we can say that 3 is odd number. Why? Because here what is the result here? 1 is the result. Okay. So by performing modulo operation with 2, if we got result as 0, then we can say that it is even number. If we got result as 1, then we can say that it is odd number. Now let us write the program. So main function int n. So first we have to read a number. So printf enter a number. Printf enter a number. Enter a number. Next read the number with the help of scanf function. So scanf percentage d comma ampersand n. So what is even number? If you perform modulo with 2, if you get result as 0, then we can say that it is even number. So if n modulo 2 double is equal to 0, then printf it is even number. Suppose if this condition is false, then we can say that it is odd number. So else printf odd number. Else printf odd number. Okay. Now let's execute this program. We have given the number 53. So what is 53? 53 is odd number. So let's check whether our logic is correct or not. If n modulo 2 double is equal to 3, so 253. So 2 2s are 4. So 5 minus 4 means 1, 1 3. So 2 6 are 12. So 13 minus 12. So what is 13 minus 12? 1. So what is the modulo will always gives remainder. So here what is the remainder? 1. 1 double is equal to 0. Condition is false. So printf odd number will be printed. Okay. Let us assume that we have given 4. So 2, 4. 2 2s are 4. So 4 minus 4, 0. So what is the remainder here? 0. So we can say that 4 is even number. So in this way we can check whether a given number is even number or not. Now let's see this program. C program to check whether given number is divisible by 3 or not. So we have to check whether the number is divisible by 3 or not. Let the input is 9. So we can say that this number is divisible by 3. Why? Because if we perform modulo 3 operation, then what is the result? The result is 0. So we can say that this is divisible by 3. If you take the number 21, so is 21 is divisible by 3 or not? What is the result of 21 modulo 3? 0. So we can say that this is also divisible by 3. Okay. So divisible by 3 is nothing but the multipliers of 3. So what are the multipliers of 3? That is nothing but 3 multiplication table. So 3 is 6, 9, 12, 15, 18, 21, 24, 27, 30. All these are nothing but the numbers which are divisible by 3. Okay. And let us assume that I have taken 5. So what is the modulo result here? So 3, 5. So 3 ones are 3. So 5 minus 3 means 2. So which operation we are performing? Modulo. So modulo will always gives remainder as the result. Here what is the remainder? 2 is the remainder. So we can say that 5 is not divisible by 3. Whereas if you take 24, so 24 modulo 3. So 3, 24. So what is the result here? 3 8s are 24. So what is the remainder? 0. So we can say that 24 is divisible by 3. So for that we have to write the program. So let's write the program now. So here the first statement is hash include stdio.h. Why? Because we are using printf and scanf functions. So next main function. Next a variable, an integer variable, integer n. Next printf, enter a number. Next scanf, %d comma %n. So here what is the logic here? If n modulo 3 double is equal to 0, then we can say that %d is divisible by 3. So here what is %d? %d is nothing but the number n. Else printf. So here we can say that %d is not divisible by 3. %d is not divisible by 3. Okay. So what is %d? %d is nothing but n. Now let's check whether our program is correct or not. We know that the execution of a program starts from main function. Printf enter n, scanf %d comma %n. So let n value is 10. So we have to perform 10 modulo 3. So what is the result of 10 modulo 3? So 3 3s are 9, 10 minus 1. Modulo will always gives remainder. So what is the result here? 1. 1 double is equal to 0. Condition is false. So here we can say that 1 double is equal to 0. Condition is false. So we can say that here %d is not divisible by 3. So what is %d? 3. So 3 is not, what is %d? 10. Why? Because here %d is nothing but n value. So what is n value? 10. So 10 is not divisible by 3. Will be printed on the monitor. Let us take one more input. So let the value is 3. So 9 modulo 3. So what is the result of 9 modulo 3? So 3, 9. So 3 3s are 9. So 9 minus 9, it is 0. So the result of 9 modulo 3 is 0. 0 double is equal to 0. Condition is true. So the body will be executed. %d is divisible by 3. So what is %d here? N value. So we can say that 9 is divisible by 3. So in this way we can develop the program. Now let's see this program. C program to check whether given character is vowel or not. Vowels are nothing but small a-e-i-o-u or capital a-e-i-o-u. So if we entered small a-e-i-o-u or capital a-e-i-o-u, then we have to display the message as given character is vowel. If we entered other than these characters, then we have to display the message as the given character is not a vowel. Here we can write the program with the help of if else as well as switch. Let's write the program with the help of the if else. We know that execution, the first statement is hash include stdio.h. Why? Because we are using printf and scanf functions. Those two are available in stdio. Execution of a program starts from main function. We have to declare one character variable. In order to declare a character variable, we have to use the data type char space. Let name of the variable is ch. Now display the message on the monitor. Printf enter a character. Printf enter a character. Here, in order to read a single character, it is better to use getChar function. The syntax for the getChar function is ch is equal to getChar. Variable name is equal to getChar. Okay. Now getChar, let us assume that we have entered x. So getChar function reads x from the keyboard and assigns x to ch. Now ch contains x. So here what is the condition? If ch double is equal to a is a character constant. So we have to enclose a within single quotation. If ch double is equal to a, this is nothing but logical OR. So what is logical OR? If one of the expression is true, then the entire expression is true. If one of the expression is true, then the entire expression is true. So that's why we are using logical OR here. So if ch double is equal to small a, or if ch double is equal to small e, it is a character constant. So we have to enclose within single quotation. Or ch double is equal to small I, or ch double is equal to small o, or ch double is equal to small u, or ch double is equal to, what is the one more condition? Capital A, or ch double is equal to capital E, or ch double is equal to capital I, or ch double is equal to capital O, this is capital O, or ch double is equal to capital U. Then we can say that if one of these condition is true, then we can say that printf %d is vowel. %d means ch. Else we can say that printf we can say that %c is not a vowel. What is %c? %c means ch here. Okay. Now let's check whether our program is correct or not. So we know that execution of a program starts from the main function. So char ch. So for ch the memory will be allocated. Printf enter a character so that this message will be printed on the monitor. Ch is equal to getChar. Let us assume that we have entered. U. So what will happen? Small u this is. So that getChar function reads small u from the keyboard and assigns it to ch. Now ch contains small u. So now the condition, this if block will be checked. What are the conditions here? Ch double is equal to small a. Here this is nothing but a character constant. We have to enclose character constant within the single quotation. In order to check whether two characters are same or not, we have to use this double is equal to operator. So this is nothing but double is equal to operator, not single is equal to operator. Single is equal to is for assigning a right hand side value to left hand side variable, whereas double is equal to is for checking whether two operands, two values are equal or not. Okay. So here what is the character here? U double is equal to a, false. U double is equal to e, false. U double is equal to I, false. U double is equal to o, false. U double is equal to u, true. This is true, and these remaining conditions are also false. So what is logical OR? If one of the expression is true, then the entire result is true. Here out of 10 expressions, one expression is true. So what will happen? The entire expression will become true. So if body will be executed. So what is if body? %c is vowel. So what is %c? Ch. What is ch? U. So u is vowel will be printed on the monitor. If block is executed, so else block won't execute. Let us assume that we have entered a character called W. Okay. WA, WE, WI, WO, WU. So all the 10 conditions are false. So what will happen? If will becomes false. So whenever if condition becomes false, then the else block will be executed. So what is the else block here? %c is not a vowel, ch. So what is %c? ch. So what is ch here? W. So W is not a vowel will be printed on the monitor. Okay. So in this way we can write the program with the help of if else. Now we have to write the same program with the help of switch. So let's write the program now. This block is same only, printf enter a character. Next ch is equal to get char. Next switch off. Here what is the variable here? Ch is the variable. Switch off ch within the curly braces. Case. Here we have 10 cases. The first one is for small a, case. The next one is for small e. Next one is for case small I, colon, because every case ends with colon. AE, IOU are nothing but some character constants. We have to enclose character constants within single quotation. So case small u, next one case capital A, next one case capital E. So next case AE is over, case capital I, next case capital O, next case capital U. So if one of these case is true, then we can say that the given character is a vowel. So printf percentage C is vowel. So what is percentage C? Percentage C means CH. Okay. Else, here else means default. Suppose if the character doesn't matches with these 10 cases, then we can say that the corresponding character is not a vowel. So printf percentage C is not a vowel. So what is percentage C here? CH. Okay. Here after this we have to use this break. If we don't use this break, then what will happen? Default case will also get executed. Here there is no need to write printf in all these 9 cases. Okay. Why? Because AE, small AE, IOU and capital AE, IOU are nothing but vowels only. Okay. So instead of that we have written the percentage C is vowel only in the last case, and after that break statement is executed. Okay. So whenever break is executed, then the control comes out from the switch. Okay. Suppose if switch doesn't matches with any case value, if the expression doesn't matches with any case value, if the variable doesn't matches with any case value, then what will happen? Default case will get executed. So let we have entered W. So what will happen? W will be compared with all these cases. So W doesn't matches with any of these case value. So default gets executed. So what is the default here? Printf percentage C is not a vowel, comma CH. So what is CH? W. So W is not a vowel, message will be printed on the monitor. So let us assume that we have entered a small Vo. So what will happen? Control directly goes to case small Vo. But here we don't have any statements, as well as we don't have any break statement. So what will happen? Next it will be shifted to U. Next it will be shifted to A. Next it will be shifted to E. Here also we don't have any statements. So next I, we don't have any statements. Vo, we don't have any statements. But in case U, we have some statements. So those statements will be executed. Printf percentage C is vowel, comma CH. So what is CH? Vo. So small Vo is vowel will be printed. Next break. So this break statement gets executed. If you don't use break, then what will happen? Default gets executed. That means Vo is not a vowel. This message is also printed on the monitor. Okay. So whenever break statement is executed, then the control comes out from the switch. Okay. So in this way, we can check whether the given character is vowel or not. Now let's see about this program. C program to print biggest of two numbers, followed by C program to print smallest of two numbers. Let we have 10 and 20. So what is the biggest number between 10 and 20? So 20 is the biggest number. So we have to display the message as 20 is big. Okay. Here it is very easy to write the program. We have a relational operator called greater than. By using greater than operator, we can compare two operands. Let the name of the variables are A and B. So if A is greater than B, then we can say that A is big. Otherwise, we can say that B is big. Okay. So let's write the program. The first statement is hash include stdio.h. Why? Because in our program we are using printf and scanf functions. Those two functions are available in stdio.h. Okay. Next, execution of a program starts from main function. In this program we are comparing two values. So we need to declare two variables. So int a comma b. Next, read that variables. Before performing reading, display message printf enter two numbers. So display this message on the monitor so that we know that we have to enter two numbers. Next, for reading the numbers, use scanf function. Scanf. Here these two numbers are of type integer. For integer, the format specified is percentage %d. So percentage d, comma. So variable names are a and b. So ampersand a, comma, ampersand b. So let the names of the variables are a and b here. So let the values are 10 and 20. So now a contains 10 and b contains 20. So here the condition is, if a is greater than b, then we can say that a is big. Okay. Then we can say that a is big. So printf a is big. Else, if this condition is false, then we can say that printf b is big. Printf b is big. Okay. And then close the main function. Now let's check how our program will be executed. We know that execution of a program starts from main function. Enter two numbers. Let me enter two numbers 10 and 20. So 10 will be stored in A, 20 will be stored in B. If A greater than B, so A value 10, B value 20. So 10 is greater than 20. 10 is greater than 20. Condition is false. So what will happen? This else block will be executed. So printf B is big. Here what is B value? 20. So B is big will be printed on the monitor. Okay. Instead of displaying A and B, if we want to display values, then we can write as here A is of type integer. For integer, the format specified is percentage %d. So percentage %d is big, comma A. Here percentage %d is big, comma B. Okay. Now if you check the condition, 10 greater than 20, 10 greater than 20, condition is false. So else block will be executed. Printf percentage %d is big, comma B. So what is percentage %d? In place of percentage %d, B will be printed. So what is B here? 20. So 20 is big, will be printed on the monitor. Okay. Now let's find out smallest of two numbers. Initially we find out biggest of two numbers. Now let us find out smallest of two numbers. Here we need to change only one condition. Instead of greater than operator, we have to use this less than. Okay. If A is less than B, then we can say that A is the smallest number. So printf percentage %d is small, comma A. Suppose if this condition is false, then we can say that B is the smallest number. So printf percentage %d is small, comma B. Okay. Let's check the condition. Here what is A value? A value is 10, B value is 20. So 10 is less than 20. 10 is less than 20. Condition is true. So printf percentage %d is small, comma A. So what is percentage %d here? 10. So 10 is small will be printed on the monitor. Okay. Here instead of using if else, we can also use conditional operator in order to know the biggest or smallest numbers. Let's write this program with the help of the conditional operator. A greater than B. We know the syntax for the conditional operator. Expression 1 question mark. The syntax for the conditional operator is expression 1 question mark, expression 2 colon, expression 3. So first expression 1 will be evaluated. If it is true, then expression 2 will be executed. Suppose if expression 1 is false, then expression 3 will be executed. Okay. If expression 1 is true, then expression 2 will be executed. Whereas if expression 1 is false, then expression 3 will be executed. Okay. Initially we have read two variables, and now we have to write this logic: A greater than B. So if this condition is true, then we can say that which is the biggest number? A is the biggest number. So printf A is big. Okay. Colon. Suppose if this condition is false, then we have to display the message as printf B is big. Printf B is big. Okay. So here what is A value? 10. What is B value? 20. So 10 greater than 20. This condition is false. So what will happen? This expression 3 will be executed. So what is expression 3? Printf B is big will be printed on the monitor. So likewise we can also write smallest of two numbers using conditional operator. Okay. Now let's see this program. C program to check whether given year is leap year or not. Actually every year contains 365 days, whereas leap year contains 366 days. So that is the only difference between a normal year and a leap year. So what is the difference? Leap year contains 366 days, whereas a normal year contains 365 days. Okay. Here the logic is very simple. So let's see the program. Here the input is year value. So print of enter year, scanf percentage d comma ampersand year. If the year is not divisible by 4, then we can say that it is not a leap year. If the year is not divisible by 4, then directly we can say that it is not a leap year. Suppose if the year is divisible by 4, then we have to check whether it is divisible by 100 and 400 or not. If the year is not divisible by 100, if year modulo 100 not equal to 0 or year modulo 400 double is equal to 0, then we can say that the corresponding year is leap year. Else print of percentage d is not a leap year. Okay. So here what is the logic here? First we have to check whether the corresponding year is divisible by 4 or not. If the year is not divisible by 4, then we can say that it is not a leap year. Let the year is 2011. So 2011 modulo 4, what is the result? That result is not equal to 0. Okay. So 4 2011. So 4 5s are 20. So 11. 4 2s are 8. So 11 minus 8 means 3. So what is the modulo result here? 3. So 3 double is equal to 0. Condition is false. So this else block will be executed. Print of percentage d is not a leap year. So what is percentage d? Percentage d means year. So we can say that 2011 is not a leap year. Suppose if it is divisible by 4, then we have to check whether it is divisible by 100, 400 or not. If it is not divisible by 100 or if it is divisible by 400, then we can say that it is a leap year. That is the condition we have written. Year modulo 100 is not equal to 0. That means if it is not divisible by 100 or year modulo 400 double is equal to 0. That means if it is divisible by 400, then we can say that the corresponding year is a leap year. Else print of percentage d is not a leap year. This percentage d stands for year. We know what is logical OR. Logical OR means if one of the operand, if one of the expression is true, then the entire result is true. Let's take the year 2012. So 2012 modulo 4. So what is the result of 2012 modulo 4? So 4 2012. Okay. 4 5s are 20. Okay. Next 12. 4 3s are 12. So what is the result? 0. So we can say that this condition is true. So next check this condition. If year modulo 100 is not equal to 0, so 2012 modulo 100, the result is not equal to 0. So we can say that this is true. So here there is no need to check this condition. If one of the expression is true, then automatically the entire result is true. So print of percentage d is leap year will be printed on the monitor. So in this way we can check whether a year is leap year or not. Now let's write this program. C program to print biggest of 3 numbers. Let me have 3 numbers 10, 20, 30. So out of 10, 20, 30, so 30 is the biggest number. So we have to display the message as 30 is big. Okay. Let 10 is stored in A, 20 is stored in B, 30 is stored in C variable. Here the logic is very simple. We have to compare A with B and C. If A is greater than B as well as A is greater than C, then we can say that A is the biggest number. Okay. If A greater than B, double and A greater than C, then print of A is big. Okay. What is logical? And if both operands are true, then only the result is true. Suppose if that condition is false, that means A greater than B, A greater than C. If that condition is false, then we can say that A is not the biggest number. So then compare B and C. If B is greater than C, then we can say that B is the biggest number. Otherwise we can say that C is the biggest number. So not only A, we can take B and compare B with A and C. If B is greater than A as well as B is greater than C, then we can say that B is the biggest number. If that condition is false, then we can say that B is not the biggest number. So compare A and C. If A greater than C, then A is the biggest number. Otherwise C is the biggest number. Or we can take C and compare C with A and B. If C is greater than A as well as C is greater than B, then we can say that C is the biggest number. Otherwise compare A and B. If A is greater than B, then A is the biggest number, otherwise B is the biggest number. Okay, let us take A and compare A with B and C. Let's write the program. Here we know that execution of your program starts from main function. So hash include stdio.h. We know that execution of your program starts from main function. Next, how many variables are needed here? 3 variables. So int a comma b comma c. So before reading, display message on the monitor, printf. So how many numbers we have to enter here? 3 numbers. So enter, printf, enter 3 numbers. Enter 3 numbers. Next, for reading, we have to use a scanf function. So scanf. So we are reading 3 integer numbers. So we have to use 3% this. 3% this, comma. So names of the variables are ABC. So ampersand A comma, ampersand B comma, ampersand C. Here we are using else if ladder. Why? Because we have more than 3 conditions. Okay, more than 2 conditions. If there are more than 2 conditions, then it is better to use a else if ladder or nested if else. It is very easy to write the program with the help of the else if ladder. Okay. If so, what is the condition? Compare A with B and C. If A greater than B, double end A greater than C. So if A is greater than B as well as A is greater than C, then we can say that A is the biggest number. So printf A is biggest number, A is big. Next, else if. After else we have to use a space. Why? Because else and if are 2 different words. Else if, suppose if this condition is false, then we can say that A is not the biggest number. So we have to compare B with C. So else if B is greater than C. Compare B and C. Suppose if B is greater than C, then we can say that B is the biggest number. So printf B is big. Okay. Else, suppose if this condition is false, then we can say that C is the biggest number. So else printf C is the biggest number. C is big. Next, close the main function. Now let's check how this program will be executed. We know that execution of a program starts from the main function. Initially we have declared 3 variables. Printf enter 3 numbers. So this message will be printed on the monitor. Next we can enter 3 numbers now, 10, 20, 30. So 10 will be stored in A, 20 will be stored in B, 30 will be stored in C. So first condition, if A greater than B, double end A greater than C. A value 10, B value 20, C value 30. So 10 greater than 20, false. 10 greater than 30, false. Both the conditions are false. What is logical end? If both are true, then only the result is true. If both are true, then only the result is true. But here both are false. So the entire expression is false. So if will returns false value. So whenever if condition is false, then automatically the control will be transferred to the next condition. So else if B greater than C. Here what is the B value? 20, C value 30. So 20 is greater than 30. 20 is greater than 30. This condition is also false. So automatically the last else block will be executed. So printf C is big message will be printed on the monitor. Okay. So let us assume that we have values like this. So 20, 30, 10. So first condition will be evaluated. 20 greater than 30. 20 greater than 30. Condition is false. 20 greater than 10. Condition is true. False, true. Which operator we use? Logical end. So logical end means if both are true, then only the result is true. But here one of the operand is false. So the entire expression is false. So control will be transferred to the next condition. Else if B greater than C. 30 is greater than 10. 30 is greater than 10. Condition is true. So B is big. The message will be printed on the monitor. Okay. Here we can write, we can find out biggest of 3 numbers using conditional operator also. So we know what is a conditional operator. Now let us write the program with the help of conditional operator. So what is the syntax for the conditional operator? Expression 1, question mark, expression 2, colon, expression 3. If the expression 1 is true, then expression 2 will be executed. Suppose if the expression 1 is false, then expression 3 will get executed. If expression 1 is true, then expression 2 will be executed. Suppose if expression 1 is false, then expression 3 will be executed. Okay. Here we are finding biggest of 3 numbers. Let us declare a variable called big. Let us write the code here. Big is equal to, first to compare a greater than b, double L a greater than c. Compare this one. A greater than b is one expression, a greater than c is another expression. So this entire will become one expression. So enclosed within parenthesis. If this condition is true, then we can say that a is the biggest number. So colon a. Okay. So this a will be assigned to b if this condition is true. Else, that is nothing but colon. If this condition is false, then we have to compare b and c. So b greater than c. Suppose if this condition is true, then we can say that b is the biggest number. Suppose if this condition is false, then we can say that c is the biggest number. Okay. So very simple here. First we are comparing a with b and c. If a is greater than b as well as a is greater than c, then a is the biggest number. This is the true block. Suppose if this condition is false, then we have to compare b and c. So it will be executed. Suppose if this condition is true, then b is the biggest number. Otherwise c is the biggest number. Let the values of a, b, c are 1, 2, 3. So 1 greater than 2, 1 greater than 3. So both are false. So the entire expression will be false. So expression 3 gets executed. So this is expression 3 after colon. Next to b greater than c. This condition, what is b? 2. C value 3. 2 greater than 3. 2 greater than 3. Condition is false. So what will happen now? If this condition is false, then what will happen? Expression 3 will be executed. Expression 3 means after colon, what is the expression? C. So this c will be assigned to big now. So what is c here? 3. So display that message. Printf. So display the message as percentage d is big. Percentage d is big, comma big. So what is percentage d here? Big. What is the big value now? C value. What is C value? 3. So 3 is big message will be printed on the monitor. Okay. So in this way, we can find out biggest of 3 numbers using LCF ladder as well as using ternary operator or conditional operator. Now let's find out smallest of 3 numbers. We can find out smallest of 3 numbers using LCF ladder as well as using ternary operator. So let's write this program with the help of those two approaches. Let me have numbers like this. So 3, 2, 1, 3, 2, 1. So what is the smallest number here? 1 is the smallest number. So we have to display the message as 1 is small. Okay. Here the logic is very simple. Let the names of the variables are a, b, c. If a is less than b as well as a is less than c, that means if both conditions are true, then we can say that a is the smallest number. Why? Because a is less than b as well as a is less than c. So we can say that a is the smallest number. Suppose if that condition is false, then we can say that a is not the smallest number. So compare b and c. Suppose if b is less than c, then we can say that b is the smallest number. Otherwise we can say that c is the smallest number. So likewise we can compare b with a and c with a and b. If you take c, then compare c with a and b. If you take b, then compare b with a and c. If you take c, then compare c with the remaining 2 numbers a, b. If you take b, then compare b with the remaining 2 numbers a, c. So if you take c, then compare c with a and b. So if c is less than a as well as c is less than b, then we can say that c is the smallest number. Okay. Suppose if this condition is false, then we can say that c is not the smallest number. So compare a and b. If a is less than b, then a is the smallest number. Otherwise b is the smallest number. Now let us take a and compare a with b and c, because that is the most commonly used approach. So let's write the program. We know that execution of a program, the first statement is hash include stdio.h. Why? Because in our program we are using printf and scanf functions. Those two are available in stdio. Next, execution of a program start from main function. Here we have 3 variables, int a comma b comma c. Next we have to read those 2 variables. Before that, display the message printf enter 3 numbers. Printf enter 3 numbers. Next scanf. So how many numbers we have? 3 numbers. So 3 integer numbers. So for integer the format specified is %d. So %d, %d, %d comma ampersand A comma ampersand B comma ampersand C. Here the logic is very simple. If A is less than B, double end. Double end means if both are true, then only the result is true. If A is less than B, double end A is less than C, then we can say that A is the smallest number. So we can write as printf percentage D is small. So what is percentage D here? EA. Next here we have more than two conditions. So we are using else if ladder. Here else and if are two different words. So we have to use a space between else and if. Else if this condition is false, then we can say that A is not the smallest number. So compare B with C. So else if B is less than C. If B is less than C, then we can say that B is the smallest number. So printf percentage D is small, comma, what is percentage D? B. Suppose if this condition is false, then we can say that C is the smallest number. So else printf percentage D is small. So what is percentage D here? Percentage D means C. Now let's check how our program will get executed. We know that execution of a program starts from the main function. So int ABC. So three variables will be created. The memory will be allocated for those three variables. Printf, we enter three numbers. So we entered three numbers. Those three numbers will be stored in ABC. So now A contains 3, B contains 2, C contains 1. Now let's check the condition. If A is less than B, double end A is less than C. Here A, B, C are 3 to 1. 3 is less than 2, false. 3 is less than 1, false. Both are false. But what is logical end? If both are true, then only the result is true. But here both are false. So the entire expression is false. So if will returns false, so what will happen? Control will transfer to the next condition. Else if B is less than C, B value 2, C value 1, 2 less than 1, 2 less than 1, condition is false. So the control will be transferred to the next condition. So else block will be executed. So what is the else block? Percentage D is small. What is percentage D? C. So what is C? 1. So 1 is small will be printed on the monitor. Now let's write the program with the help of the conditional operator. So reading is same only. Now let's write the program with the help of the conditional operator. We know the logic for the conditional operator. Conditional operator or ternary operator. Expression 1, question mark, expression 2, colon, expression 3. First the expression 1 will be evaluated. If the expression 1 is true, then expression 2 will be executed. Suppose if the expression 1 is false, then expression 3 will be executed. Okay. Let us declare a variable, one more variable called small. So small is equal to, so what is the first one? A less than B, double end A less than C. Suppose if this condition is true, then we can say that A is the smallest number. So colon A. So this A will be assigned to small if this is true. Else, that means colon, because here we are using two operators. Question mark, colon. After question mark we have true block. After colon we have false block. Suppose if this condition is false, then we have to compare B and C. So compare B and C. B less than C. Question mark. If it is true, then we can say that B is the smallest number. Next, if it is false, that means colon, then C will be executed. So C is the smallest number. Semicolon. Okay. Now after the execution of this body, the small contains the smallest variable. So display that variable. So printf percentage D is small, comma. So what is the name of the variable? Small. Now close the main function. And now let's check whether our logic is correct or not. Let we have three numbers like this, 3, 1, 2. So first condition, A less than B. 3 is less than 1. Condition is false. A less than C. 3 is less than 2. Both the conditions are false. So what will happen? The entire expression will become false. So expression 2 will be executed. So expression 3 will be executed. When expression 2 gets executed, if the condition is true, but here the condition is false. If the condition is false, then expression 3 will be executed. So it will be executed. B less than C. So B value 1, C value 2. 1 is less than 2. 1 is less than 2. Condition is true. So what will happen? This expression 2 will be executed. After question mark, we have expression 2 for this expression. Okay. So this B will be assigned to small now. So now small contains B value. What is B value? 1. So printf percentage D is small comma small. So what is small? 1. So 1 is small will be printed on the monitor. So in this way we can find out smallest of three numbers or minimum of 3 numbers using LCF ladder or ternary operator. Now let's see this program. C program to perform arithmetic operations using LCF ladder. So with the help of LCF ladder we have to perform arithmetic or calculated operations. We know what are the arithmetic operations: plus, minus, star, division and modulo. We know about plus, minus, star. Let's see what is division and modulo. Let me have 5 by 2 and 5 modulo 3. 5 by 2, 5 modulo 2. So 2, 5. So 2 2s are 4. So 5 minus 4 means 1. Okay. Division will always give quotient. So the result of 5 by 2 is 2. Whereas modulo will always give remainder. So the result of 5 modulo 2 is 1. So in this example the input variables are operator and a number. So we have to enter an operator. Let the operator is plus, whereas the numbers are 3, 4. So we have to perform addition operation on 3 and 4. So what is the result? 7. So let the operator is star, whereas the numbers are 3, 5. So what is the result of 3 into 5? 15. So likewise we have to perform the operations. So let's see the program. The first statement is hash include stdio.h. Why? Because we are using printf and scanf functions. Printf and scanf are available in stdio.h. Execution of a program starts from main function. Here this operator is nothing but a character variable. So char Voce, where Voce stands for operator. Next we require 2 numbers. Okay, 2 numbers. Let the first number is n1, whereas the second number is n2. So first read an operator. Before that display some message. Printf enter an operator. Printf enter an operator. So scanf, it is of type character. So for character variable the format specified is %c. So %c comma %. Name of the variable is Voce. So %Voce. Okay. Next we have 2 numbers. So read those 2 numbers. Before that display the message. Printf enter 2 numbers. So on which numbers we need to perform the corresponding operations. Here these numbers are of type integer. For integer the format specifiers are for integer it is %d. So scanf %d comma. So what is the control string here? %d is the format specifier, so it is the control string. So ampersand n1 comma n2. So let us write the program with the help of the LCF ladder. If Voce, if operator equal to, here we have to use this double is equal to. Double is equal to is equality operator. If you want to compare whether 2 operands are equal or not, then we have to use this double is equal to. It is a character constant, so enclosed within single quotation. If Voce double is equal to plus, then printf addition is equal to addition. This is double quotation. Addition is equal to, what is the result? Arithmetic operator will always give result as integer. So for integer the format specifier is %d. So which operation we have to perform? Addition. So n1 plus n2. Okay. LCF. What is the next operator? Minus. LCF. Voce double is equal to minus. Then which operation we have to perform? Subtraction operation. So printf, display the message result. Printf subtraction is equal to %d comma. So subtraction means n1 minus n2. Okay. Addition is over, subtraction is over. Next we have to write the code for multiplication, division and modulo. Here else and if are 2 different words. So we have to use just a space between else and if. So let's see the next condition. So else if Voce double is equal to, what is the next operator? Next arithmetic operator star. So display multiplication result. So printf multiplication is equal to, here we are displaying an integer value. So the format specifier is %d comma n1 into n2. Next, what is the next operator? Division. So else if Voce double is equal to division, it is a character constant. So we have to enclose within single quotation. So printf division is equal to percentage d comma. So perform division on n1 and n2. So n1 by n2. So what is the last operation? Modulo operation. So else if OP double is equal to modulo, then display the modulo result. So printf division is over. What is the next one? Modulo. So modulo is equal to percentage d comma n1 modulo n2. Okay. So the program is over. Next to close the main function. Now let's see how this program will be executed. We know that execution of a program starts from the main function. So printf enter an operator. Let the operator is plus. So now let the operator is star. So OP contains star now. Star. Next to printf enter two numbers. Let the first number is 10, second number is 20. So 10 is available in n1, whereas 20 is available in n2. Next, first condition will be checked if OP double is equal to plus. But what is OP? Star. Star double is equal to plus. Condition is false. So next condition will be evaluated. Star double is equal to minus. Condition is false. So the next condition will be evaluated. Star double is equal to star. Star double is equal to star. Condition is true. So multiplication is equal to what is percentage n1 star n2. 10 into 20 means 200. So 200 message will be printed on the monitor. So here this block is executed. So the control comes out from the LC ladder. Okay. So in this way we can perform arithmetic operations with the help of LC ladder. Now let's see this program. C program to calculate the student grade in the examination. Suppose if the average is greater than or equal to 90, then print the grade as A. If it is between 80 to 99, then print the grade as B. 70 to 79, C grade. 60 to 69, D grade. 40 to 59, E grade. Less than 40, F. F stands for fail. So in this example, the inputs are some 6 subjects. Next we have to calculate the average. So average is nothing but the sum of the marks by the total number of subjects. Next, based upon the average, we have to print the grade. So let's start the program. Let us write the program with the help of LC ladder. So here the first statement is hash include stdio.h. Why? Because we are using printf and scanf functions. Printf and scanf functions are available in stdio.h. Next, main function. We know that execution of a program starts from main function. So let we have 6 subject marks. Let us assume that the marks may be of type float. So let us declare here some float. So float. So we have 6 subject marks. Let the first subject marks are denoted by m1. Next m2, m3, m4, m5, m6. So 6 subject marks. Next we have to calculate the total and average. So comma total, comma average, ABC. Okay. So these are the variables. In this example, the input variables are nothing but the marks. So first you enter the marks. So printf, before reading the message, let us display that information. You enter. So how many subjects we are reading here? 6 subjects. So you enter 6 subject marks. Next to scanf. Here the marks are of type float. So for float, the format specified is percentage F. So we have to use this percentage F. So scanf. So how many percentage Fs we have to use? We have 6 subject marks. So we need to have 6 percentage Fs. So scanf, percentage F, percentage F, percentage F, 3 percentage. Next to 4th percentage F, 5th percentage F, 6th percentage F, comma, comma. So what are the marks here? M1, M% M1, comma M% M2, comma M% M3, M% M4, M% M5, and M% M6. Okay. Let us write. Let us calculate total and average. So total is equal to. So what is the formula for total? Total is nothing but the sum of all the subject marks. So M1 plus, M2 plus, M3 plus, M4 plus, M5 plus, M6. So calculation of total is over. Next we have to calculate the average. So for average the formula is total by number of subjects. So here the number of subjects are nothing but 6. So the formula for average is equal to total by 6. Average is equal to total by 6. Okay. So with this reading is over. as well as total calculation is over. Next, average calculation is over. Next, we have to write the program. We have to write the LC ladder based on these constraints. So let us erase these statements. So for space constraints, I am erasing these statements. Now let us write LC ladder. So what is the first condition here? If average is greater than or equal to 90. If it is greater than or equal to 90, then what is the grade? A grade. So printf A grade. A grade. Next, the second condition. Else if, here if and else if are different words. Else and if are two different words. So between else and if we have to use a space. Okay. Because these two are entirely different words. So else if, what is the second condition? Average is in between 80 to 89. If it is 90, then it is A grade only. If average is greater than or equal to 80, double end. Why? Because these two conditions must be true. Double end, average is less than or equal to 89. If these two conditions are true, then the grade is B grade. So printf B grade. Printf B grade. So next one, else if. So use a space between else and if. Else if, what is the next condition? In between 70 to 79. Suppose if it is 80 average, then it should be B grade. Okay. So else if average is greater than or equal to 70, double end, average is less than or equal to 79. So then what is the grade? Between 70 to 79, the grade is C grade. So printf C grade. So printf C grade. So next condition, between 60 to 69, it is D grade. So else if 60 to 69. So else if average is greater than or equal to 60, double end, average is less than or equal to 69, then the grade is D grade. So printf D grade. So next constraint, else if average is in between 40 to 59, average is greater than or equal to 40 and average is less than or equal to 59. So if it is between 40 to 59, then what is the grade? E grade. So printf, what is the grade? E grade. Else, in else if ladder, for last else, there is no need to specify any condition. If we want, we can specify the condition as else if average is less than 40. So when this else block will be executed, if average is less than 40 only, so there is no need to write if condition here. Else is sufficient. Okay, else, print out what is the grade? F, where F stands for fail. So F grade. Then how many curly braces we have to close? So only one curly brace, that is nothing but for main function. Now let's see how this program will be executed. We know that the execution of a program starts from main function. So totally we have 6 input variables here. So that message will be printed on the monitor. Enter 6 object mocks. So that we have to enter 6 numbers. So let us assume that we have entered 3 mocks like this: 80, 80, 80, 90, 90, 90. So where M1 mocks are nothing but 80, M2 mocks 80, M3 80, M4 90, M5 90 and M6 90. Next total will be calculated. So what is total now? So 8 into 3 24, 9 into 3 27. So 24 plus 27 means 7 fours, that is nothing but 510. Next average will be calculated. So average is nothing but total by 6. So 510 by 6 means what? 6 8s are 48, 85%. Okay. So first condition will be evaluated. If the average is greater than or equal to 90. But what is average? 85. 85 is greater than or equal to 90. Condition is false. So control will be transferred to the next condition. So next condition will be evaluated. What is average? 85. 85 is greater than 80. True. Next 85 is less than 89. 85 greater than 80 true. 85 less than 89 true. So both the conditions are true. We are using logical AND. If both are true, then the entire expression is true. So printf B grade message will be printed on the monitor. So in this way we can calculate student grade with the help of else if ladder. Now let's see this program. C program to calculate electricity bill by following these constraints, these are nothing but units, these are nothing but charges. If the units are between 0 to 200, then the charges are 50 paise per each unit. If the units are between 201 to 400, then the charges are 100 rupees plus 65 paise per unit excess of 200. If the units are between 401 to 600, then the charges are 230 rupees plus 0.80 per unit excess of 400. If the units are between 601 and above, then the charges are 390 plus 1.5 paise per unit excess of 600. Let the units are 500. Let the consumption units are 100. So 100 is in between 0 to 100. 100 is in between 0 to 200. So the charges are 50 paise per unit. So that means 50 paise is nothing but 0.5. So 0.5 into how many units consumed? 100 units. So 100 into 0.5 is nothing but 50 rupees. So 50 rupees is the amount that we have to pay. Let the consumption units are 300. Let the consumption units are 300. 300 is not between 0 to 200. So this condition is false. So this is true. 300 is in between 201 to 400. So what are the charges now? 100 rupees. So 100 plus 65 paise per unit excess of 200. That means for the first 200 units, the charges are 100 rupees. Whereas for the remaining units from 201 to the remaining, the charges are 65 paise. So here what are the units now? 300 is the units. So for the first 200 units, what is the charge? 100 plus here the condition is units minus 200 into, so how many paise we need to pay? 65 paise. That is nothing but 0.65. So for the first 200 units it is 100, whereas the number of units consumed are 300. So 300 minus 200 means 100. So for the next 100 units we have to pay 0.65 paise. So 100 into 0.65 means 65 rupees. So 100 plus 65 means 165 rupees. So we have to pay 165 rupees as the amount. Let the consumption units are 500. Then how much amount we need to pay? So 500 is not between 0 to 200. 500 is not between 201 to 400. Whereas here 500 is between 401 to 600. So how much amount we need to pay? For the first 400 units, the amount is 230. So 230 plus units minus, what is the previous one? 400 into how much amount we need to pay? 0.8. So 230 plus, so what are the consumption units now? 500. So 500 minus 400 means 100. That means for the units from 401 to 500, per each unit we have to pay 0.8 paise. So 100 into 0.8. So 100 into 0.8 means what? 80 rupees. So 230 plus 80 means what? 310. So likewise we have to perform the calculation. So if you see the program, then you will get the perfect idea about what we are doing. Okay. So let us write the program now. The first statement is hash include stdio.h. Why? Because in our program we are using printf and scanf functions. Printf and scanf are available in stdio.h. Next we know that execution will start from main function, main. Next here the input variables are, the first one is customer number. So int, let customer number is represented by some cust and go. So int customer number cust and go. Next number of units consumed. Okay. So number of units consumed, let it be some float value. So float units. Unit stands for number of units consumed. Next we have to calculate the charges also. So that is nothing but let it be some charges. Okay. So first read the input variables. So what are the input variables? Customer number and number of units consumed. So printf enter customer number. So scanf for customer number, what is the data type? Integer. So scanf %d comma ampersand, name of the variable is CUST. So CUST and no. Next, the next input variable is, what is the next input variable? Units. Printf enter number of units consumed. So how many number of units we consumed? Enter number of units consumed. Next scanf. Units may be of type float because we may consume like 100.5 units, 500.6 units like that. So scanf, if it is float, so the format specifier is percentage of comma. What is the name of the variable? Units. So ampersand units. So let's write the program with the help of the LC ladder. So what is the first condition? If it is between 0 to 200, then the charges are 50 paise per unit. So let us write the first condition. If units is greater than 0, or we can write it as greater than or equal to 0, and units is less than or equal to 200. So if it is between 0 to 200, then the charges is equal to, so what are the charges? 50 paise per each unit. So we can write it as units into 50. So we can write it as 0.5 into units. 50 paise is nothing but 0.5. Okay. Else if, here else and if are two different words, so we have to use just a space between else and if. Here what is the constraint? 201 to 400. So else if units greater than or equal to 201, double end units is less than or equal to 400, then the charges is equal to, so what are the charges? 100 rupees. 100 plus 65 paise per unit excess of 200. So excess of 200 means we have to subtract the corresponding units from 200. So units minus 200 into, so what is the amount we need to pay? 65 paise. 65 paise is nothing but 0.65. So that means here for the first 200 units we are paying 100 rupees. Whereas for the remaining units from 201 to 400 we are paying 65 paise. So this is very important here. Units minus 200. Whereas for this condition we have to write as units minus 400 into 0.8. Whereas for this condition we have to write as units minus 600, excess of 600. Excess of 600 means units minus 600 into that amount. So else if, so what is the next condition? From 401 to 600. So this can be written as units is greater than or equal to 401, double end units is less than or equal to 600. Then how much amount we need to pay? Charges is equal to, how much amount? 230 rupees plus 80 paise per unit excess of 400. Excess of 400 means what? Units minus 400. If there are 500 units, then for the first 400 units it is 230, and for the remaining 100 units it is what is the charge? 80 paise. So 80 paise is nothing but 0.8. Okay. Next, what is the next one? 401 to 600 is over. Next is 601 and above. Here there is no need to write the condition. Why? Because the last else block will be executed if all the previous conditions are false only. Okay. So here there is no need to write the condition as else if units is greater than or equal to 601. Why? Because if all the previous are false, then we can say that the units are greater than or equal to 601 only. Else, so what is the charges we need to pay? Else charges is equal to 390 rupees. So we have to pay 390 rupees plus 1.5 rupees, 1.5 paise per unit excess of 600. So excess of 600 means we will get units minus 600 into 1.5 into 1.5. So calculation is over. So next what we have to do? We have to perform the displaying. So printf, just to display, if we want we can display customer number and units also, but I am displaying only charges. So charges are very important here. Printf amount to be paid is, here it is of type float, so percentage of comma, so that amount is available in charges variable, comma charges. So right parenthesis ends with semicolon. Next, close the main function. Now let's check whether our program is correct or not. We know that execution of a program is passed from the main function. So the first input variable is enter customer number. Let the customer number is 1234. Next, printf enter number of units consumed. Let the number of units consumed are some 500. So what will happen? So first this condition will be evaluated. 500 is greater than 0. It is true. 500 is less than 200. 500 is less than 200. Condition is false. Which operator we use as logical AND? What is logical AND? If both expressions are true, then only the result is true. But here one of the expression is false. So the entire expression is false. So this condition is false. So the next condition will be evaluated. 500 is greater than 201. False. 500 is less than 400. 500 less than 400. False. So the entire expression is false. Next one. 500 is greater than 401. False. 500 is less than 600. 500 is less than 600. 500 is less than 600. So this condition is also true. So both the conditions are true. So the entire expression is true. So this block will be executed. So charges is equal to 230 rupees plus units. Units means 500. So 500 minus 400 means 100. So 100 into 0.8. So 100 into 0.8 means 80 rupees. So 80 rupees plus 230 means 310. So 310 is the amount that we need to pay. So here this else, if this block is executed, so this else won't execute. The control comes out from the else if ladder. The amount to be paid is equal to 310 rupees. So in this way, we can calculate electricity bill by assuming some constraints. Now let's see this program. C program to calculate roots of a quadratic equation. We know that a quadratic equation is represented in the form ax square plus bx plus c is equal to 0. Where a, b, c are nothing but some real or integer values. So here, in order to calculate the roots of this equation, first we have to calculate discriminant value. The formula for discriminant is d is equal to b square minus 4ac. The value of d may be either equals to 0 or greater than 0 or less than 0. If d double is equal to 0, if d is equals to 0, then we can say that the roots are real and equal. Whereas if d greater than 0, then the roots are, if d is equals to 0, then what are the roots? Roots are real and equal. Whereas if d is greater than 0, then the roots are real and different. Here real means floating point value. Whereas if d is less than 0, then the roots are imaginary. Okay. So how to calculate the roots of a quadratic equation? By calculating discriminant value. What is the formula for discriminant? D is equal to b square minus 4ac. D value may be either equals to 0 or greater than 0 or less than 0. If d equals to 0, then we can say that the roots are real and equal. Whereas if d is greater than 0, then we can say that the roots are real and different. Whereas if d is less than 0, then we can say that the roots are imaginary. Okay. Like we have an equation like this: x square plus 2x plus 1 is equal to 0. So what is d value here? What is the formula for d? D is equal to b square minus 4ac. Here what is a? A is equal to 1. Whereas b is nothing but 2. Whereas c is nothing but 1. What is the equation? Ax square plus bx plus c is equal to 0. So 1 into x square means 1. So a value 1. Bx, b means 2. C means 1. Okay. So what is d value here? B square minus 4ac. 2 square means 4. Whereas 4ac, 4 into 1 into 4, that is nothing but 4. So d value is 0. Okay. Here d is 0. So we can say that the roots are real and equal. Here, in order to calculate the roots of a quadratic equation, the formula is minus b plus or minus square root of b square minus 4ac by 2a. Here b square minus 4ac is nothing but discriminant value. If d equals to 0, then square root of 0, that is nothing but 0. Then we can say that the roots are nothing but minus b by 2a. Here what is b? B is nothing but minus 2. Whereas 2 into a means 2, that is nothing but minus 1. So the first root is minus 1 as well as the second root is minus 1. Whereas if d is greater than 0, let the equation is like this: x square plus 5x plus 6 is equal to 0. X square plus 5x plus 6 is equal to 0. Where a value is 1, b value is 5, c value is 6. So what is the d now? b square minus 4ac. So 5 square means 25, whereas 4ac means 4 into 1 4, 4 into 6 means 24. So d is equal to 1. So we can say that d is greater than 0. If d is greater than 0, then the roots are real and different. Let's see how to find out the roots here. So the first root is minus b plus square root of d by 2a, whereas the second root is minus b minus square root of d by 2a. So what is the first root here? Minus b. What is b value here? What is b value? 5. So minus 5 plus square root of d. What is b value? 1. Square root of 1 means 1. 1 by 2 into a. So 2 into 1 means 2. So minus 4 by 2. That is nothing but minus 2. This is the first root. Whereas what is the second root? Minus b minus square root of d. So minus 5 by 2. So minus 5 minus 1 means minus 6. So minus 6 by 2 is nothing but minus 3. So x square plus 5x plus 2 is equal to 0. If you multiply, then 6x square. Whereas if you add, then 5x. So x square plus 3x plus 3 into 2s are nothing but 6x square. 3x plus 2x means 5. Plus 6 is equal to 0. If you common x plus 3. If you common 2, x plus 3. Okay. So x plus 3 into x plus 2 is equal to 0. So the values are minus 3 and minus t. So likewise we can calculate imaginary also. Let the equation is like this. X square plus x plus 1 is equal to 0. So what is the d value here? b square 1 4ac minus 4. So 1 minus 4. So what is 1 minus 4? Minus 3. So minus 3 is less than 0. So we can say that the roots are imaginary. Okay. So let us write the program for solving this problem. So let us start from hash include stdio.h. Why? Because in this program we are using printf and scanf functions. We know that execution of a program starts from main function. So after that we can have main function. So hash include stdio.h. Next main function. Next we have to declare the variables. Here the variables which are needed are, first we need ABC. Let ABC are of type float. Next we have to calculate the roots. So we need R1 as well as R2. Next we have to calculate the discriminant. So we need to have a variable called D. Okay. So first let us declare those variables. So float. So what is the first variable? A comma, B comma, C comma, R1 comma, R2 comma, D. Okay. Next what are the input variables? A, B, C are nothing but input variables. So printf enter ABC values. ABC values. Why? Because we are representing the equation in the form of ax square plus bx plus c is equal to 0. Okay. Next is scanf. Here ABC are of type float. For float the format specified is %f. So scanf %f comma ampersand a comma ampersand b comma ampersand c. Next we have to calculate the discriminant. How to calculate the discriminant? B square minus 4ac. So d is equal to b square means b into b, whereas 4ac means we have to perform multiplication operation on 4 into a into c. Okay. Next, if d double is equal to 0, that means here the equation is in the form of x square plus 2x plus 1 is equal to 0. So what is d value? B square minus 4ac. So 4 minus 4, d is equal to 0. So if d double is equal to 0, then we can say that how to calculate the roots? Minus b plus or minus square root of b square minus 4ac by 2a. Okay. But here square root of b square minus 4ac, that is nothing but d value is 0. So the roots are minus b by 2a. The two roots are equal only. Okay. So if d double is equal to 0, then printf roots are real and equal. Real means there may be a possibility that we may get some float values, real and equal. So what is R1? R1 is equal to minus b by 2 into a. What is R2? R2 is also R1 value. So that is nothing but minus b by 2 into a. Okay. Next to printf, display the root. Printf root 1 is equal to here what is the format specified for R1 R2? %f, and root 2 is equal to %f comma. For first %f, what is the variable name? R1. For the second %f, what is the variable name? R2. So with this the first condition is over. Let us write the next condition. So what is the next condition? Else if d is greater than 0. Else if d is greater than 0. Else and if are two different goals. So we have to use a space between else and if. So else if d is greater than 0. Then we can say that the roots are real and different. The formula is, the best example is x square plus 5x plus 6 is equal to 0. So d is equal to 25 minus 24. That is nothing but 1. So 1 is greater than 0. So we can say that roots are real and different. Minus 2 and minus 3. Okay. So printf roots are real and what is the second one? Different. So next, what is the formula here? What is the first root here? R1 is equal to minus b plus square root b square minus 4ac by 2a. But in order to calculate the square root, we have to use this sqrt function. Sqrt function is available in math.h. So we have to include math.h in our program. Why? Because we are using sqrt function. So R1 is equal to, what is the formula here? Minus b plus sqrt of b by 2 into a. So what is the formula for R2? R2 is equal to minus b minus square root of d by 2 into a. So this is nothing but numerator. So you enclose within parenthesis. This is denominator. So you enclose within parenthesis. So that there is no problem. Okay. This expression and this expression will be evaluated separately. Suppose if you don't use parenthesis, then what will happen is based upon the priority, that expression will be evaluated. So this expression will not be evaluated first. Parenthesis has highest priority than any other operator. So it is better to enclose in parenthesis. Okay. Then after that, display the roots. Printf root 1 is equal to percentage f comma R1. So likewise display R2. So printf root 2 is equal to percentage f comma R2. Okay. Else, so when this else block will be executed, if d is less than 0. So if d is less than 0, then what are the roots? Roots are imaginary. So we know what is the imaginary number. It is represented in the form of a plus ib, a minus ib. Roots are imaginary. Okay. So here this else is closed. Next close the main function. Now let's see how this program will be executed. We know that execution of a program, C program, starts from the main function. So printf enter ABC values. Let the ABC values are some 1 to 1. So 1 to 1. So 1 to 1. Next d value will be calculated. So what is d value? B square minus 4ac. So 4 minus 4, that is nothing but 0. If 0 is double is equal to 0, condition is true. So roots are real and equal. That message will be printed on the monitor. R1 is equal to minus b by 2a. So R1 is equal to, what is minus b? Minus 2 by 2a. That is nothing but minus 1. Whereas R2 value is also same. Minus b by 2a. That is nothing but minus 2 by 2. That is nothing but minus 1. So here what are the roots? Root 1 is equal to minus 1 and root 2 is equal to minus 1 will be printed on the monitor. So if you calculate, then x square plus 2x plus 1 is equal to 0. So multiplication means 1x square, whereas addition means 2x. So that is nothing but x square plus x plus 1 is equal to 0. Common x. So x plus 1 plus common 1 here between these two terms. So x plus 1. So x plus 1 into x plus 1 is equal to 0. So what are the x values? Minus 1, minus 1. Now let us execute this program one more time. So let the roots are 1, 5, 6. Let ABC values are 1, 5, 6. So what is d value? D is equal to b square minus 4ac. So 5 square means 25. So 25 minus 24 means 1. So d value now is 1. So 1 double is equal to 0. Condition is false. So second condition will be evaluated. 1 greater than 0. Condition is true. So this block will be executed. Roots are real and different. So what is R1? R1 is equal to minus d minus 5 plus square root of d. That is nothing but square root of 1. Square root of 1 means 1. So minus 5 plus 1 by 1. That is nothing but minus 4 by 1. Minus 4 by 1. Minus 5 plus 1 means what? So what is the formula here? By 2a. So what is 2a? 2 into 1. That is nothing but 2. Second root minus 5 minus 1 by 2. So minus 5 plus 1 means minus 4. So minus 4 by 2 means minus 2. Whereas minus 5 minus 1 means minus 6. So minus 6 by 2 means minus 3. Next, so in this way we will get output as minus 2, minus 3. And if we run this program one more time, Let the input values we have given as 1, 1, 1. That means x square plus x plus 1 is equal to 0. So d is equal to b square minus 4ac. So 1 minus 4, that is nothing but minus 3. So minus 3 double is equal to 0, false. Minus 3 greater than 0, false. So this else block will be executed. Roots or imaginary message will be printed on the monitor. So in this way we can find the roots of a quadratic equation. Now let's see this program. C program to perform arithmetic operations using which we know what are the arithmetic operations: plus, minus, star, division and modulo. So here the input variables are an operator and two numbers. So let the operator is plus, whereas the numbers are 10, 20. So what is the result of 10 plus, what is the result of 10 plus 20? 30. So we have to display 30 on the monitor. Okay. So let the operator is star, whereas the numbers are 10, 20. So we have to display 300. What is the result of 10 into 20? 200. So 200 on the monitor. So let us develop this program. So here the first statement is hash include stdio.h. Why? Because in this program we are using printf and scanf functions. Those two functions are available in stdio.h. Next, execution of a program starts from the main function. So first we need to read an operator. So for that we need to have a character variable. So let name of the character variable is ch. Next we need to have two numbers which is of type, let it be some integer values. So int a comma b. So first read the operator. Before that display the message. So printf enter an operator. So here operator is of type character. For character the format specified is %c. So scanf %c comma ampersand. The name of the variable is ch. Okay. Next we have to read two numbers. Before that display some message. Printf enter two numbers. Here the numbers are of the type integer. For integer the format specified is %d. So scanf %d comma. So what is the first variable? Ampersand a comma ampersand b. Okay. Next write the switch. Okay. So switch off. So what is the variable here? Ch is the variable. So switch off ch. Here the possible options are plus, minus, star, division and modulo. So let us write the case for plus. So case, here plus is an operator, plus is a character constant. So we have to enclose within single quotation. So which operation we are performing here? Addition operation. So printf display the result. Addition is equal to %d comma a plus b. Next it ends with break. So next statement case. So write for minus. So case space within the single quotation minus ends with colon. Next to printf. So what is the result here? Subtraction is equal to %d comma. So subtraction means a minus b. Next it ends with break. So next one case space, which operation? Division operation. So case space division, just within the single quotation division it ends with colon. So printf. So which operation we are performing? Multiplication. So multiplication is equal to %d comma. So for multiplication we need to perform a star b. So multiplication means a star b. So next it ends with break. So plus is over, minus is over, division is over. Here it is, let it be some division operator. So star. Next one division. So case division ends with colon. Next to printf. So here we are performing division operation. So division is equal to %d comma. So division means a by b. Next to break. So what is the last choice? Modulo. So case within the single quotation modulo ends with colon. So printf modulo is equal to %d comma a modulo b. Okay. Next to break. Okay. Default colon. So in default just display the message as some wrong operator or some wrong choice. For default there is no need of any break statement. Next, close the switch. Next, close the main function. Now let's see how this program will be executed. We know that execution starts from the main function. Enter an operator. So let the operator is star. So ch contains star. Enter two numbers. So let the numbers are 5, 2. So switch off. What is the operator that we have entered? Star. So control directly goes to the star. Whereas if you take LC ladder, then first star will be compared with plus. Condition is false. Next star will be compared with minus. Condition is false. Next star will be compared with star. So the body will be executed. That means in LC ladder, the false conditions will also be checked. Whereas in switch, only true condition will be checked and true body will be executed. Okay. So print of multiplication is equal to percentage d comma a star b. So what is a star b? 5 into 10. So multiplication is equal to 10 will be printed. Next break will be executed. So whenever break is executed, then the control comes out from the switch. So there is no statement after the switch, so that the program gets terminated. Okay. Whereas if you don't use break, then what will happen is after printing multiplication, the control directly goes to the division. So print of division is equal to percentage d comma a by b. So what is the result of 5 by 2? 2. So that message will also be printed on the monitor. So that is the problem with switch. If you don't use break, then the remaining cases will also be executed. But we have to execute only star body only. So that's why every case should end with break. Let me have entered some dollar operator. So what will happen now? So now ch contains dollar. Let the numbers are 5, 2. So switch off dollar. So dollar doesn't matches with any case value. So default gets executed. So what is the body in default? Print of wrong choice will be printed on the monitor. So let us assume that we have written wrong choice before case plus. So default print of wrong choice. Default colon print of wrong choice. We can use as default anywhere in the program. Okay. So now what is the symbol? Dollar. So dollar doesn't matches with any case value. So what will happen? This default body will be executed. Wrong choice will be printed. And after that we didn't use any break statement. So what will happen? The next case will also get executed. So case plus body will also executed. So addition is equal to, what is the result? 5 plus 2. 7 will be printed on the monitor. And after that we have break. So control comes out from the switch. So that means here the point is, here in switch default is optional. And we can place default anywhere in the program. If you place default as the last case, then there is no need of any break at the end of default. Whereas if you place default at the beginning position or at the starting position or any position other than the last position, then it should ends with break. If you don't use break, then what will happen? The remaining cases will also get executed. So in this way we can perform the arithmetic operations using the switch. Now let's see this program. C program to accept a number from 1 to 7 and print appropriate day of the week. So we have to read a number. That number should be from 1 to 7. If we enter 1, then we have to display day as some Monday. If we enter 2, Tuesday. If we enter 5, some Friday. If we enter 7, then Sunday. So likewise we have to display the output. Now let us write the program. So here the first statement is hash include stdio.h. Why? Because we are using printf and scanf functions. Those two are available in stdio. Next, execution of a program starts from main function. Next, we have to read an integer value. So int, let name of the variable is day. So first read the variable. Before that, display the message. So printf enter a day. Next is scanf. So here day is of type integer. So here the format specified is percentage d. So scanf percentage d comma %d. Next, write the switch. So switch off. So here day is the expression. So switch off day. So if it is 1, then we have to display the message as Monday. So case space 1 colon. Here 1 is nothing but an integer constant. So we can write 1 directly. Whereas if it is a character constant, then we should enclose within single quotation. Okay. Case 1 printf. So what is the message which we have to display? Monday. And it ends with break. Next to case space 2 ends with colon. Printf. So if it is 2, then we have to display the message as Tuesday. Next it ends with break. So likewise, if it is 3, then display the message as Wednesday, and it ends with break. So likewise, so on. So what is the last case? Case 7. So if it is 7, then what is the message which we have to display? Sunday. So printf Sunday ends with break. So we can also write a default case. So default means if we enter other than an integer number, then default gets executed. So wrong choice. Next to close the switch. Next to close the main function. Okay. Now let's see whether our program is successfully executed or not. So we know that execution of a program starts from main function. So printf enter a day. So let the day value is 5. So now day contains 5. Switch off day. So control directly goes to case 5. So what is case 5? Friday. So Friday message will be printed, and after that we have break statement. So the control comes out from the switch. So let me enter some 3 here. So printf enter a day, scanf %d comma %day. So let the day is 3. So switch off 3. So control goes to case 3. So printf Wednesday. So that Wednesday message will be printed on the monitor. And after that we have break. So whenever break is executed, then the control comes out from the switch. Okay. Let us assume that we entered a star. Okay. So switch off star, or let us assume that I entered some 15. So 15 doesn't matches with 1, 2, 3, 4, 5, 6, 7. Okay. So if we have only from 1 to 7, then the corresponding cases will be matched. If we entered other than from 1 to 7, then the default will gets executed. Okay. So let us assume that we entered 15. So 15 doesn't matches with 1, 2, 3, 4, 5, 6, 7. So what will happen now? Default case will gets executed. So what is the default case here? Wrong choice. Wrong choice message will be printed on the monitor. Okay. Here there is no need to use break statement after the default. Why? Because we placed default as the last case only. Let us assume that if you want to place default as other than the last case, let us assume that we place a default as the first case. Then we should use break after the default. If you don't use break after the default, then what will happen? The remaining cases will also be executed. Okay. So that depends upon the location where we use default. Okay. So if you use as the last case, then there is no need of break. Why? Because after executing the default, automatically the control comes out from the switch. So if you want to use other than the last case, then it is better to use break at the end of default. Otherwise, the remaining cases will also get executed. So this is about accepting a number from 1 to 7 and printing appropriate day of the week. Now let's see this program. C program to convert a 2-digit number into words using switch statement. So what is the minimum 2-digit number? 10. Maximum 2-digit number 99. So if we entered 10, then the output should be 1, 0. So let us assume that we entered some 54. Then the output should be 5, 4. If we enter 99, then the output should be 9 and 9. 9 is the output. Okay. Likewise, we have to display the output. So let we entered 54. So what is the output here? We have to display the output as 5, 4. So from 54, we need to get 5. So how to get 5 from the 54? 54 by 10 is nothing but 5 only. 10, 54. 10 5s are 50. 54 minus 50 is equal to 1. So 54 by 10 is nothing but 5. Division will always gives quotient as the result. Whereas 54 by modulo 10 means modulo will always gives remainder as the result. So here what is the remainder? 4 is the remainder. So 54 modulo 10 will gives 4 as the result. Okay. So if you take 23, then we have to display the message as 2, 3. 2, 3. So what is the first expression? 23 by 10. So 23 by 10 will gives 2. So 2 will be printed. Next we have to display 3. So how to get 3 from the 23? 23 modulo 10. So 23 modulo 10 means 3 only. Okay. So 10, 23. So 10 2s are 20. So 23 minus 20 means 3. So 2 means division. That is nothing but quotient value. 3 means remainder value. Okay. So let us write the program now. So we know that the first statement is stdio.h. So hash include stdio.h, because we are using printf and scanf functions. Those two are available in stdio. Next, execution of a program starts from main function. Next, int. So we have to accept a 2-digit number. So let the input is digit. So int digit. So first read the number. So printf enter a digit. Printf enter a 2-digit number. A 2-digit number. Next, scanf %d comma ampersand digit. Ampersand digit. Okay. So next, what is the first one? Let the number is 23. So we have to display the message as 2, 3. So how to get it 2? By performing division operation. So switch off digit by 10. So digit by 10 will gives the first digit. So it will gives 2. So here what is the first case? Here what is the minimum 2-digit number? 10 is the minimum 2-digit number. So we should not get 0 here. There is no possibility to print 0 here. Okay. So here the first case should be from 1 only. So if it is 1, then print 1. If it is 2, then print 2. If it is 8, print 8. If it is 9, then print 9. So we can have 10 digits from 0 to 9. But if we perform division operation with 10 on a 2-digit number, we should not get 0. Why? Because the minimum number is, what is the minimum 2-digit number? 10. Next 11, 12, 20, 30, 40. So we should not get 0 here. Okay. So what is the first case? 1. So case 1 colon. So printf. So display 1. So printf display 1 in uppercase letters. Then use break statement. Okay. So next one, case 2 colon. Printf 2 in uppercase letters, break. So likewise, so on. What is the last case? We can have 10 digits from 0 to 9, but there is no need to use 0. So what is case 9? If it is 9, then display 9. So 9, printf 9, break. So the first switch is over. Next, from 23, we have to get 3. So how to get 3 from 23? By performing modulo with 10. So switch off digit modulo 10. Digit modulo 10. If you take 10, then after 1 we have to display 0. If you take 20, after 2 we have to display 0. So here we need to display 0 also. So here the first case is case 0. Next from 1 to 9. So here we have to use all the combinations from 0 to 9. So case 0 colon. So if it is 0, then we have to display the message printf 0. Next to break. Next, if it is 1, then display the message as printf within the double quotations 1. Next, use break. So likewise, so on. What is the last case? Case 9. Printf 9 in uppercase letters. Next, use break statement. Okay. Next, to close this switch. Next, to close the main function. Okay. So let's see whether our logic is correct or not. So let us assume that the number is 29. So printf enter a 2-digit number, scanf %d comma ampersand digit. No digit contains 29. So switch off 29 by 10. So what is 29 by 10? So 10, 29. So 10 2s are 20. So 29 minus 10 means 2. So division will always give quotient. So this expression will give 2 as the result. So switch off 2. So control goes to case 2. So what is case 2? Printf 2. So 2 message will be printed. Here after 1, 2, 3, it is better to use one blank space, so that after displaying 1 or 2 or 3 or 4, a space will be printed. Otherwise those two words will be printed without any blank space. Okay, so first 2 will be printed, after that a blank space will be printed. So this is executed. So next the control goes to this switch. 29 modulo 10. What is the result of 29 modulo 10? Modulo will always gives reminder. So what is the reminder here? 9. So control goes to case 9. What is the body here? Printf 9. So 9 message will be printed. Here after displaying the digit, there is no need of any blank space. Why? Because after 9 we are not displaying anything. Next break. So the control comes out from this switch. Okay. Let's see one more example. Let the number is some 58. So first 58 by 10. So 58 by 10 means what? 58 by 10. So 10, 10, 58. So 10 5s are 50. So 58 minus 10 means 8. So what is the result of 58 by 10? Division will always gives quotient. That means 5 is the result. So what is case 5? Case 5 means printf 5. So this 5 will be printed on the monitor. After that one blank space will be printed. Okay. Next control goes to this switch. Switch off 58 modulo 10. So what is the result of 58 modulo 10? Modulo will always gives reminder as the result. So what is the result here? 8. So control goes to case 8. So what is the result here? 8. So 8 will be printed on the monitor. Okay. After that we have break, so that the control comes out from the switch. Here every case should ends with break. If you don't use break, then the remaining cases will also gets executed. So in this way we can convert a 2-digit number into words. So likewise we can convert a 3-digit number or 4-digit number or 5-digit number into words. Now let's see this program. C program to print factors of a given number. Let the number is 10. What are the factors for 10? The factors for 10 are 1, 2, 5, 10. So these are nothing but the factors for 10. Let us take the number 6. The factors for 6 are 1, 2, 3, 6. So these are the factors for 6. So if the number is 10, then the output is 1, 2, 5, 10. Whereas if the number is 6, then the output is 1, 2, 3, 6. Now let's see how we are going to find out the factors for a number. So for any number, the factors are from 1 to that number. So if you take 6, then the factors are from 1 to 6. So 1 to 6. If you take 10, then the factors are from 1 to 10. Okay. Now let's see how can we say that it is a factor. If you perform modulo operation with the corresponding number, if the result is 0, then we can say that it is a factor. So here we have to perform operations like 6 modulo 1, 6 modulo 2. Why? Because 6 is nothing but our number. We have to find out factors for 6. 6 modulo 3, 6 modulo 4, 6 modulo 5, 6 modulo 6. Suppose if the remainder value is 0, we know that modulo will always gives remainder. Suppose if the remainder value is 0, then we can say that it is a factor to the corresponding number. Okay. Let us calculate the first one. 6 modulo 1. So 1, 6. 1, 6 are 6. Modulo will always gives remainder. So 0 is the result. Here 0 is the result. So we can say that 1 is a factor. Okay. Why? Because by performing modulo operation, we are getting result as 0. So we can say that 1 is a factor to 6. So 1 is a factor. Next 6 modulo 2. So 2, 6. So 2 3s are 6. 6 minus 6, 0. So here also we are getting result 0. So we can say that 2 is also a factor. Next 6 modulo 3. So 3, 6. 3 2s are 6. 6 minus 6, 0. Here also we are getting remainder as 0. So we can say that 3 is also a factor. Next 6 modulo 4. So 4, 6. 4 1s are 4. 6 minus 4 means 2. Here we are getting remainder as 2. Modulo result is 2. So we can say that 4 is not a factor. Next 6 modulo 5. So 5, 6. 5 ones are 5. 6 minus 5 means 1. So here also the result is 1. So we can say that 5 is not a factor. Why? Because we are getting the result as 1. If we got the result as 0, then only it is a factor. So 5 is not a factor. Next 6 modulo 6. 6, 6. 6 ones are 6. Result is 0. Remainder is 0. So we can say that 6 is a factor. So 1, 2, 3, 6 are the factors for 6. So we have to write the program now. Okay. Let us start the program. The first statement is hash include stdio.h. Why? Because we are using printf, scanf functions. Printf and scanf are available in stdio.h. Next, main function. Execution of the program starts from main function. Here we need two variables, I and n. I for repetition from 1 to the corresponding number. Next we need some number. For that purpose we require n. So int I comma n. So next statement, printf. Before reading the data, it is better to display the message printf enter n, so that this message will be printed on the monitor. Next scanf percentage d comma. Here n is of type integer. For integer the format specified is percentage d. D specifies decimal number, integer number. Okay. So with this reading is over. Next we have to determine the factors. So what is the minimum factor for any number? 1. What is the maximum factor for any number? That number. So here the initial value of the for loop is 1. Why? Because we have to start from 1. 1 is the minimum factor, not 0. So 0 is not a factor. So we have to start from 1 only. Okay. Next, after that, what is the maximum factor? 6. That means we have to compare 6 also. So if you want to compare 6 also, then it is better to use is equal to operator. If you use less than operator, that means if you don't use is equal to, if you use only less than operator, then what will happen is this 6 won't compare. So here the condition is I is less than or equal to n, less than or equal to n. Okay. Next I plus plus. After 1 we have to check whether 2 is factor. After 2 we have to check whether 3 is factor. So I plus plus. Next, what is the body here? If when we can say that it is a factor. If 6 modulo 1 is 0, then we can say that 1 is a factor. If 6 modulo 2 is 0, then we can say that 2 is a factor. What is 6? 6 means n. What is 1, 2, 3? 1, 2, 3 are nothing but the values of I. So we can say that if n modulo I, here we are checking the conditions. So we have to use equality operator. Double is equal to 0. Then we can say that I is a factor. So printf slash n percentage d is a factor. Percentage d is a factor. So what is percentage d? Percentage d means I. Okay. Next to close if. Next to close for. Next to close main function. Now let's check whether our logic is correct or not. Let the number is 6. So for I is equal to 1. So I value is 1. 1 is less than or equal to 6. So 1 is less than or equal to 6. Condition is true. 1 is less than or equal to 6. Condition is true. So the body will be executed. So this is the body. If n modulo I, if 6 modulo 1, double is equal to 0. What is 6 modulo 1? 0. Condition is true. So printf slash n percentage d is a factor. What is percentage d? I value. So what is I value? 1. So here the output is 1 is a factor. So this message will be printed on the monitor. Okay. So the body of the for is executed. Next I plus plus. Now I becomes 2. So one more time condition will be evaluated. 2 is less than or equal to 6. Condition is true. So body will be executed. If 6 modulo 2 double is equal to 0. What is the result of 6 modulo 2? 0. 0 double is equal to 0. Here we have to use just double is equal to. By using double is equal to, we can check whether two numbers are equal or not. Don't use is equal to operator. Is equal to use assignment operator. whereas double is equal to is equality, relational operator. Okay, so 0 double is equal to 0, condition is true. So printf percentage d is a factor comma I. So what is I value now? 2. So 2 is a factor. So this message is also printed on the monitor. So the body of the for loop execution is over. Next I plus plus. Now I becomes 3. So one more time condition will be checked. 3 is less than or equal to 6. Condition is true. So if n modulo I double is equal to 0, 6 modulo 3, what is the result? 0. 0 double is equal to 0. Condition is true. So 3 is a factor. So this message is also printed on the monitor. Okay. Next I plus plus. I becomes 4. 4 is less than or equal to 6. Condition is true. If 6 modulo 4 double is equal to 0, what is 6 modulo 4? 2. 2 double is equal to 0. 2 double is equal to 0. Condition is false. So this body won't execute. I plus plus. Now I becomes 5. 5 is less than or equal to 6. Condition is true. So body will be executed. 6 modulo 5. What is the result? 1. 1 double is equal to 0. False. So this body won't execute. Next I become 6. 6 is less than or equal to 6. Condition is true. 6 modulo 6. What is the result? 0. 0 double is equal to 0. Condition is true. So what is I now? 6. So 6 is a factor. This message will be printed. Next I plus plus. I becomes 7. 7 is less than or equal to 6. Condition is false. So the control comes out from the for loop. So in this way we can print the factors of a given number. Now let's see this program. C program to check whether given number is prime or not. Let's see what is a prime number. A number is called as prime number if it is divisible by 1 and itself. So prime number means it is divisible by 1 and itself. 1 and itself. So that means any prime number should contains two factors. The first factor is 1 and the second factor is itself. Itself means the corresponding number. If you take 1, 1 is not a prime number. Why? Because 1 has only one factor, that is 1 only. Okay, but a prime number should contain how many factors? 2 factors. Okay, if you take 2, 2 is a prime number. Why? Because 2 has 2 factors, 1 and 2. If you take 3, 3 is also prime number. Why? Because 3 has 2 factors. The first factor is 1 and the second factor is the number itself, that is nothing but 3. If you take 4, what are the factors for 4? 1, 2, 4. But a prime number should contain only 2 factors, 1 and itself. But this 4 contains how many factors? 3 factors. So we can say that 4 is not a factor, 4 is not a prime number. If you take 5, 5 is a prime number. Why? Because 5 has only 2 factors, that is 1 and itself. Okay, so that is about what is a prime number. So what is a prime number? It is divisible by 1 and itself. Okay, let's see how to calculate mathematically. If you take 5, then first we have to calculate the factors for 5. The minimum factor for any number is 1, whereas the maximum factor for any number is that number. So we have to calculate the factors from 1 to that number. So 1, 2, 3, 4, 5. Next we have to calculate whether these numbers are factors to 5 or not. So factor means if it is divisible by that number, then we can say that it is a factor. Here divisible means if you perform the modulo operation, then if we get the result as 0, then we can say that it is a factor. So here we have to perform calculations like 5 modulo 1, 5 modulo 2, 5 modulo 3, 5 modulo 4, 5 modulo 5. So if you got result as 0, then we can say that it is a factor. Okay, let us calculate the first one. So what is the first one? 5 modulo 5. So 1, 5. So 1 5s are 5. So 5 minus 5 means 0. So we can say that 1 is a factor. Why? Because what is the remainder? We got 0. If we got remainder as 0, then we can say that it is a factor. So 1 is a factor to 5. Next 5 modulo 2. So what is the result? So 2, 5. So 2 2s are 4. So 5 minus 4 means 1. Okay. 5 minus 4 means 1. So we can say that here 2 is not a factor. Why? Because what is the remainder that we got here? 1. So we can say that 2 is not a factor. Next 5 modulo 3. So 3, 5. 3 1s are 3. 5 minus 3 means 2. So here what is the remainder result? 2. So we can say that 3 is not a factor. Why? Because if the remainder is 0, then only we can say that it is a factor. Next 5 modulo 4. So 4, 5. So 4 1s are 4. So 5 minus 4, 1. So here also what is the remainder? 1 is the remainder. Okay. So we can say that it is not a factor. Next 5 modulo 5. 5 modulo 5. 5 1s are 5. 5 1s are 5. So what is the result? 0. So we can say that 5 is a factor. Okay. So how many factors we got? 2 factors. So we can say that it is a prime number. Why? Because prime number contains 2 factors. That is 1 and itself. Let us take one more number. Let us take 8. Let us take 8. So if we take 8, then we have to calculate the factors from 1 to 8. So we have to perform the operations 8 modulo 1, 8 modulo 2, 8 modulo 3, 8 modulo 4, 8 modulo 5, 8 modulo 6, 8 modulo 7 and 8 modulo 8. 8 modulo 1. What is the result? 0. Okay. 8 modulo 6. Then after that 8 modulo 7. Next 8 modulo 8. Okay. 8 modulo 1. What is the result? 0. So we can say that 1 is a factor. 8 modulo 2. Result is 0. So we can say that 2 is a factor. 8 modulo 3. Result is 2. So it is not a factor. 8 modulo 4. 0. It is a factor. 8 modulo 5. Not equals to 0. It is not a factor. 8 modulo 6. Not equals to 0. It is not a factor. 8 modulo 7. Not equals to 0. It is not a factor. 8 modulo 8. It is a factor. So how many factors are there? 1, 2, 3, 4. So totally we got 4 factors. But for a prime number we should have only 2 factors. 1 and itself. So we can say that 8 is not a prime number. Okay. So this is in this way mathematically we can calculate. And now we have to implement all these 4 with the help of a program. So let us write the program now. So the first statement is hash include stdio.h. Why? Because in this program we are using printf and scanf functions. These two are available in standard input output library. Okay. Next, every C program contains main function. Next, the variables which are needed here are for repetition from 1 to n. We need to have a variable called I. Next, n for input number. Next, how many factors a prime number should contain? 2 factors. So for that purpose, let us take a variable called count. The initial value of the count is 0. If it is a factor, then increment count value. So whenever this for loop condition is false, then check whether count is 2 or not. If count is 2, then we can say that it is a prime number. If count is not equals to 2, then we can say that it is not a prime number. Why? Because prime number should contain how many factors? 2 factors. Okay. So the initial value of the count is 0. Why? Because by adding 0, the result won't changes. Okay. Count is equal to 0. Next, what is the input variable n? Before that, display some message. So printf enter n. Next, read n value. Scanf. Here n is of type integer. For integer, the format specified is %d. So scanf %d comma m%n. Okay. So n is readed. Next, we have to find out the factors. So in order to find out the factors, here what is the minimum factor? 1 is the minimum factor, and the maximum factor is nothing but the number. So here the for loop is for, we have to start from 1 for I is equal to 1. Next, I less than n or less than or equal to n. Which condition we have to write? If we write less than, then 5 won't be checked. Up to 4 only checked. Next, 5 less than 5, condition is false. So this comparison won't done. So that's why if you want to make this comparison also, then we have to write the condition as I less than or equal to n. Why? Because we have to perform the operation 5 modulo 5 also. So I less than or equal to n. Next, after 1 we have to check for 2. After 2 we have to check for 3. So every time we have to implement I value. So I plus plus. Next, which operation we have to perform? 5 modulo 1, 5 modulo 2, 5 modulo 3. So 5 means n. Next, 1, 2, 3 are nothing but the values of I. So here we have to use some if n modulo 1, 2, 3 are nothing but the values of I. If n modulo I double is equal to 0, then increment count value. So count is equal to count plus 1. Count is equal to count plus 1. Next, close the for loop. So whenever the condition is false, then check to count value. Then check to count value. If count double is equal to 2, because prime number contains how many factors? 2 factors. If count double is equal to 2, then printf percentage d is a prime number. Percentage d is prime number. So what is percentage d? Percentage d is nothing but the value of n. Else printf percentage d is not a prime number. Printf percentage d is not a prime number. Okay, not a prime number. So what is percentage d? N. Next, close the main function. Now let's check whether our logic is correct or not. So printf enter n, scan of percentage d comma ampersand n. Let n value is 5. Next, for I is equal to 1, 1 is less than or equal to 5. Condition is true. So body will be executed. If n modulo I double is equal to 0, n value 5, I value 1, 5 modulo 1. So what is the result of 5 modulo 1? 0. So 0 double is equal to 0. Condition is true. So this body will be executed. The initial value of the count is 0. Now count value will becomes 0 plus 1 means 1. Okay. Next, body execution is over. Next, I plus plus. Now I becomes, previously I value is 1. Now I becomes 2. So one more time condition will be evaluated. 2 is less than or equal to 5. Condition is true. So body will be executed. N value 5, I value 2. So 5 modulo 2 result is 1. So 1 double is equal to 0. Condition is false. So this body won't execute. Next, I plus plus. I becomes 3. 3 is less than or equal to 5. Condition is true. So this body will be executed. Next, this condition. 5 modulo 3. What is the result of 5 modulo 3? 2. 2 double is equal to 0. 2 double is equal to 0. Condition is false. So this body won't execute. Next, I plus plus. I becomes 4. 4 is less than or equal to 5. Condition is true. Okay. 4 is less than or equal to 5. Condition is true. So what will happen now? This body will be executed. If n modulo I double is equal to 0, 5 modulo 4, what is the result? 1. 1 double is equal to 0. Condition is false. So this body won't execute. I plus plus. I becomes 5. 5 less than or equal to 5. Condition is true. Next, 5 modulo 5. 5 modulo 5. What is the result of 5 modulo 5? 0. 0 double is equal to 0. Condition is true. So 5 modulo 5. So 5, 5. 5 ones are 5. 0. 0 double is equal to 0. Condition is true. Count is equal to count plus 1. The previous value of count is 1. 1 plus 1 means 2. I plus plus. Now I becomes 6. 6 is less than or equal to 5. Condition is false. So the control comes out from the for loop. What is the count value now? 2. 2 double is equal to 2. Condition is true. So percentage d is a prime number. What is percentage d? N. What is n value? 5. So 5 is a prime number will be printed on the monitor. Okay. Let's take one more input. Let the value of n is 6. Let the value of n is 6. So first 6 modulo 1 will be calculated. Result is 0. So count becomes 1. Next 6 modulo 2 is calculated. Result is 0. So count becomes 2. 6 modulo 3 is calculated. Result is 0. So count becomes 3. 6 modulo 4. Result is not equals to 0. 6 modulo 5. Result is not equals to 0. Next to 6 modulo 6. Condition is true. So count becomes 4. So what is count value? 4. 4 double is equal to 2. Condition is false. So S block will be executed. 6 is not a prime number will be printed. So in this way we can check whether a number is prime number or not. Now let's see this program. C program to print prime numbers within the given range. So here we need to specify minimum value as well as maximum value. So in between minimum value and maximum value, we need to display the prime numbers. Let the minimum value is 3, maximum value is 10. So what are the prime numbers between 3 and 10? So 3 is a prime number, next 5 is a prime number, 7 is a prime number. So likewise the output will be printed. First let's see what is a prime number. Prime number means it has only two factors, 1 and itself. If you take 1, 1 is not a prime number. Why? Because 1 has only one factor, that is 1 only. But a prime number should contain two factors. If you take 2, 2 is a prime number because it has two factors, 1 and itself, that is nothing but 2. If you take 3, 3 is also a prime number. Why? Because it has only two factors, that is 1 and 3. If you take 4, 4 is not a prime number because the factors for 4 are 1, 2, 4. 4 has 3 factors. So we can say that it is a prime number if it has only two factors, but 4 has 3 factors. So we can say that 4 is not a prime number. So like that. So 3 has only two factors, that is 1 and itself. So 3 is a prime number. 4 has 3 factors, 1, 2 and 4. So we can say that 4 is not a prime number. 5 has only two factors, 1 and 5. Next to 6 has 1, 2, 3, 6. So 6 has 4 factors. So we can say that 6 is not a prime number. 7, it has only two factors, 1 and 7. So it is a prime number. 8, it has more than two factors. So it is not a prime number. 9, it has 3 factors, 1, 3 and 9. It is not a prime. 10, it has more than two factors, 1, 2, 5. And so we can say that 10 is also not a prime number. Okay. So for that we have to write the program. Let us observe the logic while writing the program. First let us start the program. While writing the program we will see the logic. So hash include stdio.h. So next, every C program contains main function. So main function. And next the variables which are needed are, first variable is min, so minimum value. Second variable is max, maximum value. Next variable is I. Here we need to have two for loops. I for outermost for loop, j for innermost for loop. Next we need to have a variable called count. If count value is 2, then we can say that it is a prime number. Okay. Next, here what are the input variables? Minimum and maximum are the input variables. So printf enter min and max values. Min and max values. So here minimum value is nothing but minimum and maximum are some integer numbers. For integers the format specified is %d. So %d, comma ampersand. The first variable is min, the second variable is max. So ampersand min, comma ampersand max. Okay. First let us write the outermost for loop. Here the outermost for loop is for the number repetition. First we have to check whether 3 is a prime number or not. Next 4, next 5, next 6, next 7, next 8, next 9, next 10, like that. So for that number repetition we have to use the outermost for loop. So for in outermost for loop, let us use a variable called I is equal to. So the initial value of the I is 3. What is 3? 3 means minimum value. So for I is equal to min. Next 4, 5, 6, 7, 8, 9. We have to check whether 10 is also prime number or not. So the condition should be I less than or equal to max. I less than or equal to max. Suppose if you use only less than, then 10 won't be checked. Okay. Why? Because the next 9 less than 10 condition is true. So 9 will be checked whether it is prime number or not. Next to 10 less than 10 condition is false. So 10 won't execute it. Okay. So that's why the condition should be less than or equal to. Next after 3 we have to check for 4. After 4 we have to check for 5. So every time we have to perform implementation I plus plus. Okay. Next we have to check whether this I is prime number or not. So for that purpose we need to perform the initialization here. The initial value of the count is 0. Any prime number should contain two factors, 1 and itself. So if count is 2, then we can say that it is a prime number. Suppose if count is not equals to 2, then we can say that it is not a prime number. Okay. Here, what is the initial value of I? The initial value of I is 3. So we have to check whether 3 is a prime number or not. So for that purpose, we have to determine the factors for the 3. We have to determine the factors for the 3. What is the minimum factor for any number? The minimum factor for any number is 1, whereas the maximum factor is that number. So we have to start from 1 and continues up to 3. So we have to check whether 1 is a factor or not, 2 is a factor or not, 3 is a factor or not. Okay. If it is a factor, then increment count value. Whenever the condition is false, then check count is 2 or not. If count is 2, then we can say that I is prime number. If count is not equals to 2, then it is not a prime number. Okay. So when we can say that 1 is a factor. Okay. If we perform the operation 3 modulo 1, if we get the result as 0, then we can say that 1 is a 0. 1 is a factor. Next we have to perform 3 modulo 2. Next we have to perform 3 modulo 3. So what is the result of 3 modulo 1? 1, 3. So 1 3s are 3. 0. So 3 modulo 1 means 0. So we can say that 1 is a factor. Next 3 modulo 2. So 2 3. 2 1s are 2. 3 minus 2 means 1. Here remainder is not equals to 0. So we can say that 2 is not a factor. Next 3 modulo 3. So 3 1s are 3. So 3 minus 3 means 0. So here the remainder is 0. So we can say that 3 is a 0. So how many factors does 3 has? 2 factors. 1 and itself 3. So we can say that it is a prime number. So for that we have to write the logic here. I is over. In order to check whether it is prime number or not, let us use one more for loop, innermost for loop. I is already over. So the next variable is j. J is equal to. So here we are using this innermost for loop in order to check whether this number is prime number or not. Okay. So here the initial value of the j is 1, whereas the final value of the j is 3. So what is 3? This 3 is available in I. So the condition should be j is equal to 1. This is the initialization. Next j is less than or equal to I. So next first 1 less than or equal to 3, true. 2 less than or equal to 3, true. 3 less than or equal to 3, true. Like that. Next after 1 we have to check for 2. After that we have to check for 3. So every time we have to implement j++. Next we have to check whether j is a factor or not. In order to determine whether it is a factor or not, this is the logic. 3 modulo 1, 3 modulo 2, 3 modulo 3. So what is 3? 3 is available in I. So if I modulo, next 1, 2, 3. 1, 2, 3 are available in j. So if I modulo j is 0, then we can say that it is a factor. If it is a factor, then we have to increment count value. So count ++. Next, whenever this condition is false, whenever this innermost for loop condition is false, then we have to check the value of count. If count double equal to 2, that means if the number has 2 factors, then we can say that it is a prime number. I is a prime number. So display I value. Display I value. So printf /n %d comma display I value comma I. Next to close this outermost for loop. Okay. Next to close this main function. So this is the logic here. Now let's check whether our logic is correct or not. So here what is I value? The minimum value is 3, maximum value is 5. Next for I is equal to 3, 3 is less than or equal to, what is max value? 10. So 3 is less than or equal to 10, condition is true. So body will be executed. So count is equal to 0. For every number, we have to check whether it is prime number or not. So for every number, the count value should be 0 only. So for 3 it is 0, for 4 it is 0, for 5 it is 0. Okay, likewise. If you don't perform initialization here, that means if you perform initialization here, then what will happen is 3 is a prime number, that message that number will be printed. Next we have to check for 4, but what is the value of the count? Already it is calculated for 3. The value of the count is 2. Why? Because 3 has 2 factors. So the implementation should start from 2 only, but it has to start from 0 only. So that's why the value of count is 0. Okay. Next for j is equal to 1. So what is the value of count? The value of count is 0. Okay. J is equal to 1. 1 is less than or equal to 3. Condition is true. If I modulo j double is equal to 0, 3 modulo 1, result is 0. So condition is true. Count ++. So count becomes 1. Next j ++. J becomes 2. 2 is less than or equal to 3. Condition is true. I modulo j. 3 modulo 2. Result is 1. 1 double is equal to 0. Condition is false. So this body won't execute. Next j plus plus. J becomes 3. 3 is less than or equal to 3. 3 is less than or equal to 3. Condition is true. I modulo j. 3 modulo 3. Result is 0. 0 double is equal to 0. Condition true. Count to plus plus. Now count becomes 2. J plus plus. Now j becomes 4. 4 less than or equal to 3. Condition is false. So the control comes out from the j loop. If count double is equal to 2, what is count value? 2. So 2 double is equal to 2. Condition is true. So what will happen? 3. This 3 will be printed on the monitor. Next, I plus plus. Now I becomes 4. So now we have to check whether 4 is prime number or not. So count is equal to 0. So the value of count is 0. Next, for j is equal to 1, j less than or equal to I. What is I value? 1. 1 less than or equal to 4. True. Next, I modulo j. I value 4, j value 1. 4 modulo 1. Result is 0. So count plus plus. Next, j plus plus 2. 4 modulo 2. Result is 0. So count plus plus 2. 4 modulo 3. Result is 1. So condition is false. So no need of implementation. Next, 4 modulo 4. Result is true. Count plus plus. Now count becomes 3. Next, value becomes 5. 5 less than or equal to 4. Condition is false. So the control comes out from the j loop. What is count value here? 3. 3 double is equal to 2. False. So 4 won't print. Next, I plus plus. Let's see this situation. Next, I plus plus. Now I becomes 5. 5 is less than or equal to 10. Condition is true. So count is equal to 0. Next, for j is equal to 1. 1 is less than or equal to I. 5. True. I modulo j. That means 5 modulo 1. Result is 0. Condition true. So 1. 5 modulo 2. Result is not equals to 0. So no need of implementation. 5 modulo 3. Not equals to 0. So no need of implementation. 5 modulo 4. Not equals to 0. No need of implementation. 5 modulo 5. Result is 0. So count plus plus 2. Next, it becomes 6. 6 is less than or equal to 5. False. What is the value in count? 2. 2 double is equal to 2. True. So 5 will be printed. So in this way, we can print prime numbers within the given range. Now let's see this program. C program to print prime factors of a given number. So we have to print only prime factors of a given number. Let's take the number is 6. So what are the factors for 6? 1, 2, 3, 6. So these are the factors for 6. But out of which, what are the prime numbers? 2 and 3 are the prime numbers. So the output should be 2, 3. 2, 3. If you take 10 as the input, what are the factors for 10? 1, 2. Next, what is the next factor? 1, 2, 5, 10. So 1, 2, 5, 10. So these 4 are the factors for 10. Out of 1, 2, 5, 10, 2 and 5 are the prime numbers. So we can say that the prime factors for 10 are 2 and 5. 2 and 5. Okay. Let's see what is the logic here. Let us take the number as some 6. So first we have to check whether it is a factor or not. So how to check whether it is a factor or not? If you take the number as 6, then first we have to find out the factors for the 6. The minimum factor for any number is 1, whereas the maximum factor is that number itself, 6. So we have to check whether 1 is factor or not, 2 is factor or not, 3 is factor or not, 4 is factor or not, 5 is factor or not, 6 is factor or not. So how to check whether it is factor or not? Simply by performing modulo operation. 6 modulo 1, 6 modulo 2. Next, what is the next number? 3, 4, 5. Next, 6. Suppose if the result is 0, then we can say that it is a factor. So what is the result of 6 modulo 1? So 1, 6. 1, 6 are 6. So 6 minus 6 means 0. So we got, after performing modulo operation, we got result here 0. So we can say that 1 is a factor. Okay. Next, 6 modulo, if it is a factor, then check whether it is prime number or not. So what is a prime number? Next we have to check whether this one is prime number or not. So what is a prime number? Any prime number should contain only 2 factors. that is 1 and itself. Okay. So, but how many factors does 1 contains? Only one factor. So we can say that 1 is not a prime number. So we should not display this output. Next, let us check whether 2 is factor or not. So what is 6 modulo 2? So 2, 6. So 2 3s are 6. So 6 minus 6 means 0. So we can say that 2 is a factor. Next we have, if it is a factor, then check whether it is prime number or not. So how to check whether it is prime number or not? So in order to know whether it is prime number or not, so once again, now here we have to calculate whether 2 is prime number or not. So for that purpose we have to perform 2 modulo 1, 2 modulo 2. Why? Because here 2 is the number. 2 is the number. So the minimum factor is 1. The maximum factor is that number. So 2 modulo 1, 2 modulo 2. The result of 2 modulo 1 is 1. The result of 2 modulo 2 is 1. So it has 2 factors. So we can say that 2 is a prime number. It is a prime factor. Okay. So likewise we have to perform the activities. Okay. 6 modulo 3. What is the result? 0. So we can say that 3 is a factor. Next we have to check whether 3 is prime number or not. Okay. So what is the minimum factor? 1 is the minimum factor. Whereas the maximum factor is that number itself. Okay. The result of 3 modulo 1 is 0. So next the result of 3 modulo 2 is 1. So it is not equals to 0. So 2 is not a factor. Whereas the result of 3 modulo 3 is 0. So 3 is also a factor. So we have 2 factors. So we can say that 3 is also a prime number. Next 6 modulo 4 not equals to 0. So 4, 6. 4 ones are 4. 6 minus 4, 2. So we can say that 4 is not a factor. Why? Because the remainder is not equals to 0. 6 modulo 5 not equals to 0. 6 modulo 6 equals to 0 only. But is 6 a prime number? No. Why? Because any prime number should contain only 2 factors, 1 and itself. But if you take 6, we have the factors for 6 as 1, 2, 3 and 6 also. So we have totally 4 factors. So we can say that 6 is not a prime number. Okay. So here the output is 2, 3 is the output. Okay. 2, 3 and 2, 3 is the output. So now let's write the program. So the first statement is hash include stdio.h. Why? Because we are using printf scanf. These two are available in stdio. Next, every C program contains main function. Next, the variables that are needed are a number n. Next, I for factors, j for prime number, and we need to have a variable called count. The initial value of the count is 0. If count equals to 2, then we can say that it is a prime number. Okay. So here the input variable is a number. So printf enter n. So first to display this message on the monitor. Next to read that number. So in order to perform the reading, we have to use scanf function. So scanf %d comma %n. Okay. So first we have to find out the factors for the given number. The minimum factor is 1, whereas the maximum factor is 6. So 6 is nothing but the value of n. So the for loop is for I is equal to 1, I less than or equal to n. Why? Because we have to calculate for 6 also. We need to check whether 6 is a factor or not. If it is a factor, we have to check whether it is prime number or not. So that's why we have to use is equal to also after less than. Next, after 1 we have to check for 2. After 2 we have to check for 3, like that. So I less. So first we have to check whether it is factor or not. Here 6 means n value. 1, 2, 3, 4, 5 are nothing but the value of I. So if n modulo I double is equal to 0, if n modulo I double is equal to 0, if it is double is equal to 0, then we can say that it is a factor. Let us take the number 3. 3 is a factor. 6 modulo 3. 6 modulo 3. Okay. The result is 0. So 3 is a factor. So next we have to check whether 3 is prime number or not. So for that purpose, here we have to perform the initialization. Count is equal to 0. Okay. Here we have to perform the initialization. If we perform initialization here, then what will happen is first we have to check for 1. After checking 1, count value should be 1. Next we have to check for 2. Next we have to check for 2. But the count value should be 0 only. If you don't perform initialization here, then the count value may become 1. Okay. Count is equal to 0. Next we have to check whether 3 is prime number or not. So for that purpose we have to start from 1 to that number. That number is available in I. So for j is equal to 1, j is less than or equal to, here we are checking whether I is prime number or not. So j is less than or equal to I, j plus plus. Okay. Next 3 modulo 1, 3 modulo 2, 3 modulo 3, like that. So 3 is nothing but the value of I. Next 1, 2, 3 are nothing but the values of j. So if I modulo j double is equal to 0, then increment count value. Okay. Next, whenever this condition is false, then check the value of the count. If count double is equal to 2, why? Because every prime number, any prime number should contain 2 factors. If count double is equal to 2, then we can say that I is a prime factor. So printf, display that value. Printf %d slash n comma display I value. Okay. Next close this if. Next close this for. Okay. So in this way we can write the program. Now let's check whether our logic is correct or not. Let us take the number as 6. So if you take the number as 6, then the output is 2, 3. Okay. So next, first 6 modulo 1 double is equal to 0, condition is true. So first 6 modulo 1 double is equal to 0, condition is true. So we have to check whether 1 is prime number or not. So count is equal to 0. Next, for j is equal to 1, 1 is less than or equal to, what is I value? 1. So 1 is less than or equal to 1, condition is true. Next 1 modulo 1 double is equal to 0, condition is true. Count plus plus. The initial value of the count is 0. Now count will become 1. J plus plus, j will become 2. 2 is less than or equal to, what is I value? 1. 2 is less than or equal to 1, condition is false. So the control comes out from the for loop. But what is the count value here? 1. 1 double is equal to 2, condition is false. So that means prime number should contain 2 factors, but 1 has only 1 factor. So this condition is false. So this body won't execute. Next, if it is executed, I plus plus. Next I becomes 2. 6 modulo 2. What is the result here? 0. So we can say that 2 is a factor. Next we have to check whether 2 is prime number or not. So count is equal to 0. So the initial value of the count is 0. Next, for j is equal to 1, 1 is less than or equal to 2. So 1 is less than or equal to 2, condition is true. Next, I modulo j. Here I value is 2, whereas j value is 1. 2 modulo 1, condition is true. 0 double is equal to 0, condition is true, count plus plus 1. Next, j becomes 2. 2 less than or equal to 2, condition is true. So I value 2, j value 2. 2 modulo 2, condition is true, count plus plus. Next, j becomes 3. 3 is less than or equal to 2, condition is false. So the control comes out from the for loop. So what is count value? 2. 2 double is equal to 2, condition is true. So you can say that 2 is a prime factor. Next, likewise for 3. 6 modulo 3, the result is 0. So condition is true. Next we have to check whether 3 is prime number or not. 3 is a prime number. Okay. So 3 is printed. Okay. Next to 4. 6 modulo 4. The result is 2. So we can say that 4 is not a factor. 6 modulo 4. The result is 2. 2 double is equal to 0. False. So this body won't execute. 6 modulo 5. The result is 1. 1 double is equal to 0. Condition is false. So this body won't execute. 6 modulo 6. Condition is true. But the factors for the 6 are 1, 2, 3, 6. So count value is 4. 4 double is equal to 2. Condition is false. Okay. So any prime number should contain only 2 factors, 1 and itself. Okay. So but here what is the count value? 4. 4 double is equal to 2. Condition is false. Next I plus plus. I becomes 7. 7 less than or equal to 6. Condition is false. So in this way we can print the prime factors for a given number. Now let's see this program. C program to print multiplication table of a given number. Let the number is 4. Then we have to print 4 multiplication table. Like the first row is 4 star 1 is equal to 4. Second row 4 star 2 is equal to 8. Next row 4 star 3 is equal to 12. So on. The last row is 4 star 10 is equal to 40. So likewise we have to display the output. So let's see how it can be done. The first statement is hash include stdio.h. Why? Because in this program we are using printf and scanf functions. Printf and scanf are available in stdio header file. Next, every C program contains main function. Next, let us declare the input variables int. So in this example, input variable is a number. So we require n, comma. Next, we need to have a variable in order to repeat from 1 to 10. So for that purpose, let us declare I. Okay, so these two are the input variables. Next, read a number. Before that, display the message printf enter a number or enter n. Next, scanf. Here n is integer value. For integer, the format specifier is %d, where d stands for decimal number, that is nothing but integer number, comma ampersand n. Okay. Next, in order to print the output, just use for loop. Here, what is the initial value of the for loop? 1. Next value 2. Next value 3. So final value 10. So here the initial value of I is 1. So for I is equal to 1, semicolon. What is the condition? We have to perform repetition till we get 10. So here the condition is I is less than or equal to 10. That means we have to print this row also, this 10 row also. Okay. Next, after 1, we have to perform multiplication for 2. Next 3, next 4. So every time we have to perform incrementation. So I plus plus. Okay. Next, in order to print the corresponding details, let us use printf function. Printf. Here each row is printed in a new line. So in order to print the cursor in the new line, use \n. Here 4 is nothing but an integer number. For integer, the format specifier is %d. So we can write as %d. Next, asterisk is nothing but a symbol. So display the symbol as it is. Next, this 1, 2, 3, 4, 5, all are nothing but integers. For integer, the format specifier is %d. So %d. Next, we have to display is equal to symbol. So is equal to. Next, 4, 8, 12, 16, 20, like that. So those are nothing but some integer numbers. So the format specifier is %d, comma. Here what is first %d? First %d means 4. 4 is nothing but the value of n, comma. Next, second %d is nothing but 1, 2, 3, 4. That is nothing but the value of I, comma. What is third %d? Third %d is nothing but the multiplication of 4 and 1, 4 and 2, 4 and 3, 4 and 4. So 4 is available in n, whereas those 1, 2, 3 are available in I. So third % is nothing but n star I. Next, to close the main function. Now let's check whether our logic is correct or not. We know that execution of the program starts from the main function. Printf enter a number. Let the number is 4. Next, for I is equal to 1, 1 is less than or equal to 10. Condition is true, so body will be executed. So what is here /n? So the cursor will places in new line. What is first %d? N. What is n? 4. So 4 will be printed. Next, asterisk symbol will be printed. Next, what is second %d? I value. I value is 1. So 1 is printed. Next, is equal to symbol will be printed. What is this last %d? N star I. N value is 4. I value is 1. So 4 into 1 means 4. So this first row is displayed. Okay. Next, I plus plus. Now I will becomes 2. 2 is less than or equal to 10. Condition is true. So one more time body will be executed. So previously the cursor is here. So printf /n. So /n places the cursor in the new line. So what is first %d? N. What is n value? 4. So 4 will be printed. Next, the asterisk symbol will be printed. Second %d means I value. Now y is 2. So 2 will be printed. Next, is equal to symbol will be printed. Next to 4 into 2 means 8 will be printed. So likewise, what is the last row? In the last row, I value is 10. So 10 is less than or equal to 10. Condition is true. So first percentage means 4. 4 will be printed. The asterisk will be printed. Next, I value is 10. 10 will be printed is equal to n into I. N value 4, I value 10. So 4 into 10 means 40 will be printed. Next, I plus plus, I becomes 11. 11 is less than or equal to 10. Condition is false. Okay. So in this way, we can print multiplication table for any given number. Now let's see this program. C program to print multiplication tables within the given range. So here we need to provide minimum value as well as maximum value, and we have to display multiplication tables between the minimum value as well as maximum value. Let minimum value is 4, maximum value is 8. So then we have to print multiplication tables between 4 and 8. So what is 4 multiplication table? 4 into 1 is equal to 4. Next, 4 into 2 is equal to 8, so on. What is the last row of 4 multiplication table? 4 into 10 is equal to 40. Then after that, display a line like this with the help of some minus symbols. Next, what is the next row? 5th multiplication table. So 5 into 1 is equal to 5. Next, 5 into 2 is equal to 10. So on. 5 into 10 is equal to 50. Next, display a row. So likewise, what is the last row? Let here the maximum value is 6. Okay. So 6 into 1 is equal to 6. 6 into 2 is equal to 12. So on the last row is 6 into 10 is equal to 60. So if the minimum value is 4 as well as the maximum value is 6, then we have to display multiplication tables between 4 and 6 like this. Let us start the program. While writing the program, let's write the logic. So the first statement is hash include stdio.h. Why? Because we have to use printf and scanf functions. Those two are available in stdio. Next, any C program execution starts from main function. Next, let us declare the variables. Here the input variables are min and max. So int min comma max. Next, here we need to have two for loops, the outermost for loop and innermost for loop. For the outermost for loop, let us use I. For the innermost for loop, let us use j. So I comma j. Okay. I comma j. If any other variable is needed, then we will declare that variable. Next, before reading, just display the message. Printf enter minimum and maximum values. Printf enter min and max values. So totally we have to enter two integer values. For integer, the format specified is %d. So scanf %d comma. So first one is min. So ampersand min comma ampersand max. So here min means 4, max means 6. Okay. Next, we have to write the code for outermost for loop. Here we are using outermost for loop for this repetition. Okay. First we have to print 4 multiplication table. Next to 5. Next to 6. So for that repetition we are using the outermost for loop. So for in outermost for loop, let us use I. So I is equal to. So first we have to print 4 multiplication table. 4 is available in min. So the initial value of I is min. Next we have to print 5 multiplication table. Next we have to print 6 multiplication table. So the condition is 4 is less than or equal to 6. Next to 5 is less than or equal to 6. Next to 6 is less than or equal to 6. So we have to use less than or equal to condition. If we use only less than condition, then this 6 multiplication table won't print it. Okay. So I less than or equal to max. Next, after printing 4 multiplication table, we need to print 5 multiplication table. Next to 6 multiplication table. So every time we have to increment I value. So I plus plus. Next, innermost for loop. Here we are using innermost for loop in order to print the multiplication table. If you take 4, so first we have to print 4 multiplication table. Here the initial value is 1. Next to 2. What is the final value here? 10. So here we are using this innermost for loop in order to perform this repetition, this column repetition. So what is the initial value of this loop? 1. I is already taken, so let us take j. So j is equal to, the initial value is 1. Next, what is the final value here? We have to repeat until we get 10. We need to display 10 also. So the condition is j is less than or equal to 10. Why? Because we have to display this row also. Next, after 1 we have to calculate for 2. After that we have to calculate for 3. So every time we have to increment j value. So j plus plus. Okay. Next, to display the data. So printf. Here each row should be printed in a new line. So use slash n. Next, 4 is nothing but an integer value. For integer, the format specified is %d. Next, we have to display star symbol, so asterisk symbol, so asterisk. Next, 1, 2, 3, 4, 5, 6 up to 10. These are nothing but the values of j. So 1, 2, 3 are nothing but some integer numbers. So for integer, the format specified is %d. Next, we need to display is equal to. Next, 4, 8, 12, all these are nothing but some integer numbers. So for integer, the format specified is %d, comma. So what are the variables here? Here the first %d is nothing but 4. That 4 is available in I. Next, it becomes 5. Next, it becomes 6. So I, comma. So what is the second %d? The second %d specifies 1, 2, 3, 4. Those 1, 2, 3, 4 are available in j, comma. Next, this 4, 8 is nothing but multiplication of 4 and 1, multiplication of 4 and 2, multiplication of 4 and 3, like that. So they are nothing but the values of I and j. So I star j. Okay. Next, whenever the condition is false, then we have to display a row like this. So for that, so printf within the double quotations, let us use a slash n here, so that the cursor will place us in new line. So minus, 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 minus. So likewise display some minuses. Next, close the outermost for loop. Next, close the main function. Now let's check whether our logic is correct or not. Printf enter min and max values. Minimum value 4, maximum value 6. For I is equal to min, so I value 4. Next, 4 is less than or equal to max. What is max value? 6. So 4 is less than or equal to 6. Condition is true. So this body will be executed. This is nothing but the body of this for loop. Okay. Next, for j is equal to 1, j is less than or equal to 10. So 1 is less than or equal to 10. Condition is true. So this body will be executed. This is nothing but the body of this for loop. Printf slash n. So the cursor places in the new line. What is first %d? I value. What is I value? 4. So this 4 will be printed. Next, the asterisk symbol will be printed. This second %d is nothing but j value. What is j value? 1 will be printed. Next, is equal to symbol will be printed. Next, this last %d is nothing but the multiplication of I and j. I value is 4, j value is 1. So 4 into 1 means 4. So 4 will be printed. Okay. Next, to j plus plus. Now j will become 2. So 2 is less than or equal to 10. Condition is true. Next, so this body will be executed slash n. So it places the cursor in the new line. Next, the first %d means 4. So 4 star. Second %d means j value 2. Next, is equal to symbol will be printed. Next, I star j. 4 into 2 means 8. Likewise, what is the last row? 10. So now let the cursor is here. So let j value is 10. 10 is less than or equal to 10. Condition is true. So first %d means 4. Second %d means 10. So 4 into 10 is equal to 4 into 10 means 40 will be printed. Okay. Next, j plus plus. J becomes 11. 11 is less than or equal to 10. Condition is false. So the control comes out from the j loop. So printf slash n. Some minus minus minus. So a row will be printed like this. Next, I plus plus. Now I becomes 5. 5 is less than or equal to 6. Condition is true. So now 5 multiplication table will be printed. Next, I plus plus. I becomes 6. 6 is less than or equal to 6. Condition is true. So 6 multiplication table will be printed. So likewise, we can print multiplication tables within the specified range. Now let's see this program. C program to print sum of digits of a given number. Let the number is 123. So what are the digits in 123? 1, 2, 3. So the result is 1 plus 2 plus 3. that is nothing but 6. If you take 786, 7865, then totally we have 4 digits in the number. So the result is sum of digits. So 7 plus 8 plus 6 plus 5, that is equal to 15 plus 6, 21 plus 5, 26. If you take the number as some 950, 925, 925, then the result is 9 plus 2 plus 5. So 9 plus 2 means 11, 11 plus 5 means 16. So 16 is the output. So for that we have to write the program. Okay. If you given any number as the input, then it has to print the sum of digits of the corresponding number. Okay. Let's see what is the logic here. So from 925 we have to extract either 9 or 2 or 5. But it is very easy to extract 5 from 925. If you perform modulo temp, then directly it will give the last digit, that is nothing but 5. So here if the number contains 3 digits, then 3 iterations are needed, whereas if the number has 4 digits, then 4 iterations will be needed. So here the number contains 3 digits, so totally we need to require 3 iterations. In the first iteration what we have to do is 10, 925, so 10, so what is the result here? 1092 means 920. So what is the result here? 925 minus 920 means 5. So 5 is the remainder. So if you perform division operation, it will give this quotient, whereas if you perform modulo operation, it will give remainder. That means 925 by 10 means 92, whereas 925 modulo 10 means 5. Why? Because here 925 and 10 are integer numbers. The result of integer by integer is always integer value. So we should not get the result as 92.5. Why? Because here 925 and 10 both are integer values. Okay. Now what we have to do is, initially we have to take a variable called sum. The initial value of the sum is 0, and add this remainder to the sum. So s is equal to s plus r. So what is the initial value of 0? Yes, 0. The initial value of s is 0. Why? Because by adding 0 to the corresponding result, the result won't changes. So s is equal to 0 plus what is the remainder? 5. So 0 plus 5 means 5. Okay. Now what is the result of 925 by 10? 92. In the next iteration there is no need of this 5. So we have to perform operation on only 92. So how to get 92 from 925? That is nothing but by 10. Okay. So next perform operation on 92. So 10 nines are 90. 92 minus 90 means 2. So now what is the remainder value? 2. So add remainder to sum. So 5 plus 2 means 7. Next, the operation on 2 is over. So in the next iteration there is no need of 2. We need to perform operation only on 9. So how to get 9 from 92? That is nothing but by performing division 10. So next to perform operation on 9. 10 zeros are 0. So 9 minus 0 means 0. So 9 minus 0 means 9. So now the remainder is 9. So add 9 to sum. Add 9 to sum. So 9 plus 7 means 9 plus what is the previous result? 7. 9 plus 7 means 16 is the result. Okay. So next, what is the result here? 0. So whenever the result is 0, then quit the process. Okay. So we have to solve this problem mathematically by writing a program. Okay. So let us start the program so that we can get the perfect idea. The first statement is hash include stdio.h. Next, every C program contains main function. So main. Next, int. Here we require a number. So n is nothing but a number. Next, we need to have r. R stands for remainder. Next, we need to require sum. The initial value of the sum is 0. Okay. So what is the input variable here? A number is the input variable. So printf enter a number. So before reading the data, it is better to display the message. So printf enter a number. Next, to read the data. For reading the data, use scanf function. So scanf percentage d comma percentage d stands for decimal number. Decimal number is nothing but integer number only. Here we are reading an integer number. So that's why the format specified is percentage d comma ampersand n. Okay. Next, here we have to repeat the loop as long as n is not equals to 0 or n is greater than 0. In the first iteration, n value is 925. In the second iteration, n value 92. In the third iteration, n value 9. So whenever n becomes 0, then we have to quit the process. So while n is not equal to 0, then only we have to perform the operation. So first, what we have to do now? First, from 925 we have to extract this 5. So how to extract 5 from 925? By performing modulo 10. So here the first statement is r is equal to n modulo 10. So n modulo 10 will use the remainder. Okay, now r value is 5. Next, what we have to do? We have to add r value to sum. So the next statement is sum is equal to sum plus r. Now the operation on this 5 is over. In the next iteration, there is no need of 5. In the next iteration, there is no need of 5. We need to have only 92 as n value. So how to get 92 from 925? This is nothing but quotient. So by performing the division with 10, then we will get 92. So n is equal to n by 10. N by 10. Next, calculate, close the while loop. Next, whenever the condition is false, then display some value. Printf sum of digits is equal to sum of digits of given number is percentage d comma the result is available in sum. Okay. Next, to close the main function. Now let's check whether our logic is correct or not. So printf enter a number, a scan of percentage d comma ampersand n. Here what is the initial value of the sum? The initial value of the sum is 0. Okay. Why n is not equal to 0? Here let us assume that n value is 925. So 925 is not equal to 0. Condition is true. So this body will be executed. R is equal to n modulo 10. So what is 925 modulo 10? Modulo means remainder, whereas division means this quotient. N modulo 10. Here n is 925. So 925 modulo 10 means 5. So now R value is 5. Sum is equal to sum plus R. The initial value of the sum is 0. Now R value is 5. So 0 plus 5 means 5. Next, n is equal to n by 10. N value is 925. 925 by 10 means 92. Now n value is 92. Now n value is 92. So this iteration is over. So what is n value now? 92. So once again control goes to the condition. So what is n value now? 92. 92 is not equal to 0. Condition is true. So R is equal to n modulo 10. 92 modulo 10 means 2. Sum is equal to sum plus R. The previous value of the sum is 5, whereas R value is 2. So 5 plus 2 means 7. Next, n is equal to n by 10. 92 by 10 means 9. So now n value is 9. So once again control goes to the condition. Okay. Why n is not equal to 0? 9 is not equal to 0. Condition is true. So one more time body will be executed. R is equal to 9 n modulo 10. So what is 9 modulo 10? 0. I'm sorry. What is n modulo 10? What is 9 modulo 10? 9. So now R value is 9. Sum is equal to sum plus R. The previous value of sum is 7. So 7 plus 9 means 16. Next, n is equal to n by 10. So what is 9 by 10? 0. So 0 is not equal to 0. 0 is not equal to 0. Condition is false. So the control comes out from the while loop. So sum of digits of the given number is, in place of percentage, the sum value will be printed. What is sum value? 16. So 16 will be printed on the monitor. Sum of digits of given number is 16 will be printed on the monitor. So in this way we can print sum of digits of a given number. Now let's see a C program to print reverse of a given number. That means let the number is 786. So after reversing 786, what is the output? 687 is the output. Let the number is 12. So after reversing 12, the output is 21. So here the input is a number, whereas the output is reverse of that number. Okay. Let us assume that here the number is 1234. Let us assume that the number is 1234. So the reverse of 1234 is 4321. Okay. So we have to display 4321 as the output. Here if the number contains 2 digits, then 2 iterations are needed. Whereas if the number contains 3 digits, then 3 iterations are needed. In this example, the number contains 4 digits. So totally we need to have 4 iterations. So let's see the logic here. First from 1 to 3, 4, we have to extract a digit. From 1 to 3, 4, it is very easy to extract the last digit, that is nothing but 4. If you perform modulo 10 operation, then we will get the last digit, that is nothing but 1, 2, 3, 4. The last digit, that is nothing but 4. Let us perform the operation. So 10, 1, 2, 3, 4. Here 10 ones are 10. Next directly we can write here. So 10 ones are 10. Next to 23. 10 20s are 20, 3, 4. So 10 30s are 30. That is nothing but 4. Okay. So here what is the remainder here? 4 is the remainder. So 10, 1, 2, 3 is nothing but the quotient. So 10 into 1, 2, 3, 0 is nothing but 1, 2, 3, 0, 4. So if we perform modulo 10, then we will get 4. Whereas if we perform division 10, we will get the quotient. Here the quotient is 123, remainder is 4. Okay. Division operation will give quotient, whereas modulo operation will give the remainder. Here the logic is very simple. REV is equal to REV into 10 plus remainder. The initial value of REV is 0. So 0 into 10 plus, so what is the initial remainder? 4. So 0 into 10 means 10. 10 plus 4 means 4. So that means after the first iteration, we will get the last digit as the output. After second iteration, the last 2 digits are reversed. That means we will get 43 as the output. After the third iteration, we will get the reverse of the last 3 digits. That is nothing but 432. In the last iteration, we will get 4321 as the output. Okay. Now the operation on 4 is over. So in the next iteration, there is no need of 4. So we need to have 123. So how to get 123 from 1 to 3, 4? By performing division 10 operation. Okay. So now in the first iteration, n value is 1, 2, 3, 4. Whereas in the second iteration, n value is 123. So 10 12s are 120. So 123 minus 120 means 3. Okay. So now what is the remainder value? 3 is the remainder value. So REV is equal to, what is the formula? REV into 10. What is REV value? 4. So 4 into 10 plus, what is the remainder value now? 3. So 4 into 10 means 40. 40 plus 3 means 43. That is nothing but reverse of the last 2 digits. Okay. So in the second iteration, operation on 3 is over. So in the next iteration, there is no need of 3. We have to perform operation only on 12. So how to get 12 from 123? That is nothing but by division, by 10. Okay. So in the third iteration, n value will become 12. So 10 ones are 10s. So 12 minus 10 means 2. So now the remainder value is 2. So let us calculate now. REV is equal to REV into 10. The previous value of REV is 43. So 43 into 10 plus, now remainder value is 2. So 43 into 10 means 430. 430 plus 2 is nothing but 432. 432 means reverse of the last 3 digits. Okay. Next, operation on 2 is over. So now there is no need of this 2 in the next iteration. Okay. So how to get this one? By performing division 10. Okay. So 10, 1. So 10 zeros are 0. So 1 minus 0 means 1. So now the remainder value is 1. So REB is equal to, REB value is 432. 432 into 10 plus, what is the remainder? 1. So that is nothing but 4321. So now what is n value? 0. So we have to repeat the loop as long as n is not equal to 0. So whenever n is equals to 0, then we have to quit from the loop. So what is REB value? 4321. So that is nothing but the reverse of this number. Okay, the reverse of 1, 2, 3, 4. Now we have to write a program in order to implement reverse of a given number. So let's write the program. The first statement is hash include stdio.h. Why? Because we are using printf and scanf functions. Printf and scanf are available in stdio. Next, every C program execution starts from main function. Next, the variables which are needed are, we need to have a number. For number, let us use n. Next, in order to calculate the remainder, use r. Next, in order to calculate reverse of a given number, we need to have REB. The initial value of REB is 0. Okay. Next, before reading n value, let us display some message on the monitor. So printf enter n. Printf enter n. Next, scanf. Here n is of type integer. For integer, the format specified is %d, where d stands for decimal number. Decimal number is nothing but integer number only. Ampersand n. Next, what is the condition here? We have to perform the repetition as long as n is not equals to 0. So while n is not equals to 0, so if n is not equals to 0, then we have to perform the repetition. So first what we have to do? First we need to calculate the remainder. What is the formula for remainder? R is equal to n modulo 10. Why? Because modulo will always use the remainder. So R is equal to n modulo 10. Next, what is the formula for calculating reverse? REB is equal to REB into 10 plus R. So that is the formula here. So REB is equal to REB into 10 plus R. Okay. In the first iteration, R value is 4. In the second iteration, R value is 3. In the third iteration, R value 2. In the last iteration, R value 1. Likewise. Next, what is n value? N value should be 123. So how to get 123 from 1 to 3, 4? That is nothing but division 10. Okay. So n is equal to n by 10. So whenever the condition is false, then reverse of the number is available in REB. So printf, so display the message. Printf reverse of number is %d comma. So result is available in REB. Next, close the main function. Okay. Now let's check whether our logic is correct or not. We know that execution starts from the main function. The initial value of REB is 0. Next, printf enter a number. Scanf %d comma ampersand n. Let the number is 1, 2, 3, 4. While n is not equal to null. So what is n value? 1, 2, 3, 4. So 1, 2, 3, 4 is not equal to null. 1, 2, 3, 4 is not equal to 0. Condition is true. So the body will be executed. R is equal to n modulo 10. So what is 1, 2, 3, 4 modulo 10? 4. So now R value is 4. Next, reverse is equal to reverse into 10 plus R. What is the previous value in reverse? 0. So 0 into 10 plus what is R value? 4. So 0 into 10 means 0. 0 plus 4 means 4. Next, n is equal to n by 10. 1, 2, 3 by 1, 2, 3, 4 by 10 is nothing but 1, 2, 3. So now n value is 123. Okay. So now the first iteration is over. So after first iteration, what is the output? The last digit in 1, 2, 3, 4. In 1, 2, 3, 4, what is the last digit? 4 is the last digit. Okay. So that is the output here. Okay. So next, control goes to the value. While n is not equal to 0. Now n value is 1, 2, 3. So 1, 2, 3 is not equal to 0. Condition is true. So body will be executed. So it will be executed now. R is equal to n modulo 10. 1, 2, 3 modulo 10 means 3. So now R value is 3. REB is equal to REB into 10 plus R. So what is REB value? 4. So 4 into 10 plus what is R value? 3. 4 into 10 means 40. 40 plus 3 means 43. So next, n is equal to n by 10. 1, 2, 3 by 10 means 12. So now n value is 12. The second iteration is over. After second iteration, what is the output? 43. 43 means reverse of the last 2 digits. So once again, control goes to the condition. Now what is n value? 12. 12 is not equal to 0. Condition is true. So R is equal to n modulo 10. Okay. So this is over. Now it will be executed. So what is 12 modulo 10? 2. Next, now R value is 2. REV is equal to REV into 10 plus R. So 43 into 10 plus, what is R value? 2. So 43 into 10 means 430. 430 plus 2 means 432. Next, n is equal to n by 10. 12 by 10 means 1. So now n value is 1. So third iteration is over. What is REV value? 432. 432 means the reverse of the last 3 digits. So once again control goes to the condition. While n is not equal to 0. Now n value is 1. 1 is not equal to 0. Condition is true. So now it will be executed. R is equal to, it will be executed. R is equal to n modulo 10. 1 modulo 10 means 1. Okay. So now R value is 1. REV is equal to REV into 10 plus remainder. What is the remainder value? 1. 432 into 10 means 4320 plus 1 means 4321. Next, n is equal to n by 10. 1 by 10 means 0. Now n value is 0. Okay. Now control goes to the condition. 0 is not equal to 0. Condition is false. So control comes out from the while loop. Reverse of the number is in place of percentage the REV value will be printed. What is REV value? 4321 will be printed. So in this way we can print reverse of a given number. Now let's see this program. C program to check whether given number is palindrome or not. So we have to check whether a number is palindrome number or not. Palindrome number means the reverse of a number is equals to the given number. Let the number is 121. So after reversing 121, what is the output? 121 is the output. That means both these numbers are same. So we can say that 121 is a palindrome number. Let us take 55. So what is the reverse of 55? The reverse of 55 is 55 only. So that means the reverse of a number is equals to the given number. So we can say that 55 is a palindrome number. So for that we have to write the program. So first we have to write the logic for reverse of a given number. The logic for reverse of a given number is very simple. Let the number is 786. So after reversing 786, the output is 687. So 687 is the output. Here the number contains 3 digits. So we need to have 3 iterations. Suppose if the number contains only 2 digits, then only 2 iterations are needed. Okay. But here how many digits we have in the number? 3 digits. So totally we have 3 iterations are needed. From 786 we have to extract either 7 or 8 or 6. But it is very easy to extract 6 from 786. We can extract the last digit very easy from the given number by performing modulo 10 operation. So let's see that operation. So 10, 786. 10 78s are 780. So 786 minus 780 means 6. So if you perform modulo operation, we will get the remainder value. Whereas if you perform division operation, we will get the quotient value. But here we should not get a floating point value as the result. Why? Because 786 is integer value, 10 is integer value. Integer by integer means only integer. We should not get the output as 78.6. Okay, 78.6. That is not the correct output. Why? Because numerator and denominator are integer values. So the result is also integer value. Okay. So here the formula is very simple. In order to reverse the given number, the formula is REV is equal to REV into 10 plus remainder. Okay. The initial value of REV is 0. So 0 into 10 plus. So what is the remainder now? 6. So 0 into 10, 0. 0 plus 6 means 6. So after first iteration, REV value is 6. That means the last digit. After second iteration, the value of REV is the reverse of last two digits. That is nothing but 68. Whereas after the last iteration, the value of REV is 687. Okay. Now the operation on 6 is over. In the next iteration, there is no need of 6. We need to perform operation only on 78. So how to get 78 from 786? That is nothing but by 10. So in the next iteration, the value of n is 78. So 10 sevens are 70. 78 minus 70 means 8. Okay. So now the remainder value is 8. whereas this division value is 7. Okay. Now let us calculate REV. REV is equal to, what is the formula? REV into 10 plus R. What is the previous value in REV? 6. So 6 into 10 plus, what is remainder value? 8. So 6 into 10 means 60. 60 plus 8 means 68. 68 is nothing but the reverse of the last two digits. Now the operation on 8 is over. In the next iteration, there is no need to perform operation on 8. We have to perform operation on 7 only. So how to get 7 from 78? That is nothing but by 10. Okay. So in the next iteration, the value of n will become 7. So 10 zeros are 0. 7 minus 0 means 7. So now the remainder value is 7. So calculate REV. REV is equal to REV into 10. Now REV value is 68. So 68 into 10 plus, what is the remainder value? 7. 68 into 10 means 680. 680 plus 7 means 687. Okay. So now the last iteration is over. So what is the REV value? 687. So 687 is nothing but the reverse of 786. So in the next iteration, what is n value? N value is 0. So whenever n becomes 0, then we have to fit from the while loop. Now check whether the given number as well as this REV are same or not. If they are same, then it is a palindrome number. If they are not same, but it is not a palindrome number. Okay. Now let's write the program. Hash include stdio.h. Why? Because we have to use printf and scanf functions. Printf and scanf are available in stdio. Next, every C program execution starts from main function. Next, declare the variables. Here the variables which are needed are, we need to have n, a number. Next, what is the initial value of REV? REV is equal to 0. Next, we need to have one more temporary variable, temporary variable. Let the temporary variable is PAL. So why we are using PAL here? Here PAL stands for palindrome number. Here palindrome number means the reverse of a given number. After reversing the number, the result is available in REV. But whenever that condition is false, what is n value? N value is 0. N doesn't contain 786. Okay. In the first iteration, n value is 786. In the second iteration, n value 78. In the third iteration, n value 7. In the next iteration, n becomes 0. So n doesn't contain 786. So we have to store n in a temporary variable. The temporary variable is nothing but PAL. So before going into the while loop, we have to store n value in PAL. Okay. PAL stands for palindrome number. Okay. Next, read n value. So before reading, let us display some message. Printf enter n. Printf enter n. Next, scanf %d comma %n. So after reading is over, what we have to do? We have to store n value in PAL. So PAL is equal to n. Now PAL contains 786. Now how long we have to repeat the loop? While n is not equal to 0. If n becomes 0, then we have to quit from the loop. So while n is not is equal to 0, so first we have to calculate remainder. So for that we need to have one more variable, that is R. R stands for remainder. What is the formula for remainder? Remainder is equal to n modulo 10. So by performing modulo operation, we will get the remainder. So R is equal to n modulo 10. Next, what is the formula for REV? REV is equal to REV into 10 plus R. So REV is equal to REV into 10 plus R. Okay. Next, in the next iteration, n has to become 78. So how to get 78 from 786? That is nothing but by 10. So n is equal to n by 10. N is equal to n by 10. Next, whenever the condition is false, then compare PAL value and REV value. If they are same, then we can say that it is a palindrome number. If they are not same, then we can say that it is not a palindrome number. Okay. So here the condition is, if PAL double is equal to REV, printf, we can say that it is a palindrome number. So printf %d is palindrome number. So what is %d? %d means n value, but n value becomes 0. Now n is available in which variable? PAL. Okay. Else printf, we can say that percentage d is not a palindrome number. Percentage d is not a palindrome number. So what is percentage d here? Percentage d means PAL. Next, to close the main function. Now let's check whether our logic is correct or not. So printf enter n value, scan of percentage d comma ampersand n. Let the value of n is 786. Next, PAL is equal to n. So what is PAL now? 786. So now PAL value is 786. Next, while n is not equal to 0. What is n value? 786. So 786 is not equal to 0. Condition is true. So r is equal to n modulo 10. So what is 786 modulo 10? 6. Reverse is equal to reverse into 10 plus r. The initial value of rev is 0. So 0 into 10 plus what is remainder value? 6. So 0 into 10 means 0. 0 plus 6 means 6. Next, n is equal to n by 10. 786 by 10 means 78. So in the next iteration, the value of n is 78. Next, once again control goes to the while loop. While n is not equal to 0, now n value is 78. So 78 is not equal to 0. Condition is true. So r is equal to n modulo 10. 78 modulo 10 means 8. Next, rev is equal to rev into 10 plus r. So what is the previous value in rev? 6. So 6 into 10, 60. 60 plus what is remainder value? 8. So 60 plus 8 means 68. Next, n is equal to n by 10. 78 by 10 means 7. So in the next iteration, the value of n is 7. So once again control goes to the condition. While 7 is not equal to 0, condition is true. So the body will be executed. R is equal to n modulo 10. 7 modulo 10 means 7. Next, rev is equal to rev into 10 plus r. 68 into 10 means 680. 680 plus 7 means 687. N is equal to n by 10. 7 by 10 means 0. Next, once again control goes to the condition. While 0 is not equal to 0, condition is false. So the control comes out from the while loop. If PAL double is equal to rev, what is PAL value? 786. What is rev value? 687. So these two are not equal. So else block will be executed. Percentage d is not a palindrome number. Okay. So what is percentage d? PAL. So what is PAL? 786. So 786 is not a palindrome number will be printed. Okay. Now let n value is 121. 121. So PAL is 121. Next, control goes to the condition. So what is the reverse of 121? The reverse of 121 is 121 only. Next, if PAL double is equal to rev, PAL value 121, reverse value 121. 121 double is equal to 121. Condition is true. So in place of this percentage, the PAL will be printed. So 121 is palindrome number will be printed on the monitor. So in this way, we can check whether given number is palindrome number or not. Now let's see this program. C program to print palindrome numbers within the given range. We know what is a palindrome number. The reverse of a number is equals to the given number. Let the number is 121. The reverse of 121 is also 121. So these two are same. So we can say that 121 is a palindrome number. Let the number is 13. The reverse of 13 is 31. Okay. 13 and 31. These two are not equal. So we can say that 13 is not a palindrome number. So what is a palindrome number? If reverse of a number is equals to the given number, then we can say that it is a palindrome number. First, let's see the logic for palindrome number. After that, we will see a program in order to display the palindrome numbers within the given range. Let the number is 147. So first we have to find out reverse of 147. So what is the reverse of 147? 741. So from 147 we have to extract either 1 or 4 or 7. From 147 we can extract the digit 7 very easily by performing modulo 10. So here the operation is 10 147. 10 14s are 140. 147 minus 140 means 14. So first we got a remainder as 4. So here the formula is very simple. Reverse is equal to reverse into 10 plus r. R means remainder. The initial value of the reverse is 0. So 0 into 10 plus what is the remainder value here? 4. So 0 into 10 means 0. 0 plus 4 means 4. So after first iteration, what will happen is, so what is 147 minus 140? 147 minus 140 means 7. Modulo will always gives remainder, whereas division will gives quotient. So here what is the remainder? 7 is the remainder. So 7 is the result. So after first iteration, the last digit is the reverse of the given number. After second iteration, reverse of last two digits. That means 74 is the output. After the next iteration, reverse of the last three digits. That is nothing but 741 is the output. Now the operation on 7 is over. Next we have to perform operations on 14. So how to get 14 from 147? By performing division 10. So now n value is 14. So 10 ones are 10. 14 minus 10 means 14. So now the remainder is 4. So here the formula is reverse is equal to reverse into 10. The previous value of reverse is 7. So 7 into 10 plus this remainder is 4. So 7 into 10 means 70. 70 plus 4 means 74. So after second iteration, 74 is the reverse number. 74 is nothing but reverse of last two digits. Now we performed operation on 4. So in the next iteration there is no need of 4. Now we have to perform operations on 1 only. So how to get 1 from 14? That is nothing but division 10. Okay. Next, now n value is 1. So 10 zeros are 0. 1 minus 0 means 1. Okay. So here now remainder is 1. Reverse is equal to reverse into 10. The previous value of reverse is 74. 74 into 10 plus 1. That is nothing but 741. Okay. Now what is n value? 0. So we have to perform the repetition as long as n is not equal to 0. So what is the reverse number? 741 is the reverse number. If reverse number and given number both are same, then we can say that it is a palindrome number. But here what is the given number? 147. What is the reverse number? 741. These two are not same. So we can say that 147 is not a palindrome number. In this example, our target is we have to print palindrome numbers within the given range. Let the minimum value is 10, maximum value is 100. So we have to display the palindrome numbers between 10 and 100. So what are the palindrome numbers between 10 and 90? Minimum value 10, maximum value 90. From 10 to 20, we have only one palindrome number, that is 11. Next, from 21 to 30, 22. From 31 to 40, 33. From 41 to 40, 44. From 51 to 60, 55. So like that we can have several palindrome numbers. So we need to display all those palindrome numbers. Let us start the program. While writing the program, we will discuss the logic in detail. The first statement is hash include stdio.h. Why? Because we have to use printf and scanf functions. Printf and scanf are available in stdio. Next, main C program execution starts from main function. Here the input variables are min and max. So int min comma max. So these two are the input variables, min comma max. Next, we have to store minimum value in a number, in a variable. For that, let us use n. Next, we need to calculate a remainder. For that, let us declare r. Next, we have to calculate reverse of the given number. So for that, we need rev. Next, here the problem is after performing operations on the n, in the first iteration n value is 147. In the second iteration n value 14. In the third iteration n value 1. In the next iteration n value becomes 0. So n doesn't contains this number. Okay. So what we have to do is, before checking the condition, we have to store n in a temporary variable. Here let us assume that the temporary variable is pal. Pal stands for palindrome. Okay. So why we are using this variable? If you take any number, whenever the condition is false, then n value will become 0. We have to repeat the loop as long as n is not equal to 0. So whenever n becomes 0, then we have to check the value of n with this reverse. If these two are same, then we can say that it is a palindrome number. But whenever the condition is false, n is not containing this number, n is containing 0. So that's why we need to store n in a temporary variable called pal. So these are the variables. Next, read the number. So before reading the number, display some message. So printf enter n. Next, read the number, scanf. For integer, the format specified is %d. So %d comma ampersand n. Okay. Next, here we have to find out the palindrome numbers between minimum value and maximum value. So here the for loop is for I is equal to, we have to start from minimum, and we need to check whether max is also palindrome or not. So the condition should be less than or equal to. If we use only less than, then max will not be compared. I plus plus. First we have to check for 10, next we have to check for 11, next we have to check for 12. Like that the process is to be continued. Okay, so I plus plus. Okay, so first we have to check whether 10 is a palindrome number or not. So we have to store the 10 in a variable. So let us store 10 in I. Okay, but here what is the problem? Whenever the condition is false, then n becomes 0. So we need to store n in a temporary variable called pal. So pal is equal to n, or we can write it as I also. Next, check whether n is palindrome number or not. So for that, what is the condition? Here we have to perform the repetition as long as n is not equal to 0. So why n is not equal to 0? So first what we have to do? First we have to calculate remainder. What is the remainder? Remainder means n modulo 10. R is equal to n modulo 10. Okay. Next we have to calculate reverse. What is the formula for calculating reverse? Reverse is equal to reverse into 10 plus R. But what is the initial value of reverse? The initial value of the reverse is 0. So here we need to include one more statement, that is reverse is equal to 0. Here include one more statement, reverse is equal to 0. So for each number we have to perform this initialization. First we have to check whether 10 is palindrome or not. So we have to reverse 10. So the initial value of REV is 0. Next we have to check whether 11 is palindrome or not. So the initial value of REV should be 0. Okay. So for each number the initial value of REV should be 0. Okay. Next, operation on 147 is over. Next we have to perform operations on 14. How to get 14 from 147? That is nothing but n is equal to n by 10. Okay. So this is over. Okay. Next, what we have to do? We have to check whether the values of PAL and REV are equal or not. If PAL value as well as REV value both are equal, then we can say that it is a palindrome number. If PAL double is equal to REV, then printf palindrome number. Here there is no need to display palindrome number, just to display that value. So which value we have to display here? N contains here 0 only whenever the condition is false. So we have to display either I or this PAL. Why? Because both are same only. So printf %d /n comma, so display I. Okay. So next close the for loop. Next close the main function. Okay. Let us assume that minimum value is 11, whereas the maximum value is some 25. Okay. So what is the initial value of I? I is equal to 11. Next n is equal to 11. PAL is equal to 11. REV is equal to 0. So next here this while loop reverses the given number. So what is the reverse of 11? The reverse of 11 is 11 only. So now REV value is 11. Okay. Next, so whenever this condition is false, we have to check PAL value and REV value. What is PAL value? 11. What is REV value? 11. Both are same. So what will happen now? 11 will be printed. Next, I plus plus. Now I becomes 12. Okay. Next, while n is not equal to 0. So whenever this condition is false, then REV stores the reverse of 12. So what is the reverse of 12? 21. Now what is PAL value? PAL value is 12, whereas REV value is 21. 12 double is equal to 21. False. So this value won't be printed. I plus plus. Next I becomes 13. So now what is PAL value, n value? 13. What is the reverse of 13? 31. So now PAL value 21, REV value 31. Both are not equal. So 13 won't be printed. Next likewise 14 won't print, 15 won't printed. If you take 22, the reverse of 22 is 22. Whereas the value of the PAL is 22. Both are equal. So 22 will be printed. So 11 and 22 are the palindrome numbers between 11 and 25. So in this way we can print palindrome numbers within the given range. Now let's see this program. C program to check whether given number is Armstrong number or not. Armstrong number means the sum of cubes of digits is equals to the given number. Let the number is 153. So what are the digits in 153? 153. So the sum of cubes of 153 are 153 only. So what are the digits in 153? What are the digits in 153? 153. So 1 cube plus 5 cube plus 3 cube is equal to. So what is the result of 1 cube? 1. What is the result of 5 cube? So 5 into 5, 25. 25 into 5, 125. Next 3 cube means 3 into 3, 9. 9 into 3 means 27. That is nothing but 153 only. So if the sum of cubes of digits of a number is equals to the given number, then we can say that it is an Armstrong number. Okay. Let's see how we are checking whether the number is Armstrong number or not. So from 153 we have to extract either 1 or 5 or 3, but from 153 it is very easy to extract 3, that is nothing but the last digit of the number. So what is the Armstrong number? 153. So if we perform modulo 10, then we will get 3. So 10 15s are 150. 153 minus 150 means 3. Modulo operator will always gives a remainder, whereas division operator will gives quotient. So if we perform modulo 10, we will get 3. Initially we have to take a variable called sum. The initial value of the sum is 0. So in the first iteration, what is the remainder value? 3. So here we have to cube that remainder. So 3 cube is nothing but 27. So you add 27 to sum. So 0 plus 27 means 27. Now operation on 3 is over. In the next iteration there is no need of 3. We have to perform operation on 15 only. So how to get 15 from 153? That is nothing but 153 by 10. 153 by 10 means 50. Now perform operation on 15. So 10 ones are 10. 15 minus 10 means 15. So now the remainder value is 5. So cube 5. So what is the result of 5 cube? 125. You add 125 to some value. The previous value of sum is 27. 27 plus 5 cube means 125. 125 plus 27 means 153. Now operation on 5 is over. So next we have to perform operation on 1. So how to get 1 from 15? That is nothing but by 10. So now n value is 1. So 10 zeros are 0. So 1 minus 0 means 1. Now remainder value is 1. So cube 1. So what is the cube of 1? 1. You add 1 to sum. So 152 plus 1 cube means 153. Now n becomes 0. So that means operations on all the digits are over. So here we have to repeat the loop as long as n is not equal to 0. So if the number contains 3 digits, then 3 iterations are needed. Whereas if the number contains some 5 digits, then 5 iterations are needed. Now let us write the program. The first statement is header file hash include stdio.h. Why? Because in this program we are using printf and scanf functions. Printf and scanf are available in stdio header file. Next, every C program execution starts from main function. Now let us declare the variables. Here we need a number n. The initial value of the sum is 0. So sum is equal to 0, comma. We need to have remainder. So r, comma. Here in the first iteration n value is 153. In the second iteration n value is 15. In the third iteration n value is 1. In the next iteration n becomes 0. So whenever the condition becomes false, then n is 0. But what is Armstrong number? Here the number is 153. But 153 is not available in n. Why? Because whenever the condition becomes false, n becomes 0. So before checking the condition, we have to store n in some temporary variable. Let name of the temporary variable is Armstrong. Armstrong. Okay. So these are the variables which are needed. So first read n. So before reading, display some message. So printf enter n value. Next read n value. So scanf. Here n is of type integer. For integer the format specified is %d. So %d comma n. Okay. Here we have to check whether the number as well as the sum value both are equal or not. If both are equal, then only we can say that it is an Armstrong number. But whenever the condition is false, n is becoming 0. So that's why before checking the condition, we have to store n value in a temporary variable called Armstrong. So Armstrong is equal to n. So now Armstrong contains n, that is nothing but 153. Now write the code. So here how long we have to repeat the loop? As long as n is not equal to 0. So while n is not equal to 0, so first we have to calculate the remainder. So how to calculate remainder? Remainder is equal to n modulo 10. Remainder is equal to r is equal to n modulo 10. Next, after that we have to cube r and add it to sum. Okay, the initial value of the sum is 0. So sum is equal to sum plus cube r. So r cube can be written as r into r into r. Okay. Next, in the first iteration n value is 153. So now operation on 3 is over. So next, in the next iteration n should be 15. So how to get 15 from 153? That is nothing but n is equal to n by 10. Next, whenever the condition is false, then compare Armstrong and sum. If both are equal, then we can say that it is Armstrong number. If they are not equal, then we can say that it is not an Armstrong number. Okay. So here the condition is very, very simple. If Armstrong double is equal to sum, then we can say that it is Armstrong number. So printf Armstrong number. If they are equal, then we can say that it is Armstrong number. Else, we can say that it is not an Armstrong number. So else printf not Armstrong number. Not Armstrong number. Okay. Next, to close the main function. And now let's check whether our logic is correct or not. Here the initial value of the sum is 0. Printf enter n. Let n value is 153. Next, Armstrong is equal to n. So what is Armstrong value? Armstrong is equal to 153. Okay. Next, why n is not equal to 0. So what is n value? 153. So 153 is not equal to 0. Condition is true. So r is equal to n modulo 10. 153 modulo 10 means 3. Okay. Next, sum is equal to sum plus r cube. 0 plus what is 3 cube? 27. So 0 plus 27 means 27. Next, n is equal to n by 10. 153 by 10 means 15. So the first iteration is over. Now n value is 15. So once again control goes to the condition. While n is not equal to 0. So 15 is not equal to 0. Condition is true. So r is equal to n modulo 10. 15 modulo 10 means 5. Sum is equal to sum plus r cube. 27 plus 5 cube means 125. 125 plus 27 means 152. N is equal to n by 10. 15 by 10 means 1. So now n value is 1. Once again control goes to the condition. While 1 is not equal to 0, condition is true. R is equal to n modulo 10. So 1 modulo 10 means 1. Sum is equal to sum plus r cube. 152 plus 1 cube means 153. Next, n is equal to n by 10. 1 by 10 means 0. Now n value is 0. 0 is not equal to 0. Condition is false. So control comes out from the while loop. If Armstrong double is equal to sum, what is Armstrong? 153. What is sum? 153. 153 is double is equal to 153. Condition is true. So Armstrong number message will be printed on the monitor. So in this way we can check whether a number is Armstrong number or not. Now let's see this program. C program to print Armstrong numbers within the given range. First let's see what is an Armstrong number. Armstrong number means the sum of cubes of digits of a number is equals to the given number. The perfect example for Armstrong number is 153. So in 153 the digits are 153. Perform cube and add those digits. So 1 cube plus 5 cube plus 3 cube. So 1 cube means 1, 5 cube means 125, 3 cube means 27. Add these three numbers. So 7 plus 5 means 12, 12 plus 1 means 30. So 2 to 1 means 5, 153. So this 153 is nothing but the given number. So we can say that 153 is an Armstrong number. So here some minimum value is specified as well as some maximum value is specified. So we have to display the Armstrong numbers between minimum value and maximum value. Let minimum value is 1, maximum value is 10,000. So it brings Armstrong numbers between 1 to 10,000. Actually, if mathematically, if you want to calculate Armstrong numbers between 1 to 10,000, it will take hours of time. Whereas with the help of a simple program with some 10 to 20 lines of code, we can display any range of Armstrong numbers by specifying minimum and maximum values. First, let's see how to calculate whether the number is Armstrong number or not. After that, we will see the program by specifying the range. So the best example for Armstrong number is 153. So from 153 we have to extract either 1 or 5 or 3, but it is very easy to extract 3 from 153 by performing modulo 10 operation. So 10, 153, 10 15s are 150, 153 minus 150 means 3, okay. So now what is the modulo result here? The last digit, that is nothing but 3. Modulo will always gives remainder, whereas division will always give quotient. Now what we have to do is, initially let us take a variable called sum. The initial value of the sum is 0, because by adding 0 the result won't changes. So here the Armstrong number means we have to cube each digit. So what is the cube of 3? 3 cube means 27. 27 should be added to sum. So 27 plus 0 means 27. Next operation on 3 is over. So in the next iteration there is no need of this 3. Now we have to perform operation on 15. So how to get 15 from 153? By performing division 10. So in the next iteration the value of n is 15. In the first iteration the value of n is 153. So 10 ones are 10. 15 minus 10 means 15. So now the remainder value is 3. Okay. Previously what is remainder value? 3. I'm sorry. Previously it is 3. Now it is 5. So sum is equal to sum plus what is the cube of 5? So 5 cube means 125. So 125 should be added to 27. 125 plus 27 means 152. Now operation on 5 is over. In the next iteration there is no need of 5. Now we have to perform operation on 1. So how to get 1 from the 15? By performing division 10. So 10, 1, 10 zeros are 0. 1 minus 0 means 1. Okay. So now the remainder is 1. So we have to add this remainder to the sum. So sum is equal to 152 plus 1 cube. That is nothing but 153. So in the first iteration n value 153. In the second iteration n value 15. In the next iteration n value 1. Now what is n value? 0. So we have to repeat the loop as long as n is not equal to 0. Okay. So here what is the sum value? 153. What is the given number? 153. So both are equal. So we can say that 153 is Armstrong number. So for that we have to check whether a range of numbers are Armstrong numbers or not. Okay. We need to specify minimum value as well as maximum value. So the program has to display Armstrong numbers between the minimum value and the maximum value. Let's see the program. While writing the program we will see the logic in detail. The first statement is hash include stdio.h. Because we are using printf and scanf functions, printf and scanf are available in stdio. Next, every C program execution starts from main function. Next, here the input variables are min and max. So min comma max. Next, to perform operations on the number, let us use n. Next, here we need to calculate the remainder. So R for remainder. Next, in order to store the result, use a variable called sum. Here the problem is whenever the condition is false, then n is becoming 0. So we should not compare n with 153. Why? Because sum is 153 only, but n is not containing 153. N is containing 0. In the first iteration n value 153. In the second iteration n value 15. In the third iteration n value 1. In the next iteration n has to become 0. So before checking the condition, we have to store n in a temporary variable. For that, let us declare one more variable. Name of that variable is Armstrong. So these are the variables needed, and for repetition purpose in the for loop, let us declare a variable called I. Okay. Next, first display the message. So what are the input variables here? Printf enter. The input variables are min and max values. So printf enter min and max values. Enter min and max values. Next, read the values with the help of the scanf function. So the statement is scanf %d. Why? Because both are integers. Next, ampersand, minimum variable is min, whereas maximum variable is max. Okay. Next, we have to take a for loop in order to specify a range of numbers. Let the minimum value is 1, whereas the maximum value is 30. So first we have to check whether 1 is Armstrong or not. Next to 2, next to 3, likewise up to 50. So what is the minimum value? Minimum value is available in min variable. Next we have to check up to 10,000. We need to check 10,000 also. We need to check whether 10,000 is Armstrong or not. So the condition should be I less than or equal to max. If we use only less than, then 10,000 won't be checked. Next, after checking 1, we need to check whether 2 is Armstrong or not. Next, 3 is Armstrong or not. So every time we have to perform implementation. Next, what we have to do? We have to store this I value in a number called n. N is equal to I. So now we can perform operations on the number. But here what is the problem? Whenever the condition is becoming false, it is containing, n is containing 0. So it is better to store n in Armstrong. If you want, we can compare with I also. It is our choice. So Armstrong is equal to n. Okay. Now let's write the logic for Armstrong number. So we have to repeat the loop as long as n is not equal to 0. So whenever n becomes 0, then we can stop the while loop execution. Next, first we have to calculate the remainder. The formula for remainder is equal to n modulo 10. Remainder is equal to n modulo 10. Next we have to add this remainder to the sum. So here we have to perform the initialization here. Include one more statement, that is nothing but sum. Sum is equal to 0. So for every number, the initial value of the sum is 0. So for the first number is 1. So for 1, sum should be 0. Next we have to check for 2. So the initial value of the sum is 0. Next we have to check for 3. So the initial value of the sum is 0. So sum initialization should be done here, okay, inside the for loop. Next we have to perform the cube of r and add it to some value. So sum is equal to sum plus r cube. R cube can be written as r into r into r. Next, operation on 153 is over. Next we have to perform operation on 15. So how to get 15 from 153? By performing division 10. So n is equal to n by 10. So next value closed. Next we have to check whether this sum value as well as Armstrong value both are same or not. So if sum double is equal to Armstrong, then we can say that it is an Armstrong number. So printf, here we have to display the number only. So printf %d slash n comma display the sum. Suppose if they are not equal, then we can say that it is not an Armstrong number. So close the for loop. Okay. So here let the minimum value is 153. Let the maximum value is some 160. So what is 153? It is an Armstrong number. Let's check whether our logic is correct or not. I is equal to min. So what is I value? 153. So 153 is less than or equal to 160. Condition is true. So n is equal to 153. Next, Armstrong is equal to 153. Next, sum is equal to 0. Okay. Next, in the first iteration, what is sum value? So first, why n not equal to 0? So what is n value? 153. So 153 is not equal to 0. Condition is true. So r value 3. Next, sum is equal to sum plus r cube. So 3 cube means 27. 27 plus 0 means 27. Next, n is equal to n by 10. 153 by 10 means 15. So in the next iteration, n value 15. So once again, control goes to the condition. 15 is not equal to 0. True. R is equal to 15 modulo 10. 15 modulo 10 means 5. Next, sum is equal to sum plus r cube. 27 plus 5 cube means 152. Next, n is equal to n by 10. 15 by 10 means 1. So in the next iteration, n value is 1. 1 not equal to 0. Condition is true. So r is equal to n modulo 10. 1 modulo 10 means 1. Sum is equal to sum plus r cube. 153. N is equal to n by 10. 0. 0 not equal to 0. False. Sum value 153. Armstrong value 153. Both are same. So 153 will be printed. So likewise we can print next to 154, 155 like that. 154 is not an Armstrong number, 155 not Armstrong. Armstrong numbers between 153 to 160 are only 153. So that number will be printed. Okay. So in this way we can print a range of Armstrong numbers by specifying the given range. Now let's see this program. C program to print factorial of a given number. Let the number is 3. The factorial of 3 is 1 into 2 into 3, that is nothing but 6. If you take number as 5, then the factorial of 5 is 1 into 2 into 1 into 2 into 3 into 4 into 5. That is nothing but 1 into 2, 2, 2 into 3, 6, 6 into 4, 24, 24 into 5 means 120. So 120 is the result. Okay. So for that we have to write the program. Let us write the program. While writing the program, this we will see the logic. So here the first statement is hash include stdio.h. Why? Because we are using printf and scanf. Those two are available in stdio. Next, every C program execution starts from main function. Now let's see what are the variables that are needed. Here we need to have a number. For number, let us use n. Next, here how to calculate factorial of a number. We have to start from 1 and we need to continue up to this number. Okay. So for this repetition, first the value is 1, next the value is 2, next the value is 3. So for this repetition, we need to use a loop. In the loop, let us use I. Okay. And next, in order to store the result, we need to have a variable. For storing the result, let us declare a variable called fact. Here we are performing the multiplication operation. So for that, let us declare the initial value of the fact as 1. If you don't perform any initialization, then some garbage value will be stored. Garbage value means unpredictable value. Okay. Whereas if you store 1 here, then by multiplying with 1, the result won't changes. Let the number is 2. So 2 into 1 means 2 only. Let the number is 5. 5 into 1 means 5 only. So if you multiply with 1, then the corresponding result won't changes. So that's why it is better to initialize the value of fact as 1. Okay. Now read a number. Before reading, let us display the message. Printf enter n value, enter a number, so that this message will be printed on the monitor. Next, read the data, read the number, scanf. Here n is of type integer. For integer, the format specified is %d, where d stands for decimal number. Decimal number means integer number, comma %n. Now let's write the logic. Here let us use a for loop. For here we have to start repetition from 1 onwards. Okay. So for I is equal to the initial value of the one I is 1. Okay. Next, we have to perform repetition till we get 5. So 5 is nothing but the value of n. We have to multiply 5 also. So the condition is I is less than or equal to n. Why? Because we need to multiply with 5 also. Suppose if we write the condition as less than, then what will happen is this multiplication with 5 won't done. So only up to 4 will be repeated. But here we need to multiply the fact with 5 also. So that's why we need to write the condition as I less than or equal to n. Okay. Next, after 1 we have to multiply with 2. After 2 with 3. After 3 with 4. So every time we have to increment I value. So I plus plus. So here the logic is very simple. We have to multiply 1 with 1. Next 1 with 2. Next to 2 with 3, next to 3 with 4. So multiply the result of fact with this I value. So the body is fact is equal to fact into I. Fact is equal to fact into I. Okay. So this is the logic here. And now let's check whether our logic is correct or not. We know that execution starts from main function. So printf enter n. Let n value is 5. Next for I is equal to 1. So what is I value? 1. Next 1 is less than or equal to 5. Condition is true. So fact is equal to body will be executed. Fact is equal to fact into I. The initial value of the fact is 1. I value 1. So 1 into 1 means 1. Next to I plus plus. Now I becomes 2. So condition will be evaluated. 2 is less than or equal to 5. Condition is true. So fact is equal to fact into I. Previous value of fact 1, I value 2. So 1 into 2 means 2. Body execution is over. Next I plus plus. Now I becomes 3. One more time condition will be checked. I less than or equal to 5. 3 is less than or equal to 5. Condition is true. So body will be executed. Fact is equal to fact into I. So what is the previous value in fact? 2. I value 3. So 2 into 3 means 6. Now fact value is 6. Next I plus plus. Now I becomes 4. Next condition will be checked. 4 is less than or equal to 5. Condition is true. So body will be executed. Fact is equal to fact into I. Previous value of fact 6, I value 4. 6 into 4 means 24. Now fact value 24. Next I plus plus. I becomes 5. Next condition will be checked. 5 less than or equal to 5. Condition is true. So body will be executed. Fact is equal to fact into I. Fact value 25, I value 5. So 25 into 5 means 120. Next I plus plus. I becomes 6. 6 is less than or equal to 5. Condition is false. So the control comes out from the for loop. So what is the value in fact? Fact 120. So that is nothing but the result of the factorial. So printf factorial of percentage d is percentage d. So what is first percentage d? N. Second percentage d fact. So here factorial of what is first percentage d? N. What is n? 5. So factorial of 5 is what is second percentage d? This fact. So what is fact value? 120. So factorial of 5 is 120 will be printed on the monitor. Here if we want, we can start from 5 and continues till we get 1. That means we can perform like this also. So 5 into 4 into 3 into 2 into 1. That is nothing but 60. So in place of this for loop, we can also write as for I is equal to what is 5? 5 is nothing but the value of n. Semicolon. Here we have to perform the repetition till we get 1. Here we need to multiply with 1 also. So I greater than or equal to 1. So 5 greater than or equal to 1. Next 4 greater than or equal to 1. 3 greater than or equal to 1. 2 greater than or equal to likewise. Next after 5 we have to multiply with 4. After that with 3. So every time we have to perform decrementation. It is our choice. We can either start from 1 and continue till we get 5, or we can start from 5 and continue till we get 1. So in this way we can find out the factorial of a given number. Now let's see about this program. C program to check whether given number is strong number or not. Let's see what is a strong number. The best example for strong number is 145. In 145, what are the digits 1, 4, 5? Let us calculate the factorial of 1, 4 and 5. The factorial of 1 is 1. The factorial of 4 is 24. The factorial of 5 is 120. So let us add all these terms. So 4 plus 1 means 5. 2 plus 2 means 4. 1. So that means this is nothing but the given number. So strong number means the sum of factorials of digits is equals to the given number. So 1 factorial plus 4 factorial plus 5 factorial is nothing but 145. So 145 is nothing but the given number. If you consider 1 or 2, in 1 what are the digits we have? 1 has only one digit, that is 1. So what is the result of 1 factorial? 1. So we can say that 1 is a perfect, 1 is a strong number. Likewise in 2 also we have only one digit, that is 2. The result of 2 factorial is 2. So we can say that 2 is a strong number. So what is the definition for a strong number? The sum of factorials of digits is equals to the given number. Okay. The best example for the strong number is 145. So now we have to write the program for that. So 145. So first from 145 we have to extract either 1 or 4 or 5. But from 145 it is very easy to extract the last digit, that is nothing but 5, by performing modulo operation with 10. So 10 145. So 10 14s are 140. So 145 minus 140 means 5. Modulo will always gives remainder, whereas division will gives quotient. So modulo means 5, whereas division means 14. So now what is the remainder here? 5 is the remainder. And then we have to perform factorial on this remainder. So what is the result of this 5? The result of 5 factorial is 120. So now fact contains 120. Now we have to add this fact to some sum. Let us declare a variable called sum. The initial value of the sum is 0. So 0 plus What is the result of 5 factorial? 120. So 0 plus 120 means 120. So the value of sum is 120. Okay. Next, the operation on 5 is over. Next we have to perform operations on 14. So how to get 14 from 145? By performing division with 10. Now n value is 14. So 10 ones are 10. 14 minus 10 means 4. So now the remainder value is 4. So now we have to calculate the factorial for this 4. So what is the fact of 4 What is the fact of 4? So 4 into 3 into 2 into 1 or 1 into 2 into 3 into 4, that is nothing but 24. Next we have to add this factor to some value. So 120 plus 24 means what? 144. Okay. Next operation on 4 is done. Next we have to perform operation on 1. Okay. So how to get 1 from 14? By performing division with 10. So in the next iteration n value is 1. So 10 zeros are 0. 1 minus 0 means 1. So now the remainder value is 1. So we need to calculate the factorial for 1. So the result of 1 factorial is 1. Next we have to add this factor to some value. So 1 plus 144 means 145. Now n value is 0. So here we have to repeat the loop as long as n is not equal to 0. Okay. Here what is the sum value here? 145. 145 is nothing but the given number. So we can say that 145 is an example for a strong number. Okay. Now let's write the program. So here the first statement is hash include stdio.h. Why? Because we are using printf and scanf functions. Printf and scanf are available in stdio. Next, every C program execution starts from main function. Now let us declare the variables. So what are the variables needed? First a number. For the number let us declare n. Next, what are the variables that we needed? First we have to calculate here some remainder. In order to calculate the remainder, let us use r. Next, for the remainder we need to calculate factorial. So fact. Next we need to add that factorial result to sum. So sum, the initial value of the sum is 0. Okay. So these are the variables which we needed. We need one more variable. Why? Because here in the first iteration the value of n is 145. In the second iteration n value becomes 14. In the third iteration n value becomes 1. Okay. In the next iteration what is n value? 0. But here we have to compare the sum with n value. But what is n value? Whenever the condition is becoming false, n is 0. So we have to store n in a temporary variable. Let the name of the temporary variable is strong. Why? Because we are checking whether the number is strong number or not. Okay. So these are the variables that we needed. Next, first to display the message, printf enter a number. Printf enter n. Next read the number, scanf %d comma %n. So let n value is 145. Next, let us use while loop here. Before that, what we have to do? We have to store this n value in a temporary variable called strong. So strong is equal to n. If strong and sum both are same, then we can say that it is a strong number. If strong and sum, these two are not same, then we can say that it is not a strong number. Okay. If they are same, it is a strong number. Otherwise, not a strong number. Okay. Now let us write the while loop. While. So we have to repeat the loop as long as n is not equal to 0. So while n is not equal to 0, first we need to calculate the remainder. The formula for remainder is n modulo 10. So r is equal to n modulo 10. So next we have to calculate the remainder for 5. Here the initial value of the fact is 1. So while calculating the factorial, in order to store the result, let us use fact. The initial value of the fact is 1. So first we need to, in the first iteration, we need to calculate the factorial for 5. In the next iteration, we need to calculate the factorial for 4. So while calculating 4 also, the initial value of the fact should be 1 only. If you don't perform initialization here, that means if you perform initialization here, then what will happen is, after the first iteration, factorial value is 120, but in the second iteration, 1 will be multiplied with 120, 2 will be multiplied with 120, 3 will be multiplied with 120. Likewise, it will be done. So that's why we have to perform initialization here. Fact is equal to 1. Here we need to calculate the factorial for r. So r, this remainder 5, 4, 1 like that. In order to calculate the factorial, the logic is we have to start from 1 and continue till we get r. So I less than or equal to r. Why? Because we are calculating the factorial for r. 5, 4, 1 dot for n, I plus plus. So the logic here is fact is equal to fact into I. So calculation of the factorial is over. Next we have to add this factorial to sum. So the statement is sum is equal to sum plus fact. Here the for loop contains only one statement. So curly braces are optional, not compulsory. So sum is equal to sum plus fact. In the next iteration, the value of n is 14. So how to get 14 from 145? N is equal to n by 10. N is equal to n by 10. Next we have to check whether strong and sum both are same or not. So here the condition is if strong double is equal to sum, then we can say that it is strong number. So printf strong number, printf strong number, else we can say that it is not a strong number. So printf not a strong number. Okay, not a strong number. Next, close the main function. Now let's check whether our logic is correct or not. So here the initial value, enter n, the initial value of n is 145. So next, strong is equal to n. So what is strong value now? N value. So what is n? 145. Next, while n is not equal to 0, n value is 145. So 145 is not equal to 0. Condition is true. So r is equal to n modulo 10. So 145 modulo 10 means 5. So r is equal to 5. R is equal to 5. So next we have to calculate the result of 5 factorial. So for that, initially we have to assign 1 as fact value. So fact is equal to 1. Next, for I is equal to 1, 1 is less than or equal to r. So 1 is less than or equal to what is r? 5. So 1 is less than or equal to 5. Condition is true. So fact is equal to fact into I. So fact value 1, I value 1. So 1 into 1 means 1. Next, I plus plus. I becomes 2. 2 less than or equal to 5. Condition is true. So fact is equal to fact into I. So 1 into 2 means 2. Next, I becomes 3. 3 less than or equal to 5. 2. So 2 into 3 means 6. Next, it becomes 4. 4 into 6 means 24. Next, it becomes 5. 5 into 24 means 120. Next, I become 6. 6 is less than or equal to 5. Condition is false. What is the result of this f value? 120. So now fact is 120. Next, sum is equal to sum plus fact. The initial value of the sum is 0. So 0 plus fact. What is fact value? 120. So 0 plus 120 means 120. Next, n is equal to n by 10. 145 by 10 means 14. So now n value is 14. So once again control goes to the condition. While n is not equal to 0. 14 is not equal to 0. Condition is true. R is equal to n modulo 10. 14 modulo 10 means 4. Next, by using this for loop, we can calculate the factorial. What is the result of 4 factorial? 24. So now fact value is 24. Sum is equal to sum plus fact. So 120 plus fact value 24. So 120 plus 24, 144. Next, n is equal to n by 10. 14 by 10 means 1. So now n value is 1. So once again control goes to the condition. N not is equal to 0. N value 1. 1 is not equal to 0. True. R is equal to n modulo 10. 1 modulo 10 means 1. Next, fact is equal to 1. What is the result of 1 factorial? 1. Sum is equal to sum plus fact. 144 plus 1 means 145. Next, n is equal to n by 10. 1 by 10 means 0. Once again control goes to the condition. 0 is not equal to 0. Condition is false. So the control comes out from the while loop. Strong value 145. Sum value 145. Both are same. So we can say that it is a strong number. So in this way we can check whether a number is strong number or not. And now let's see this program. C program to print strong numbers within the given range. First let's see what is a strong number. Strong number means the sum of factorials of digits is equals to the given number. Let the number is 145. So the digits in 145 are 145. 1 factorial means 1. 4 factorial means 24. 5 factorial means 120. So 120 plus 24 plus 1 is nothing but 145. So 145 is nothing but the given number. So what is a strong number? The sum of factorials of digits is equals to the given number. Suppose here the minimum value is 1, maximum value is some 10,000. So this program has to display the strong numbers between 1 to 10,000. If we calculate mathematically, then it requires hours and hours of time. Whereas with the help of a simple program, we can display a list of strong numbers by specifying the given range. First, let's see the logic for this strong number. After that, we will write the program in order to display a list of strong numbers by specifying the given range. From 145, we have to extract 1 or 4 or 5. But from 145, it is very easy to extract the last digit, that is nothing but 5, by performing modulo 10 operation. So 10, 145, 10 14s are 140. So 145 minus 140 means 5. Okay. So what is the remainder value here? 5 is the remainder value. Let us take a variable called sum. The initial value of the sum is 0. Why? Because by adding 0 to any value, the result won't changes. 0 plus 5 means 5 only. Next 0 plus 30 means 30 only. So that's why the initial value of the sum is 0. Next we have to calculate factorial for 5. The factorial of 5 is 120. So 120 plus 0 means 120. So now there is no need of 5 in the next iteration. So in the next iteration, the value of n should be 14 only. How to get 14 from 145? By performing division 10. So in the next iteration, the value of n is 14. So 10 ones are 10, 14 minus 10 means 14. Now the modulo result is 14. Now the remainder value is 4. So we have to calculate the factorial of 4. What is the factorial of 4? 24. So 24 should be added to sum. 120 plus 24 means 144. Now in the next iteration, there is no need of for. There is no need of 4. Why? Because already operation on 4 is over. So next we have to perform operation on 1. So how to get 1 from the 14? By performing division 10. So now perform operations on 1. So 10 zeros are 0. 1 minus 0 means 1. So now the remainder value is 1. So what is the factorial of 1? 1 only. So add 1 to 144. So that is nothing but 145. In the next iteration, n will become 0. So we have to repeat the loop as long as n is not equal to 0. So whenever n becomes 0, then we can quit from the while loop. So let's write the program. While writing the program, we will discuss the logic in detail. Here the first statement is hash include stdio.h. stdio.h. Why? Because we are using printf and scanf. Both are available in stdio. Next, every C program execution starts from main function. Next, to declare the variables. Here the input variables are min comma, max comma. Let us store the corresponding minimum values in a variable called n. Next, we have to calculate remainder. For remainder, let us use r, where r stands for remainder. Next, in order to calculate the factorial, let us use a variable called fact. Next, we have to add the corresponding factorial result to the sum. So let us declare a variable called sum. So next, in order to calculate the factorial, let us use a variable called I. Next, if there is any need of any other variable, we will declare those variables. Next, first display the message before reading the data. So printf enter min and max values. Printf enter min and max values. And next, read min and max value. Here min and max are of type integer. For integer, the format specified is %d, where d stands for decimal number. Here we have two %ds. Why? Because we are reading two numbers. The first number is min, ampersand min comma ampersand max. Okay. Next, write the for loop. So first we have to check whether 1 is strong or not. Next to 2 is strong or not. Next to 3 is strong or not. Next up to 10,000. We have to check 10,000 also. So the initial value of the I is 1. Next, up to 10,000. So we have to write I less than or equal to, what is the condition? What is 10,000? 10,000 is nothing but max. If we use only less than condition, then 10,000 won't be compared. Okay. Next, I plus plus. So first we have to check for 1, next for 2, next for 3, next for 4, likewise up to 10,000. Okay. So next, what is the other variable? We have to store this 1. What is this 1? This 1 is nothing but minimum value. So for I is equal to min, I less than or equal to max, I plus plus. Okay. Next we have to store I value in a number called n. So n is equal to I. Here the problem is in the first iteration n value 145, in the second iteration n value 14, in the next iteration n value 1, next iteration n value 0. So whenever the condition is becoming false, the value of n is 0. Okay, but here what we have to do, we have to compare sum and n. Here the value of sum is 145 only, but n value is 0. So we have to store n in a temporary variable. So for that, let us declare one more variable, that is strong. Next, in order to calculate the factorial, let us use a variable called j. So strong is equal to n. So strong contains n value, that is nothing but 145. Now perform the operation on the number. So while n is not equal to 0, so first we have to calculate the remainder. So what is the formula for remainder? R is equal to n modulo 10. Next we have to calculate the factorial for remainder. So the initial value of the fact is 1. So first to calculate factorial for 5. In the next iteration we have to calculate factorial for 4. In the next iteration we have to calculate factorial for 1. So the initial value of the fact should be 1. Next to calculate the factorial for r. So for j is equal to 1, j is equal to r, j plus plus. For j is equal to 1, j less than or equal to r, j plus plus. Next we know the logic for the factorial. So fact is equal to fact into j. So now factorial result is available in variable called fact. So now we have to add that fact to sum. So here sum is already declared. The initial value of the sum is 0. Okay. So add sum to fact. So sum is equal to sum plus fact. Next operation on 145 is over. Next we have to perform operation on 14. So how to get 14? N is equal to n by 10. Okay. So this is the logic which we use for checking whether it is strong number or not. Next to check whether strong and sum both are same or not. If strong double is equal to sum, then we can say that it is a strong number. So printf percentage is slash n comma strong. Otherwise it is not a strong number. So there is no need to display any message. Close the for loop, close the main function. Now let's check for one number. Here let the minimum value is 145, whereas let the maximum value is 2000. So it has to display the strong numbers between 145 and 2000. So for I is equal to mean, so what is mean? 145. So 145 is less than or equal to 2000, condition is true. Next n is equal to I. What is I? 145. Next strong is equal to 145. So strong is equal to 145. So what is the value of the sum? Sum is 0. So n value 145, strong value 145, sum value 0. Next while n is not equal to 0, so 145 is not equal to 0, true. R is equal to 145 modulo 10. 145 modulo 10 means 5. Fact is equal to 1. So this for loop calculates the factorial of a given number. We know the logic for the factorial. So 1 into 2 into 3 into 4 into 5. That is nothing but factorial of 5. That is nothing but 120. So add 120 to sum. So sum is equal to 0 plus 120. That is nothing but 120. N is equal to n by 10. 145 by 10 means 14. So once again control goes to the condition. While 14 is not equal to 0, true. So R is equal to 14 modulo 10. 14 modulo 10 means 4. Next fact is equal to 1. So these statements calculates the factorial of 4. What is the factorial of 4? 24. So 24 plus 120 means 144. Sum is equal to sum plus fact. So 140, already it is added. Next n is equal to n by 10. So n value is 14 by 10 means 1. Okay. Next while n is not equal to 0. 1 is not equal to 0, 2. R is equal to n modulo 10. Now R is 1. Now calculate factorial of 1. Factorial of 1 is 1. Next add fact to sum 145. N is equal to n by 10. 1 by 10 means 0. 0 is not equal to 0, 2. What is strong value? 145. What is sum value? 145. Both are same. So 145 will be printed. Likewise, we have to check for 146, 147 up to 2000. So in this way, we can display a list of strong numbers within the given range. Now let's see the next program. C program to check whether given number is a perfect number or not. A perfect number means if the sum of factors of a number is equals to the given number, then we can say that it is a perfect number. Okay. Let's see the definition for a perfect number. Sum of factors of a number. Sum of factors of a number, excluding that number. We should not consider the corresponding number. Excluding that number. Excluding that number. is equals to the given number. The sum of factors of a number excluding that number is equals to the given number. Is equals to the given number. Then we can say that it is a perfect number. Okay. Let's take an example here. Let us consider 6. What are the factors for 6? The factors for 6 are 1, 2, 3, 6. But we should not consider that number. So don't consider 6. So the factors for 6 are 1, 2, 3. So what is the sum of 1, 2, 3? The sum of 1, 2, 3 is nothing but 6 only. So 6 is nothing but the given number. So we can say that 6 is a perfect number. So what is a perfect number? The sum of factors of a number is equals to the given number. But while calculating the sum, we should not consider that number. Okay. Let us take one more example. If we consider 28, what are the factors for 28? The factors for 28 are 1, 2, 4, 7, 14, 28. But we should not consider 28. Okay. So 1 plus 2 means 3. 3 plus 4 means 7. 7 plus 7 means 14. 14 plus 14 means 28. So that is nothing but the given number. 1 plus 2 plus 4 plus 7 plus 14 is nothing but 28. 14 plus 7, 21. 21 plus 4, 25. 25 plus 2, 26. 21, 25. 21, 25. 27 plus 1. That is nothing but 28. Okay. So for that we have to develop the program. Okay. Here if we consider 6, then we need to calculate the factors for 6. So what is the minimum factor for any number? The minimum factor for any number is 1, whereas the maximum factor is that number, that is nothing but 6. So 1, 2, 3, 4, 5, 6. So we have to calculate the factors like this. But what is a perfect number? We should not consider that number. That means we should not consider 6. But before 6, what is the next factor? For any number, the maximum factor excluding that number is n by 2. If we consider 28, the maximum factor for 28 is 14. Okay. If you don't include that number. Okay. So what is the maximum factor here? 14 only. Likewise, if you consider 6, then the maximum factor for 6 is, what is 6 by 2? 3 only. Likewise, if you consider any even number, let us consider some 50. So what is the maximum factor for 50? If you don't consider 50, then it is 50 by 2. That is nothing but 25. If you consider 10, then what is the maximum factor for 10? Other than 10, 10 by 2. That is nothing but 5 only. Okay. So that means if the number is 6, then we have to compare, then we have to determine the factors up to 3 only. Okay. Here it is better to take 28 so that we will get more number of factors. So for 28 we have to determine the factors. So 1 next to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Why? Because here what is n value? N value is 28. But here we should not consider 28. So what is the next maximum factor? 28 by 2. That is nothing but 14 only. 14 into 2 is nothing but 28. After 14 the next factor is 28. But we should not consider 28. Okay. So how to check whether it is factor or not? By performing modulo operation. 28 modulo 1, 28 modulo 2, 28 modulo 3. Likewise, if we perform modulo operation, if the remainder is 0, then we can say that it is a factor. Suppose if the remainder is not equals to 0, then we can say that it is not a factor. 28 modulo 10, 28 modulo 1. What is the result? 128s are 28. Modulo will always gives remainder. So what is the remainder? 0. So we can say that 1 is a factor. So likewise, if we consider 2, so 28 modulo 2, so 2 28. 2 14s are 28. So what is the result? 0. So we can say that 2 is also a factor. If you consider 3, 28 modulo 3, 3 9s are 27. So 28 minus 27 means 1. So here the remainder is 1. So we can say that 3 is not a factor. So likewise we have to calculate the factors. Initially we have to take a variable called sum. The initial value of the sum is 0. If it is a factor, then you add that number to the sum. So what is 1? 1 is a factor. So you add 1 to sum. So now sum value is 0 plus 1 means 1. Next, what is 2? 2 is a factor. So you add 2 to sum. So 1 plus 2 means 3. Next, 3 is not a factor. So there is no need of adding. 4 is a factor. So you add 4 to the sum. 3 plus 4 means 7. 5 is not a factor. So no need of adding. 6 is not a factor to 28. No need of adding. Then 7. 7 is a factor to 28. So we have to add 7 to the sum. 7 plus 7 means 14. 8 is not a factor to the sum. 8 is not a factor to 28. 9 is not a factor. 10 is not a factor. 11 is not a factor. 12 is not a factor. 13 is not a factor. Whereas 14 is a factor. So we have to add 14. 14 plus 14 means 28. So here now next there is no need to compare for 15. Okay. Why? Because the maximum factor is n by 2. 28 by 2 means 14 only. So what is some value? 28. What is the given number? 28. Both are equal. So we can say that 28 is a perfect number. Now let's write the program. Here the first statement is hash include stdio.h. Why? Because we have to use printf and scanf functions. Printf and scanf are available in stdio. Next, every C program execution starts from main function. So main. So what are the variables which are needed here? Int. We need to have n. Next, in the for loop for iterations we require some I. Next, sum is equal to 0. The initial value of the sum is 0. Okay. First read n value. So before reading value, display some message on the monitor. Printf enter n. Printf enter n. Next, scanf. Here n is of type integer. For integer, the format specified is %d, where d stands for decimal number. Decimal number is nothing but integer number only. Okay. Next, for here what is the minimum factor? 1 is the minimum factor. So for I is equal to 1. Next, what is the maximum factor? 14. What is 14? 14 means n by 2. Here we have to compare this 14 also. So here the condition is less than or equal to I less than or equal to n by 2. I less than or equal to n by 2. If you take 6, then the maximum factor other than 6 is 3. That means we have to consider this 3 also. So the condition is I less than or equal to n by 2. If we include only less than, that means if you don't include is equal to, then what will happen is only up to 13 only the numbers will be compared. But we have to consider 14 also. So I less than or equal to n by 2. Next, I plus plus. So next, check whether I is factor or not. So how to check whether it is a factor or not? If n modulo I double is equal to 0, then we can say that it is a factor. If it is a factor, then we have to add I to sum. Whenever the condition is false, this for loop condition is false, then check whether n and sum are equal or not. If n double is equal to sum, then we can say that it is a perfect number. So printf a perfect number. Printf perfect number. If n is not equals to sum, then we can say that it is not a perfect number. So else printf, we can say that it is not a perfect number. Okay. Now let's check whether our logic is correct or not. Next, close the main function. The initial value of the sum is 0. Printf enter n, scanf %d comma %n. Let the n value is 6. Let n is equal to 6. So for I is equal to 1, 1 is less than or equal to n by 2. So 6 by 2 means 3. So 1 is less than or equal to 3. Condition is true. If n modulo I double is equal to 0. So what is n? 3. I value 1. What is the result of 3 modulo 1? 0. 0 double is equal to 0. Condition is true. So sum is equal to sum plus I. Sum value 0, I value 1. So 0 plus 1 means 1. Next, I plus plus. Now I becomes 2. 2 is less than or equal to 3. Condition is true. Next, if 3 modulo 2 double is equal to 0. I'm sorry, what is n here? 6. If 6 modulo 2 double is equal to 0. Condition is true. So sum is equal to sum plus I. Sum value 1, I value 2. So 1 plus 2, 3. Next, I plus plus. Now I becomes 3. 3 is less than or equal to 3. Condition is true. If n modulo I double is equal to 0, n value 6, I value 3. 6 modulo 3 means 0 only. 0 double is equal to 0. Condition is true. So sum is equal to sum plus I. So some value 3, I value 3. So 3 plus 3, 6. Next I plus plus, I becomes 4. 4 is less than or equal to 3. Condition is false. So control comes out from the for loop. N value 6. Some value 6. 6 double is equal to 6. Condition is true. So perfect number message will be printed on the monitor. Let n value is 8. Then what we have to do? We have to check whether 1, 2, 3, 4 are factors or not. Why? Because if the number is n, then we have to check up to n by 2. That means up to 8 by 2 means up to 4. If it is a factor, then we add it to sum. What is the initial value of sum? 0. 8 modulo 1. Result is true. So you add 1. 8 modulo 2. Factor. You add 2 to sum. 1 plus 2, 3. 8 modulo 3. Not a factor. 8 modulo 4. Factor. So 4 plus 3 means 7. So what is sum value? 7. N value 8. So n is not equal to sum. So we can say that 8 is not a perfect number. In this way we can check whether given number is perfect number or not. And now let's see this program. C program to print perfect numbers within the given range. Let's see what is a perfect number. Perfect number means the sum of factors of a number excluding that number is equals to the given number. If you take 6, the factors for 6 are 1, 2, 3, 6. But we should not consider 6. We have to exclude this number. So what is the sum of 1, 2, 3? 1 plus 2 plus 3 means 6. So 6 is nothing but the given number. So we can say that 6 is a perfect number. If we consider 9, what are the factors for 9? 1, 3, 9. But we should not consider 9. So if we add these two factors, 1 plus 3. 1 plus 3 means 4. 4 is not equals to 9. So we can say that 9 is not a perfect number. Let us consider 28. The factors for 28 are 1, 2, 4, 7, 14, 28. But we should not consider 28. So what is the sum of these factors? 1 plus 2, 3, 3 plus 4, 7, 7 plus 7, 14, 14 plus 14, 28. So 28 is the sum here. So we can say that 28 is a perfect number. So now if the here we need to display the perfect numbers within the given range. Let the minimum value is 6, maximum value is 30. The perfect numbers between 6 and 30 are 6 and 28. So we should display 6 and 28 as the output. Okay. Suppose if the minimum value is 1, maximum value is some 20,000. Then this program has to display the perfect numbers between 1 and 10,000. If we calculate mathematically, then it will take hours and hours of time. Okay. Whereas with the help of a simple program, we can display a range of perfect numbers by specifying minimum value and maximum value. Okay. First, before writing the program, let's see the logic for the perfect number. If you take 6, 6 is a perfect number, but we should not consider 6 here. Okay. So here we know that the minimum factor for any number is 1. Whereas the maximum factor for that number is that number. So what is the number here? 6. So the minimum factor is 1, whereas the maximum factor is 6. Okay. So what are the factors here? 1, 2, 3, 4, 5. So the factors are from 1 to 6. So we have to check whether there is any factor from 1 to 6 or not. If there is such factor, then we have to add that to some sum. Okay. And next here we should not consider this number. So before this digit, what is the next factor? If you take any number, then the maximum factor excluding that number is n by 2. If you take 6, then the maximum factor other than 6 is 3 only. After 3 we don't have any factors. If you take 12, then the maximum factor other than 12 is 12 by 2, 6. If you take some 10, the maximum factor other than 10 is 10 by 2, that is nothing but 5. If you take 30, the maximum factor other than 30 is 30 by 2, 15. Okay. So here we need to check only up to 3 only. Okay. So we have to check whether 1 is a factor or not, next to 2 is a factor or not, next 3 is a factor or not. If it is a factor, then add it to the sum. Okay. Add it to the sum. Okay. Let us take 28 so that we can get the perfect area. So 28. So what are the factors for 28? So the minimum factor is 1, whereas the maximum factor is 28. But here we are not considering that number 28. So the maximum factor is 28 by 2. That is nothing but 14. So we have to determine the factors from 1 to 28. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have to check one is a factor or not. So how to check whether it is a factor or not? Simply perform the operation modulo. 28 modulo 1, 28 modulo 2, 28 modulo 3. So likewise 28 modulo 4, likewise up to 28 modulo 14. If the remainder is 0, then we can say that it is a factor. If we take 28 modulo 1, so 128. 128 are 28. So 28 minus 28 means 0. So here the remainder value is 0. So we can say that 1 is a factor. If it is a factor, then add that factor to a variable called sum. The initial value of the sum is 0. Why? Because by adding 0, the result won't changes. If you don't perform any initialization, then initially some garbage value will be stored in sum. Garbage value means some unpredictable value. Suppose let it be some 1000. So 0 will be added to 1000. So we should not get any number as the perfect number. Okay. So sum is equal to 0 plus 1 is a factor. So add 1 to sum. So 0 plus 1 means 1. Next check whether 2 is a factor or not. So 2 28. 2 14s are 28. 28 minus 28 means 0. Okay. Here the remainder is 0. So we can say that 2 is a factor. So add 2 to sum. The previous value of sum is 1. So 1 plus 2 means 3. Next check whether 3 is a factor or not. So 3 28. 3 9s are 27. 28 minus 27 means 1. So here the remainder is not equals to 0. So we can say that 3 is not a factor. So there is no need to add 3 to sum. Okay. Next 4. 4 is a factor. So add 4 to sum. 4 plus 3 7. 5 is not a factor. 6 is not a factor. 7 is a factor. So add 7 to sum. 7 plus 7 means 14. 8 is not a factor. 9 is not a factor. 10 is not a factor. 11 not. 12 not. 13 not. 14. 14 is a factor. So add 14. 14 plus 14 means 28. So we can say that 28 is a perfect number. So for that we have to write the program now. So let's write the program. So while writing the program we will see more logic. So the first statement is hash include stdio.h. Why? Because we have to use printf and scanf functions. Printf and scanf are available in stdio. Next, every C program execution starts from main function. Next, let us declare the variables. Here the input variables are min, max. Next, we need to store min in a number. So for that, let us declare n. Next, we need to have a variable called sum. Next, in the for loop, in order to perform the operations, we need to have a variable called I. If there are any extra variables needed, then while writing the program, let us declare those variables. We need to have one more variable, that is say. Okay. Next, display the message. Printf enter minimum and maximum values. So before reading the data, just display this message. Enter min and max values. Next, scanf. Here min and max are of type integers. So for integer, the format specified is %d. So %d, comma ampersand min, comma ampersand max. So let minimum value is 6, maximum value is 30. So we need to find out the perfect numbers between 6 and 30. The perfect numbers between 6 and 30 are 6 and 28. Okay. Next, let us write the outermost for loop. Here the outermost for loop is for repetition purpose. We have to check whether 6 is a perfect number or not. Next, 7 is a perfect number or not. Next, 8, 9 up to 20. So we have to check whether 30 is also a perfect number or not. So the condition should be I less than or equal to max. If you use only less than, then 30 will not be checked. Okay. Next, after 6 we have to check for 7. Next, after that we have to check for 8. So every time we have to perform the incrementation operation. Okay. Next, we need to store this I value in a number called n. So n is equal to I. So now n contains the minimum value. So what is the minimum value? 6. So for every number we have to check whether it is perfect number or not. So the initial value of the sum is 0. So for every number the initial value of the sum is 0. Okay. Next, we have to check whether it is whether n is perfect number or not. Okay. So what is the minimum factor? 1. What is the maximum factor? n by 2. So for that, write the for loop. So what is the initial factor? 1. So for j is equal to 1, j less than or equal to So we have to search for 14. What is 14? 28 by 2. So we have to write less than or equal to. If we write only less than, then 14 won't complete. So j less than or equal to n by 2. Next semicolon j plus plus. So next we have to perform the operations 28 modulo 1, 28 modulo 2, 28 modulo 3, like that. This 28 is available in n, whereas 1, 2, 3 are available in j. So here the condition is if n modulo j double is equal to 0. If n modulo j double is equal to 0. So what is n value? Initially n value is 28. So 28 modulo 1 double is equal to 0. If it is a factor, then what we have to do? We have to add it to sum. So sum is equal to sum plus factor is nothing but j value. So sum is equal to sum plus j. Next, whenever this condition is false, then check I value and sum value, or n value and sum value. Suppose if n and sum both are same, then we can say that it is a perfect number. If it is a perfect number, then print the value. So printf %d slash n comma sum. If it is not a perfect number, then there is no need of any printing. Next to close the for loop, next to close the main function. Let's check for 6 here, from 6 to 30, check whether 6 is a perfect number or not. So for I is equal to, what is the minimum value? 6. Next n is equal to 6, sum is equal to 6. N is equal to 6, sum is equal to 0. Okay. Next for j is equal to 1, 1 is less than or equal to 6 by 2. 6 by 2 means 3. Okay. Next n modulo j. So what is n modulo j? N means 6, j means 1. 6 modulo 1, condition is true. So add 1. 6 modulo 2, condition is true. Add 2. 6 modulo 3, condition is true. So add 3. Next to j plus plus, j becomes 4. 4 less than or equal to 3, false. Next check n and sum. N is 6, sum is 6. So both are same. So display sum value or display n value. Why? Because here both are same only. But it is better to write n. So 6 will be printed. Next I plus plus. Now I becomes 7. Okay. Now n becomes 7. I becomes 7. Next n becomes 7. Next the initial value of the 7 is the initial value of the sum is 0. Next for 1 to 7 by 2 means 3. 7 by 2 means 3, because integer by integer will always gives integer. 7 modulo 1, condition is true. So add 1. 7 modulo 2, false. 7 modulo 3, false. So sum value 1. Whereas what is n value? What is n value? 7. 7 double is equal to 1, false. So 7 won't be printed. So likewise 8 won't print, 9 won't print, 28 will be printed. Why? Because what are the factors for 28? Already we calculated. Okay. So in this way we can print the perfect numbers within the given range. Now let's see this program. C program to generate Fibonacci sequence up to n. We know what is the Fibonacci sequence. The first two terms are 0 and 1. We will get the next term by adding its previous two terms. So here the previous two terms are 0 and 1. So 0 plus 1 means 1. So the next term is 1. So its next term is addition of its previous two terms. That is nothing but 1 plus 1, 2. Next term 1 plus 2, 3. Next term 3 plus 2, 5. Next term 5 plus 3, 8. Next one 8 plus 5, 13. So likewise the Fibonacci sequence will be continued. So in this example our target is we have to print Fibonacci sequence up to n. Suppose let the number is 5. Then this is the output. Why? Because what is the next Fibonacci number? 13 plus 8 means 21. But here we have to print up to 15 only. So this is the output which we have to display. Here the logic is very simple. 0 will be taken as the first term. That means let f1 is equal to 0. Next 1 will be taken as the next term. Let f2 is equal to 1. So first we have to print f1 as well as f2 values. And next we need to calculate f3. What is the formula for f3? f3 is equal to f1 plus f2. 0 plus 1 means 5. So here what is the value here? 13. So we have to check whether f3 is less, here n value is 5. Let n value is 5. We have to check whether f3 is less than n or not. If f3 is less than n, then print the corresponding term and add its previous two terms. Okay. So here what is f3? 1. So 1 is less than 15. Already 0 is printed, 1 is printed. That means this F1 is printed, F2 is printed. Next F3 is calculated. So F3 is less than n, condition is true. So we have to print F3. So next what we have to do, we need to add these two terms. Okay. So how to add these two terms? These two terms are nothing but F2 and F3 values. Here we have to copy F2 value into F1, F3 value into F2. Okay. So copy, what is F2 value? 1. So 1 should be copied to F1. Next, what is F3 value? 1. So this 1 should be copied to F2. Now calculate F3. So what is the formula for F3? F3 is equal to F1 plus F2. So 1 plus 1 means 2. So that means these two terms are added. So the next term is 2. So what is the F3 value now? 2. So 2 is less than 15. Condition is true. So this term is also printed. So now one more time what we have to do? We have to copy this F2 to F1 value, F3 to F2. So what is F2? 1. So 1 will be copied to F1. Next what is F3? 2. So 2 will be copied to F2. Now calculate F3. F3 is equal to F1 plus F2. So 1 plus 2 means 3. So 3 is less than 15. Condition is true. So what will happen? 3 will be printed. Next, once again we have to copy F2 to 2. What is F2 value? 2. So 2 will be copied to F1. Next copy F3 value to F2 variable. 3. Next F3 is equal to F1 plus F2. So 2 plus 3 means 5. 5 is less than 15. Condition is true. So 5 will be printed. So likewise we have to print the Fibonacci series. Let's see the logic. If we see the logic, then we will get the perfect idea about the program. Here the first statement is hash include stdio.h. Why? Because we are using printf and scanf. Those two are available in stdio. Next, C program execution starts from main function. Next, here the input variables are a number n, next f1, next f2, next f3. So f1 means first term, f2 means second term, f3 means sum of its previous two terms. Here the input variable is a number. Before that display some message, printf enter n. So we have to print Fibonacci sequence up to n. Next scanf, n is of type integer. For integer the format specified is %d, comma %n. Okay. So what is the first term in the Fibonacci sequence? 0. So f1 is equal to 0. Next second term in the Fibonacci sequence 1. So f2 is equal to 1. Now what we have to do? We have to print f1 as well as f2 value. So printf %d. Then after that display some tab space /d %d comma. Here first %d means f1, second %d means f2. So f1 comma f2. So f1 value will be printed as well as f2 value will be printed. Next we have to calculate f3. The formula for f3 is equal to f1 plus f2. Next we have to check whether f3 is less than n or not. Here we need to display that n value also. So it is better to write the condition as less than or equal to, while f3 is less than or equal to n. That means if n value is 8, then we have to print that 8 also. Okay, 8 is a Fibonacci number. Okay, if you use is equal to, if you don't use is equal to, then 8 won't print it. Okay, so if this condition is true, then what we have to do? We have to copy f2 value to f1. Before that, first to display f3 value. If this condition is true, then display f3 value. So already a number is printed here. So we need to have a tab space. So /d %d comma. So what is the variable here? f3 is the variable. Next copy f2 value to f1, f3 value to f2, and then calculate f3. So f1 is equal to f2. Next f2 is equal to f3. Next f3 is equal to, what is the formula for f3? f3 is equal to f1 plus f2. Next close the while, next close the main function. Now let's check whether our logic is correct or not. Let here the number is 8. So the output should be 0, 1, 1. Next 2, 3, 5, 8. Let's check whether our logic is correct or not. f1 is equal to 0, f2 is equal to 1. So f1 value 0, f2 value 1. Okay. Next, print of percentage d slash d percentage d comma f1 comma f2. So what is f1 value? So what is f1 value? F1 value is 0, f2 value is 1. So 0 and 1 we have to print them. So 0 will be printed. Next 1 will be printed. Okay. Next, f3 is equal to f1 plus f2. So what is the formula for f3? f1 plus f2. So f1 value 0, f2 value 1. So 0 plus 1 means 1. So now f3 value is 1. So here what is the condition? f3 is less than or equal to 8. 1 is less than or equal to 8. Condition is true. So the body will be executed. Printf slash d percentage d comma f3. So what is f3 value? 1. So this one will be printed. So next we have to copy this f2 to, this is nothing but f1, this is nothing but f2, this is nothing but f3. We have to copy this f2 to f1, this f3 to f2. Okay. f1 is equal to f2. So what is f2? 1. So 1 should be copied to f1. Okay. Next, what is f2? f2 means f3. f2 is equal to f3. That means f3 value should be copied to f2 variable. So 1. Next, f3 is equal to f1 plus f2. So 1 plus 1 means 2. So once again control will be transferred to the condition. While f3 is less than or equal to n. So f3 value is 2. So 2 is less than or equal to 8. Condition is true. Okay. So the body will be executed. So f3 value will be printed. What is f3 value? 2. So 2 will be printed. Next, f1 is equal to f2. So what is f2 value? 1. So now f1 value 1. Next, f2 is equal to f3. What is f3 value? 2. So now f2 value 2. f3 is equal to f1 plus f2. 1 plus 2 means 3. Okay. So one more time condition will be evaluated. While f3 is less than or equal to 8. f3 value 3. 3 is less than or equal to 8. Condition is true. So 3 will be printed. Next, f1 is equal to f2. So now f1 becomes 2. f2 is equal to f3. f2 becomes 3. f3 is equal to f1 plus f2. 2 plus 3 means 5. So one more time condition will be evaluated. f3 value is 5. So 5 is less than or equal to 8. Condition is true. So 5 will be printed. Next, f1 is equal to f2. f1 value 3. f2 is equal to f3. 5. f3 is equal to 8. So one more time condition will be evaluated. 8 is less than or equal to 8. Condition is true. So 8 will be printed. Next, f1 is equal to 5. f2 is equal to 8. f3 is equal to 13. So 13 is less than or equal to 8. Condition is false. So the control comes out from the value. So this is the Fibonacci series which we have to print. So in this way we can generate Fibonacci sequence up to the given number n. Now let's see this program. C program to print first n terms of the Fibonacci sequence. We know what is a Fibonacci sequence. The first term of the Fibonacci sequence is 0. Next term is 1. The next term is addition of the first two terms. So 0 plus 1 means 1. Next term, sum of its previous two terms. So 1 plus 1 means 2. Next term, 1 plus 2, 3. Next term, 2 plus 3, 5. Next term, 5 plus 3, 8. Next one, 8 plus 5, 13. Next one, 13 plus 8, 21. So in this example, our aim is we have to print the first n terms of the Fibonacci sequence. Let n value is 5. Then we have to print the first 5 terms of the Fibonacci sequence. So 1, 2, 3, 4, 5. So this is the output. Suppose let n value is some 7. Then we have to print the first 7 terms of the Fibonacci sequence. So this is the output. Suppose if n value is 9, then this is the output. So we have to print like this. First let's see the logic here. The first term of the Fibonacci sequence is 0. So f1 is equal to 0. Next term of the Fibonacci sequence is 1. Here let n value is 5. So what is the next term? 1. So f2 is equal to 1. So first we have to print these two terms. Next we need to calculate f3. The formula for f3 is f1 plus f2. So what is f1? 0. What is f2? 1. So 0 plus 1 means 1. So here already how many numbers are printed? 2 numbers are already printed. So we need to take a variable called count. The initial value of the count is 0. If count is less than or equal to n, here what is n? 5. So 3 is less than or equal to 5. Condition is true. So one more time we have to add these two terms and print the corresponding number. Next 4 is less than or equal to 5. So the next term will be printed. 5 is less than or equal to 5. The next term will be printed. So likewise we have to continue the process. Let's see the logic while writing the program. The first statement is header file. Here we have to use stdio.h header file. So hash include stdio.h. Next, every C program contains main function. Next, the variables are int n comma f1 comma f2 comma f3 comma count. Okay. Next, here the input variable is a number, but before reading the number, let us display message. So printf enter n. Next, read the number with the help of scanf function. So scanf %d comma %n. So what is the first term of the Fibonacci sequence? 0. So f1 is equal to 0. The second term of the Fibonacci sequence is 1. So f2 is equal to 1. So we have to print f1 value as well as f2 value. So printf %d slash t %d slash t comma. So display f1 value, f2 value. So that means the first number is printed, second number is printed. Suppose if n value is 5, then how many numbers we have to print? We have to print third number, fourth number and fifth number. So the initial value of the count is 3. Why? Because already two numbers are printed. So we need to start printing from third number onwards. So here before writing the condition, let us calculate f3. What is the formula for f3? f3 is equal to f1 plus f2. Why? Because the next term is sum of its previous two terms. Okay. Next we have to check whether this count is less than or equal to n or not. If it is less than or equal to n, then we can display f3 value. If it is less than or equal to 1, less than or equal to n, then we can display f3 value. Then what we have to do is we have to copy f2 value to f1 variable. Next f3 value to f2 variable. Next calculate f3. f3 is equal to f1 plus f2. Next increment the count value. So count plus plus. Next close the value. Next close the main function. So here what are the statements? f1 is equal to f2. f2 is equal to f3. f3 is equal to f1 plus f2. Next increment count. So count plus plus. So here the statements are count plus plus. Here the statement is count plus plus. Next we have to close this while loop. So close the while loop. Next close the main function. So this is the logic here. Now let's check whether our logic is correct or not. We know that execution of a program starts from main function. Enter n. So that n value is 5. Next f1 is equal to 0, f2 is equal to 1. So f1 value 0, f2 value 1. Okay. Next printf %d slash t %d slash t comma f1 comma f2. So what is f1 value? 0, f2 value 1. So 0 is printed, 1 is printed. Okay. So next count is equal to 3. So what is the value of the count now? Count is equal to 3. Because two numbers are already printed, we have to print from third number onwards. Okay. Next let's check the condition. While count is less than or equal to n. So n value is 5. So 3 is less than or equal to 5. Condition is true. So here already f3 is calculated. f3 is equal to f1 plus f2. So what is f3? f1 plus f2. 0 plus 1 means 1. Next 3 is less than or equal to 5. Condition is true. If the condition is true, then we can display this value, f3 value. So what is f3 value? 1. So totally 3 numbers are printed till now. Next what we have to do is we have to copy. What is the next term? 1 plus 1. This is the next term. We have to add these two terms. So that's why we need to copy f2 to f1, f3 to f1. The formula for f3 is f1 plus f2. So f1 is equal to f2. So copy assign f2 value to f1. So what is f2 value? 1. So 1 will be assigned to f1. Next f2 is equal to f3. f3 value will be assigned to f2. So f3 value 1. So 1 will be assigned to f2. Next f3 is equal to f1 plus f2. So 1 plus 1 means 2. Next count plus plus. Now count becomes 4. So one more time, count plus plus, count becomes 4. So one more time, control goes to the condition, while count less than or equal to n. So 4 is less than or equal to 5, condition is true. So body will be executed. What is F3 value? 2, so 2 will be printed. Next, F1 is equal to F2. So what is F2 value? 1, so 1 will be copied. Next, F2 is equal to F3. What is F3 value? 2, so 2 will be assigned to F2. F3 is equal to F1 plus F2. F1 value 1, F2 value 2. So 1 plus 2 means 3. Next, count plus plus. Now count becomes 5. So control goes to the condition. While count is less than or equal to n, 5 is less than or equal to 5. Condition is true. So print of percentage the slash become F3. So F3. 3. This 3 will be printed. Next, F1 is equal to F2. F2 value 2. So 2 will be assigned. F2 is equal to F3. F3 value 3. So 3 will be assigned. F3 is equal to 2 plus 3, 5. Next to count plus plus. Okay. Now count becomes 6. So one more time, condition will be evaluated. 6 less than or equal to 5. Condition is false. So the control comes out from the while loop. So what is the output? 0, 1, 1, 2, 3. So these are nothing but the first 5 terms of the Fibonacci sequence. So in this way, we can print the first n terms of the Fibonacci sequence. Now let's see this program. C program to check whether given number is Fibonacci number or not. Here the Fibonacci sequence is the first two terms are 0 and 1. So the first term is 0, second term is 1. We can get the third term by adding these two terms. So 0 plus 1 means 1. Next we can get the next term by adding these two terms. So 1 plus 1 means 2. Next term 2 plus 1 means 3. Next term 3 plus 2 means 5. Next term 5 plus 3 means 8. So likewise the Fibonacci sequence will be continued. Let the number is 5. So we have to check whether 5 is Fibonacci number or not. So 5 is available in Fibonacci series. So we can say that it is a Fibonacci number. Let the number is 4. 4 is not a Fibonacci number. Okay, 4 is not present in the Fibonacci series. So we can say that 4 is not a Fibonacci number. So for that we have to write the program. Here initially we have to take two variables, F1 and F2, where F1 is the first term of the Fibonacci series and F2 is the second term of the Fibonacci series. So what is the first term of the Fibonacci series? 0. So F1 is equal to 0. Next F2 is equal to 1. So if F1 value is 0 or F2 value is 1, then we can say that it is a Fibonacci number. Okay. Next we have to calculate F3. So how to calculate F3? F3 is equal to F1 plus F2. F3 is equal to F1 plus F2. F1 value 0, F2 value 1. So 0 plus 1 means 1. Okay. Now let the number is 5. So what is 5? 5 is Fibonacci number. So we have to check whether it is Fibonacci number or not. So for that we are writing the logic here. And then the logic is very simple here. We have to check whether this F3, the new term, is less than n or not. If it is less than n, then we need to add the corresponding terms. Okay. So what is F3 here? 1. So 1 is, F3 is less than n. This is the condition. So F3 value here is 1. So 1 is less than 5. Condition is true. So what we have to do now is, so this is nothing but F1 term. This is nothing but F2 term. This is nothing but F3 term. So next we have to add these two terms. So this one and this one. Okay. So we have to copy this F2 to F1 and copy this F3 to F2. So here the formula is F1 is equal to F2, F2 is equal to F3, F3 is equal to F1 plus F1. Okay. So what is F1 here? F2. What is F2? 1. So now F1 value will become 1. Okay. Next F2 is equal to F3. So what is F3? 1. So F2 value is also 1. Okay. Next F3 is equal to F1 plus F2. So F1 value 1, F2 value 1. So 1 plus 1 means 2. So now F3 value is 2. Okay. So 2 is less than 5. Condition is true. So one more time we have to add the terms. So how to add the terms here? F1 is equal to F2. So what is F2? 1. So this one is copied here. Next F2 is equal to F3. What is F3? 2. So this 2 will be copied here. Next F3 is equal to F1 plus F2. F1 value 1, F2 value 2. So 1 plus 2 means 3. So next once again check whether it is less than 5 or not. So 3 is less than 5. Condition is true. So one more time we have to add the terms. Okay. F1 is equal to F2. What is F2? 2. So F1 value will become 2. F2 is equal to F3. What is F3? 3. So F2 value will become 3. F3 is equal to F1 plus F2. 2 plus 3 means 5. Next, 5 is less than 5. Condition is false. Now check whether F3 and N both are same or not. If they are same, then we can say that it is Fibonacci number. If they are not same, then we can say that it is not a Fibonacci number. Here F3 is 5 as well as N is 5. F3 is 5 as well as N is 5. So we can say that N is a Fibonacci number. So in this way we can check whether the number is Fibonacci number or not. Let's write the logic. So while writing the logic, we can understand the program in a detailed manner. So the first statement is hash include stdio.h. stdio.h. Next, C program execution starts from main function. Next here the variables are, we need F1, F2, F3 and N. So we have to check whether N is Fibonacci number or not. Next here the input variable is N. So printf enter N value. So we have to check whether this N is Fibonacci number or not. Next scanf %d comma %n. Okay. Next, what is the first term of the Fibonacci series? 0. Second term 1. So F1 is equal to 0. Next F2 is equal to 1. Okay. So next condition, if N double is equal to 0, then we can say that it is Fibonacci number. Printf Fibonacci number. Fibonacci number. Here if N is 1, then also it is Fibonacci number, but we can get that condition here also, because the result of F3 is equal to 1 only. Next condition is, next we have to calculate F3. So what is the formula for F3? F3 is equal to F1 plus F2. Next, what is the logic here? We have to check whether F3 is less than N or not. Okay. We have to check whether F3 is less than N or not. So here let us use while loop. While F3 is less than N. So what is the body here? We have to copy F2 to F1. Copy F3 to F2. So F1 is equal to F2. Next F2 is equal to F3. Next one F3 is equal to F1 plus F2. So whenever this condition is false, then compare F3 and N value. Compare F3 and N value. If they are same, then we can say that it is a Fibonacci number. So printf Fibonacci number. Okay. If they are not same, then we can say that it is not a Fibonacci number. So not a Fibonacci number. Okay. Next, close the main function. So in this way we can write the program. Now let's check whether our logic is correct or not. Here let us assume that the number is 4. So what is 4? Is 4 is a Fibonacci number or not? 4 is not a Fibonacci number. So let's check whether our program is correct or not. F1 is equal to 0, F2 is equal to 1. So here the value of F1 is 0, F2 value is 1. Next, if N double is equal to 0, but what is N value? 4. So 4 double is equal to 0. Condition is false. So what will happen? This body won't execute. Next F3 will be calculated. F3 is equal to F1 plus F2. So what is F3 now? 0 plus 1. That is nothing but 1. Okay. Next, let us check the condition. Why F3 is less than N? So 1 is less than N. Condition is true. So we have to calculate the next term. So F1 is equal to F2. So what is F1 now? We have to copy this term here. Next F2 is equal to F3. So F2 is F3 only, same. Next F3 is equal to F1 plus F2. 1 plus 1 means 2. So now f3 value is 2. So one more time control transfer to the condition. While f3 is less than n, now f3 value 2. So 2 is less than 4. Condition is true. So the body will be executed. f1 is equal to f2. So f1 value f2. f2 is equal to f3. So what is f3 value? 2. So 2 will be copied here. Next f3 is equal to f1 plus f2. So 1 plus 2 means 3. Okay. Next once again control will be transferred to the condition. f3 value is 3. 3 is less than 5. Condition is true. So what is f1 value? f2. What is f2? 2. So f1 value 2. f2 value 3. f3 is equal to f1 plus f2. 2 plus 3 5. Once again control transfer to the condition. f3 value 5, n value 4. 5 less than 4. Condition is false. So the control comes out from the while loop. So what is f3 value? 5. Next what is n value? 4. 5 double is equal to 4. Condition is false. So printf not a Fibonacci number. So this message will be printed on the monitor. Okay, let the number is 1. Okay. So if n double is f1 value 0, f2 value 1. So f1 value 0, f2 value 1. Okay. Let the number is 0. 1 double is equal to 0. False. So this block won't execute. f3 is equal to f1 plus f2. So 0 plus 1 means 1. Next while f3 is less than n, while 1 is less than 1. Condition is false. So the control comes out from the while loop. f3 value 1. Okay. Whereas n value 1. Okay. Both are same. So we can say that 1 is a Fibonacci number. Here there is no need to write the condition. Or n double is equal to 1. If n double is equal to 0, then Fibonacci number message will be printed here. Whereas if n double is equal to 1, then here we are printing that message. So in this way we can check whether a number is Fibonacci number or not. Now let's see about pattern programs. In this video we are going to discuss about these 3 pattern programs. Here we uses the same logic in order to write these pattern programs in C language or C++ or in Java or in C# or in Python. In any programming language we uses the same logic. In order to develop these types of pattern programs, we uses nested loops. We know what is nested loop. Nested loop means defining a loop inside another loop. Here it is better to use nested for loop. So nested for loop means defining a for loop inside another for loop. Here the value of n is 5. The value of n is 5. So if n is equal to 5, then we have to display the output like this. The first row contains 1, second row contains 1, 2, third row contains 1, 2, 3, fourth row contains 1, 2, 3, 4, fifth row contains 1, 2, 3, 4, 5. So by doing some minor modifications in that program, we will get this program as well as this program output also. Okay. Let us assume that the value of n is 5. Here we need to have 2 variables I and j. I and j are of type integer variables. Here we are using 2 for loops. So this is outermost for loop. This for loop is called as outermost loop, and this for loop is called as innermost for loop. Okay. Here in order to perform operations on outermost for loop, we are using a variable called I, and in order to perform operations on innermost loop, we are using a variable called j. So this loop is innermost for loop and this loop is outermost for loop. Okay. Next we need to display some value. So printf, let us see which value we will display later. Next close this curly brace. Next close this curly brace. Okay. Let's see the logic here. Here in the first row we are displaying 1. In the second row we are displaying 1, 2. Here n value is 5. So that's why we are displaying 5 rows. Suppose if n value is 10, then the last row is from 1 to 10. That is the output. Okay. Here if you observe the second row, here the values are changing. The first value is 1 and then we are displaying 2. If you observe the third row, so first we are displaying 1, next we are displaying 2, next we are displaying 3. So here the values are changing. If the values are changing in a particular row, then we have to display innermost for loop value. Let us consider this example. Here the first row contains 1, whereas the second row contains 2, 2. The values are same. If we consider third row, 3, 3, 3, the values are same. If we consider the fourth row, 4, 4, 4, 4, the values are same. If the values are same in a particular row, then we have to display outermost loop value. Whereas now we are developing the first program. Here the values are changing. If the values are changing, then we have to display this innermost loop value. Here let us assume that we are using some C language. In place of C we can use C++. In C++ we use cout object. If we consider Java, we use system.out.println. If we consider Python, then we use print function. If we consider C#, we use console.write. So any depends upon the programming language, we use the corresponding printing statement. In C language, the format specified is %d. %d. Here after displaying 1, we want to display some space. After displaying this 2, we want to display some space. So that's why after %d, give some space, comma, which value we have to display? J. So print of %d comma j. Here the values are changing. So that's why we need to display innermost loop value. Okay. Whereas if we consider this program, here values are not changing. So we have to display outermost loop value such as I. We will see that later. Okay. Let us consider the logic now. So here the first row is starting with 1. Second row is starting with 1. Third row is starting with 1. So every row is starting with 1. So here which value we are displaying? J value. So J value should also start from 1. So for J is equal to 1. Why? Because we are displaying which value? J value. Here what is the initial value? The initial value of each row is 1. So that's why the initial value of J is 1. Next, what is the condition we have to write? In the first row we have to display from 1 to 1. In the second row we have to display from 1 to 2. In the third row we have to display from 1 to 3. In the fourth row we have to display from 1 to 4. So the condition should be, in the first row I value is 1. In the second row I value is 2. In the third row I value 3. Fourth row I value 4. Fifth row I value 5. So the condition should be J less than or equal to I. J less than or equal to I. So we have to start from 1 and continue up to that I value. In first iteration I value 1. In second iteration I value 2. Third iteration I value 3. Next I value 4. Next I value 5. Next every time what we have to do? After 1 we need to have 2. After 2 we need to have 3. After 3 we need to have 4. So every time we have to increment J value. So J++. Next, what is the outermost for loop? So while developing these types of programs, first we have to develop innermost loop logic, and then based on that we have to write outermost loop logic. In the first iteration I value is 1, so I is equal to 1. In the second iteration I value is 2. In the third iteration I value is 3. So every time we have to increment I value, I++. Same condition, I less than or equal to n. So this is the program here. Let us see whether our logic is correct or not. So for I is equal to 1, 1 is less than or equal to 5. Condition is true. So body gets executed. 1 less than or equal to 5. Condition true. So this is the body. So this body will get executed now. Next, for j is equal to 1, j less than or equal to I. So 1 less than or equal to 1. Condition is true. So printf %d comma j. So now this one will get printed. This one will get printed. Next to j++, j will become 2. 2 less than or equal to 1. Condition is false. So the control comes out from this for loop. So now the cursor is here, but we have to places the cursor in the new line. So how to places the cursor in the new line? We have to use this /n. So printf /n. So if we use a /n, then the cursor will places in next line. So in this outermost loop, the first iteration is over. Next to I plus plus, I will become 2. 2 less than or equal to 5. Condition is true. So once again the body gets executed. For j is equal to 1, j less than or equal to I. So the initial value of j is 1. 1 less than or equal to what is a value? 2. 1 less than or equal to 2. Condition is true. So printf percentage d comma j. So 1 will get printed. Here we have some space is there. So space will get printed. Next to j plus plus. Now j will become 2. 2 less than or equal to 2. Condition is true. So now 2 will get printed. Next to j plus plus. J will become 3. 3 less than or equal to 2. False. So the control comes out from this innermost loop. So printf slash n. So the cursor will place us in new line. So now the cursor is here. Next what will happen? I plus plus. Now I will become 3. 3 less than or equal to 5. Condition is true. So what will happen? Body gets executed. So what is j value? 1. So 1 less than or equal to what is j value? 3. So 1 less than or equal to 3. Condition is true. So printf percentage d comma j. So 1 gets printed. Next j become 2. 2 less than or equal to 3. 2 gets printed. Next j become 3. 3 less than or equal to 3. 3 gets printed. Next j becomes 4. 4 less than or equal to 3. Condition is false. So the control comes out from the for loop. Next to slash n. So cursor will place us in new line. So likewise we will get the output. Now let us write the code for this program. Here the only modification which we have to do in this logic is, in place of this j, display I value. Why? Because if we consider every row, the values are same. 2, 2. If we consider third row, 3, 3, 3. If we consider fourth row, 4, 4, 4. In the first iteration, what is I value? 1. In the second iteration, I value 2. In the third iteration, I value 3. So that's why we have to display I value. This is the only change. Let us see whether our logic is correct or not. So for I is equal to 1. 1 less than or equal to 5. Condition is true. For j is equal to 1. J less than or equal to I. So 1 less than or equal to what is I value? 1. 1 less than or equal to 1. Condition is true. So printf percentage d space comma I. What is I value? 1. So 1 will get printed. Next to j plus plus. J will become 2. 2 less than or equal to 1. False. So the control comes out from the for loop. Slash n. So cursor will place us in new line. Next to I plus plus. I will become 2. 2 less than or equal to 5. Condition is true. So the body will get executed. J is equal to 1. 1 less than or equal to what is I value? 2. 1 less than or equal to 2. 1 less than or equal to 2. Condition is true. But which value we are displaying? I value. What is I value? What is I value? What is I value? 2. So what will happen now? Now 2 will get printed. Okay. Next to j plus plus. J will become 2. 2 less than or equal to 2. Condition is true. So we have to display I value. What is I value? I value is 2. So 2 will get printed. Let us check for one more row. Next j will become 3. 3 less than or equal to 2. Condition false. So the control comes out from slash this loop printf slash n. So the cursor will place us in new line. So let us observe this row carefully. Next to I plus plus, I will become 3. Next to j is equal to 1. 1 less than or equal to I. 1 less than or equal to what is I value? I value is 3. Condition is true. So I gets printed. So what is I value? 3. So 3 gets printed. Next to j plus plus. J will become 2. 2 less than or equal to 3. What is I value? 3. So 3 gets printed. Next to j plus plus. J becomes 3. 3 less than or equal to 3. We are printing I value. What is I value? 3. So 3 gets printed. So likewise we will get the output. So if we want to display stars in the same format, then what we can do is, we have to display with symbol star. Here display star. So if you display star, then in the first row, 1 star will get printed. In the second row, 2 stars. In the third row, 3 stars. In the fourth row, 4 stars. In the fifth row, 5 stars will get printed. So in this way we can display these patterns. In the next video we will discuss some more. Now let's see about these two pattern programs. Here we use the same logic in order to develop the program in C language or C++ or Java or C# or Python. In any programming language we use the same logic. Let n is equal to 5. If n is equal to 5, then we have to display 5 rows like this. First row contains 5, 4, 3, 2, 1. Second row contains 5, 4, 3, 2. Third row contains 5, 4, 3. Fourth row contains 5, 4. Fifth row contains 5. So we have to display output like this. In order to develop these types of pattern programs, we have to use nested loop. We know what is nested loop. Nested loop means writing a loop inside another loop. It is better to use nested for loop. Nested for loop means writing a for loop inside another for loop. So here we need to have two for loops. So this first for loop is called as outermost for loop, whereas this for loop is called as innermost for loop. To perform operations on the outermost for loop, we are using a variable called I. To perform operations on innermost for loop, we are using a variable called J. Okay. Next we have to display the value. We will discuss which value we will display later. Next close the curly brace. Next to close this outermost loop. Okay. Here first row contains 5, 4, 3, 2, 1. So all are different values. Second row contains 5, 4, 3, 2. All are different values. So if you want to display different values in each row, then we have to display innermost loop value. Whereas if we want to display same values in the row, then we need to use outermost loop value. Let us assume that here we have 5, 5, 5 like this. Here we have 5, 5, 5. Second row contains 4, 4, 4 like this. Here the first row contains same values. The second row contains same values. So likewise if we want to display, then we must use this outermost loop value. But in this example, what is our target? Our target is we want to display different values in each row. So we must display J value. J value. Here after displaying each value, we are displaying some blank space. So after percentage %d, we are giving some blank space here for better visibility purpose. Then after that, what is the starting value of each and every row? The first row is starting with 5. The second row is starting with 5. Third row is starting with 5. So every row is starting with 5. And which value we are displaying? We are displaying J value. So first we have to write the logic for J loop. For innermost loop we have to write the logic. What is the starting value of the J? The starting value of the J is N. What is N value? 5. Why? Because here every row is starting with 5. Next, what is the condition? So in the first row we have to start from 1 and continues up to 1. Continues up to 1. So in the first iteration I value is 1. In the second row we have to start from 5 and continues up to 2. So in the second iteration I value is 2. In the third row we have to start from 5 and continues up to 3. So in the third iteration I value is 3. So what is the starting value of the I? In the first iteration we have to continue up to 1. So the starting value of the I is 1. I is equal to 1. Next, in the next iteration what is I value? 2. So every time we have to perform incrementation. I plus plus. Next I has to become 3. Next I has to become 4. Next I has to become 5. So I plus plus. So how long we have to continue? We have to continue till we get N value. So the condition should be I less than or equal to N. Okay. So with this we can conclude that our outermost for loop logic is over. Next let us write the condition as well as expression 3 in innermost loop. So we have to start from 5 and continue 1. We have to start from 5 and continue 2. Here this 1, 2, 3, 4, 5 are nothing but I values. So for J, what is the condition? 5 is greater than 1 or less than 1? 5 is greater than 1. So we have to use greater than or equal to. Greater than or equal to. Why? Because we have to display that 1, 2, 3, 4 also. If you don't use is equal to, then that last value won't get printed. So j greater than or equal to I. Next, what is j value? So first we have to display 5, next to 4, next to 3, next to 2, next to 1. So every time we have to decrement j value. So j minus minus. So this is the program. Now let us check whether our logic is correct or not. So for I is equal to 1, 1 less than or equal to 5. So 1 less than or equal to 5, condition is true. So the body will get executed. For j is equal to n, what is, for j is equal to n. So what is n value? 5. 5 greater than or equal to, what is I value? What is the initial value of I? 1. So 5 greater than or equal to 1. Condition is true. So printf percentage d comma j. After percentage d we are giving some space. So 5 will be printed. After that some space will get printed. Next to j minus minus, j will become 4. 4 greater than or equal to 1. Condition is true. So now 4 gets printed. After that some blank space. Next j minus minus, j will become 3. 3 greater than or equal to 1. Condition is true. So 3 gets printed. After that some blank space. Next to j minus minus, 2 greater than or equal to 1. So 2 gets printed. Next to j minus minus, j will become 1. 1 greater than or equal to 1. We must use is equal to, otherwise this condition will become false. 1 greater than or equal to 1. Condition is true. So 1 will gets printed. Next to j minus minus, j will become 0. So 0 greater than or equal to 1. False. So the control comes out from this innermost loop value. Next we have to place the cursor in the new line. If we use C, then we use printf. Whereas in C++, we use cout. In Java, system.out.println. So likewise we use, okay. So next what will happen? I++. So printf /n. So here we have cursor. Whenever /n is executed, the cursor will place us in new line. Next I++. I will become 2. 2 less than or equal to 5. Condition is true. Next what is j value? J value is 5. 5 greater than or equal to I. What is I? 2. So 5 greater than or equal to 2. So up to 5 to 2 we will get the output. 5 greater than or equal to 2, true. So 5 gets printed. Next to decrementation will be done. 4 greater than or equal to 2, condition true. So 4 gets printed. Next to 3 gets printed. Next to 2 gets printed. Next to j will become 1. 1 greater than or equal to 2, false. So the control comes out from this for loop. Printf /n. So the cursor will place us in the new line. So we can conclude that our program is correct. Now let us write the program for, the second one. Okay, the second one. So what is this program? First row contains same 5 4 3 5 4 3 2 1. Whereas what is the second row? 4 3 2 1. 4 3 2 1. Next 3 2 1. Next 2 1. Here also n value is 5. If n is equal to 5, we have to display output like this. Okay. So in order to perform operations on the outermost for loop, we are using I. To perform operations on the innermost loop, we are using j. So which value we have to display? We are using some C here. So printf percentage d, some space comma. Here also the values are changing. So first to 5, next to 4, next to 3, next to 2, next to 1, next to 4, 3, 2, 1. Okay. So in every row we are displaying different values. So if you want to display different values in each row, then we have to display innermost loop value. That is, we have to display j value. Okay. Next, here we have to write the logic for innermost loop first. So what is in the first row? It is starting with 5. Second row is starting with 4. Third row is starting with 3. Fourth row is starting with 2. The last row is starting with 1. So j will get value from I. Why? Because here the j value is changing. First 5, next 4. So j receives values from I. So in the first iteration, what is I value? I value should be 5. Why? Because j has to receive the value from I. So in the first row, what is the first value we have to display? 5. So in the first iteration, I value 5. Second iteration, I value 4. Third iteration, I value 3. Fourth iteration, I value 2. Fifth iteration, I value 1. So let us write the logic for outermost loop. So for I is equal to n, so every time we have to perform decrementation. So I greater than or equal to 1. After 5, 4. After 4, 3. After 3, 2. So decrementation. I minus minus. Next for j is equal to I. So how long we have to perform the repetition? 5 to 1, 4 to 1, 3 to 1, 2 to 1, 1. So every time we have to continue up to 1. So j greater than or equal to 1. Next decrementation, j minus minus. Okay. Let us check whether this logic is correct or not. So here also slash n. So for I is equal to n. Okay. Next to I greater than or equal to 1. So 5 is greater than or equal to 1. Condition is true. So the body will get executed. For j is equal to I. What is I value? 5. So 5 is greater than or equal to 1. Condition is true. So print of percentage d comma j. So 5 gets printed. Next j minus minus. J will become 4. 4 greater than or equal to 1. 4 gets printed. J minus minus 3. 3 greater than or equal to 1. Condition true. 3 gets printed. 2 greater than or equal to 1. Condition is true. So 2 gets printed. Next 1. 1 greater than or equal to 1. Condition is true. So 1 gets printed. 0 greater than or equal to 1. Condition is false. So the control comes out from the j loop. Okay. After j loop we have slash n. So the cursor will place us in new line. Let us observe this row carefully. Next to I minus minus. What is the previous value in I? 5. Now I become 4. Next for j is equal to I. What is I value? What is I value? 4. So j is equal to I. So j receives value from I. So that is 4. 4 greater than or equal to 1. Condition is true. So we will get output from 4 to 1. Okay. 4 greater than or equal to 1. Next to 3 greater than or equal to 1. 2 greater than or equal to 1. 1 greater than or equal to 1. Next to 0 greater than or equal to 1. Condition false. Slash n. Okay. Next to what will happen? I minus minus. I will become 3. Next to for j is equal to I. J receives value from I. That is 3. 3 to 1 we will get the output. So in this way we can get the output. In the next video we will discuss some more pattern programs or pyramid programs. Okay. If we want to display some stars like this, I want to display. In place of 5, 4, 3, 2, I want to display some stars like this. Okay. Some stars. 5 stars, 4 stars, 3 stars, 2 stars, 1 star like that. Then here in place of that percentage dj, just simply we have to use this star. So that in the first row 5 stars will get printed. In the second row 3 stars. In the third row 2 stars. In the likewise we will get. In this video we are going to discuss about these two pattern programs or pyramid programs. If n is equal to 5, then we have to display output like this. First row contains 1, second row contains 1, 2, third row contains 1, 2, 3, fourth row contains 1, 2, 3, 4, fifth row contains 1, 2, 3, 4, 5. Here printing digits is not important. Printing the numbers in this format is very, very important. Okay. Here let's see what will happen. In the first row what we are doing is, in the first row we are displaying, this is one space, this is second space, this is first space, this is second space, this is third space, this is the fourth space. So in the first row we are displaying 4 blank spaces. Likewise in the second row we have to display 3 blank spaces. In the second row we have to display 3 blank spaces. After displaying this number we will display 1 blank space very easily. Next in the third row we have to display 2 blank spaces. In the third row 2 blank spaces. In the fourth row 1 blank space. Fifth row 0 spaces. So that is the output we have to get here. Okay. Here in order to develop these types of programs we use nested loop. Nested loop means writing a loop inside another loop. Here it is better to use nested for loop. Totally we have to use 3 for loops here. I loop, S loop, J loop. So I for performing operations on the row. S for blank spaces. S stands for space. Next J for printing the numbers. Okay. So totally we need to have 3 loops. So this is the outermost loop. In this we are using I to perform the operations. Next we have to use S. S for blank spaces. So first we have to display blank spaces. First we have to display blank spaces. And after that we have to display the corresponding output. In order to display the output, here we are using J. In order to display the output, we are using J. Next close the for loop. Okay. So let's see what is the logic here. So first we have to care about the blank spaces. In the first row, how many blank spaces are needed? 4 blank spaces are needed. In the second row, 3 blank spaces are needed. If you observe the logic, so in the first row we have to display 1 only. In the second row we have to display from 1 to 2. First let us concentrate about this J loop. So which value we have to display in order to print these numbers? I value or J value? Here we are changing the values. The second row contains 1, 2. These 2 values are not same. Third row contains 1, 2, 3. So these values are different. So if you want to display different values, then we have to use this J here. So printf %d. After %d, give one blank space. Okay. So that after the number we will get one blank space. So printf %d comma J. Okay. Whereas if we want to display like this, first row contains only 1, second row contains 2, 2, third row contains 3, 3, 3, fourth row contains 4, 4, 4, fifth row contains 5, 5, 5, 5, like this. Here if you consider second row, in second row the numbers are equal, third row numbers are equal, fourth row numbers are equal. In that occasion we have to use this outermost loop value I. But here the values are changing. If the values are changing, then we have to display J value. Okay. So let us write the logic for J. So here every time, here we are displaying J value. The first row is starting with 1, second row is starting with 1, third row, fourth row, fifth row. Every row is starting with 1. So the J value is 1. So for J is equal to 1. So how long we have to perform the repetition? 1 to 1, first row. Second row, 1 to 2. Third row, 1 to 3. Fourth row, 1 to 4. So in the first row, I value is 1. In the second row, I value is 2. In the third row, I value is 3. Fourth row, I value 4. Fifth row, I value 5. So the condition must be J less than or equal to I. So 1 to 1, 1 to 2, 1 to 3. So I value is also same. I is equal to 1. So how long we have to proceed? From 1 to 5 we have to display. So I less than or equal to n. So first 1, next I value 2, next I value 3, next I value 4, next I value 5, like that. So every time we have to perform the implementation. Okay. So here also every time we have to perform the implementation. So J++. Okay. So with this we will get these numbers. But here it is important to display the blank spaces. Let us assume that the starting value of S is 1. So we have to write one condition here. So what is the initial value of S? 1. So in the first row how many spaces are needed? 4. But what is n value? 5. N value is 5. What is S value? 1. So S less than or equal to, in the first row 4 spaces are needed, but n value is 5. So if you subtract 1 from that n, we will get 4 spaces. So S less than or equal to n minus I. Next, every time we have to perform the implementation. Next, to display spaces. So printf display some blank space. Within the double quotation, display some blank space. Let us check whether this logic is correct or not. Whether this logic is correct or not. So first, for I is equal to 1, I less than or equal to n. So 1 less than or equal to 5. Condition is 2. So body gets executed. For S is equal to 1, S is equal to 1, S less than or equal to n minus I. What is n value? 5. 5 minus, what is I value? 1. 5 minus 1 means 4. So 1 less than or equal to 4. 1 blank space will get printed. Next to S++. 2 less than or equal to 4. 2 less than or equal to 4. condition true, second blank space. Next s plus plus, s will become 3, 3 less than or equal to 4, third blank space. S plus plus, s will become 4, 4 less than or equal to 4, fourth blank space will get printed. Next s will become 5, 5 less than or equal to 4, condition is false, so the control comes out from this s for loop. Next for j is equal to 1, j less than or equal to I. What is the starting value of I? 1. So 1 less than or equal to 1. Condition is true. So 1 will get printed. After that some space will get printed. So this is that space. Next to j plus plus. J will become 2. 2 less than or equal to 1. Condition is false. So the control comes out from this j loop. Next we have to display output in the next row. So use /n. So print of /n. So that the cursor will places in the new line. Okay. Next I plus plus. I will become 2. 2 less than or equal to 5. Condition is true. Next for s is equal to 1. S less than or equal to n minus I. So 1 less than or equal to, what is n? 5. 5 minus what is I value? 2. So 5 minus 2 means 3. So 1 less than or equal to 3. Condition is true. One blank space. Next s will become 2. 2 less than or equal to 3. Condition true. Second blank space. S plus plus. 3 less than or equal to 3. Condition is true. Third blank space. S plus plus. S will become 4. 4 less than or equal to 3. False. So the control comes out from S loop. Okay. Next for j is equal to 1. J less than or equal to I. What is I value? I value is 2. 1 less than or equal to 2. Condition is true. So 1 will get printed. Next here we have space. So that space will get printed. Next to j plus plus. J will become 2. 2 less than or equal to 2. Condition is true. So 2 will get printed. Next to some space. Okay. Next to j plus plus. J will become 3. 3 less than or equal to 2. Condition is false. So the control comes out from this for loop. Print of /n. So the cursor will places in the next line like this. Let us observe this row. So this is the last row which I want to discuss. I plus plus. I will become 3. 3 less than or equal to 5. Condition is true. Next for s is equal to 1. S less than or equal to 1 less than or equal to, what is n? 5. What is I? 3. 5 minus 3 means 2. So 1 less than or equal to 2. 1 space. 2 less than or equal to 2. 2 spaces. So 2 spaces will get printed. Next for j is equal to 1. J less than or equal to I. What is I value? 3. 1 less than or equal to 3. 1 will get printed. Next after that one blank space. Next 2 will get printed. Blank space. 3 will get printed. Next blank space. Next the cursor will places in the new line. So if we arrange the blank spaces, then this is the output which we want to produce. Okay. Which we want to produce. Likewise here 1, 2, 3, 4 will get printed. Okay. 1, 2, 3, 4, 5 will get printed. If we want to display like this, then the only modification which we have to do is, in place of this j, display I value. If we display I value, then what will happen? Second row contains 2, 2 only, third row contains 3, 3 only. Likewise we will get the output. Or if you want to display stars like this, if you want to display stars like this, in the same format, if you want to display stars, first row contains star like this, second row contains stars, third row, fourth row, next to fifth row. So if you want to display like this, then erase this one. In the double quotations, display star symbol. Okay. If you display like this, we will get output like this. Okay. So in this way, we will get the output in these shapes, in these patterns or in these pyramids. In the next video, we will discuss. In this video, we are going to discuss about this pattern program. This can also be called as pyramid program or Floyd's triangle. If n value is 5, then we have to display 5 rows like this. First row contains 1, second row contains 2, 3, third row 4, 5, 6, fourth row contains 4 values 7, 8, 9, 10, fifth row contains 5 values 11, 12, 13 and 14. So here we will have one more value, that is 15. Okay. So fourth row 4 values, fifth row 5 values. So likewise we have to produce the output. So for this we have to develop the program. In order to develop any pattern program, we have to use nested loops. Here it is better to use nested for loop. We know what is nested for loop. Writing a for loop inside another for loop is called as nested for loop. So totally we require two for loops here. So this is outermost for loop. In order to perform operations on outermost for loop, we are using a variable called I. So first we have to declare some I, j, and what is n value? The value of n is 5 here. Okay. Here the logic is same for any programming language. It may be either C or C++ or Java or C# or Python or Pascal. In any programming language, the logic must be same. Okay. Next one, for this is nothing but innermost for loop. In order to perform operations on the innermost for loop, we are using a variable called j. Okay. J. Next here we have to perform the printing operation. We will discuss which value we have to print later. Next to close this for loop. Okay. Now let's see the logic here. In the first row we have to display only one value. In the second row we have to display two values, and those two values are what? Incrementation of 1. If we increment 1, then we will get 2. If we increment 2, then we will get 3. If we increment 3, 4. Incrementation of 4 means 5. Incrementation of 5 means 6. So the logic is very, very simple here. Every time we have to print that count value. What is the initial value of the count? 1. Okay. So initially we have to take a variable called count C. The initial value of the C is 1. Okay. So in this innermost loop, so how many times we have to repeat this j? In the first iteration, we have to perform the repetition for only one time. So print C value. Okay. So the logic is very, very simple here. Printf %d comma C. Printf %d comma C. So what is C value? 1. So first one will get printed. How many times we have to display 1? Only once. Okay. Next, in the second iteration, we have to perform j loop repetition for how many times? 2 times. So we have to perform the repetition for 2 times. In the third iteration, we have to perform the repetition for 3 times. So every time this value should be incremented. So by observing this, we can write as j is equal to 1. So how many times we have to perform the repetition? In the first iteration only 1 time. In the second iteration 2 times. In the third iteration 3 times. So the value of I in the first iteration should be 1. In the second iteration it should be, how many values we have to print? 2 values. In the second iteration I value should be 2. Next, in the third iteration I value should be 3. In the fourth iteration I value 4. In the fifth iteration I value 5. Okay. So every time we have to perform the incrementation. So I++. Next, how long we have to perform the repetition? We have to perform the repetition for 1, 2, 3, 4, 5. 5 times. So I less than or equal to n. In this example, the value of the n is what? 5. The value of n is 5. Next, perform j++. So this is the logic here. Now let's check whether our logic is correct or not. For I is equal to 1, I less than or equal to n. So I value is 1. So 1 is less than or equal to 5. Condition is true. So this body will get executed. J is equal to 1. J less than or equal to I. So 1 less than or equal to, what is I value? 1. So 1 less than or equal to 1. Condition is true. Printf %d comma C. So what will happen? What is the initial value of the C? 1. So 1 will get printed now. So next, in the second iteration, we have to display 2 and 3. So we need to perform incrementation. So C++. C++. Next, what will happen? C will be incremented. Initially C value 1. Now C value will become 2. Okay. Next, we have to place the cursor in the next line. The second row will start from the new line. So how to place the cursor in the new line? We have to use a /n here. In C we use printf. In C++ cout object. In Java system.out.print. In C# console.writeLine. So depends upon the programming language, we have to use the print statement. Okay. So printf /n. So the cursor will place us in new line. So the body execution is over. Next I plus plus. I will become 2. 2 less than or equal to 5. Condition is true. So this body will get executed. For j is equal to 1. So once again the j loop will start from 1. So 1 less than or equal to, what is I value? 2. 1 less than or equal to 2. Condition is true. So printf percentage d comma c. What is the value of c now? 2. So 2 will get printed. Next c plus plus. Now c will become 3. Next body execution is over. So once again control goes to j loop. J plus plus. Now j will become 2. 2 less than or equal to 2. Condition true. So what will happen? C value will get printed. What is C value? 3. So 3 will get printed. Next for loop execution is over. Next control goes to the j loop. J plus plus. Now j will become 3. 3 less than or equal to 2. Condition is false. So the control comes out from this for loop. Printf slash n. Here we have the cursor. So whenever this slash n is executed, then the cursor will place us in the next line. Let us see this iteration. So the last iteration in this program. Okay, if we understand this iteration, then understanding the next iterations will also become quite easy. Next I plus plus. Previously I value 2. Now I value will become 3. 3 less than or equal to 5. Condition is true. So the body of the for loop will get executed. J is equal to 1. So 1. J less than or equal to I. 1 less than or equal to what is I? 3. 1 less than or equal to 3. Condition is true. Printf percentage d comma c. What is the previous value in C? What is the previous value in C? Actually after that we have performed the implementation. So now C value will become 4 after implementation. Now C value is what? 4. So 4 gets printed. Okay. Next to C plus plus. Now C will become 5. Okay. Next to J plus plus. J will become 2. 2 less than or equal to 3. Condition is true. So we have to print C value. What is C value? 5. So 5 gets printed. Next to C plus plus. C will become 6. C will become 6. Next J plus plus. J will become 3. 3 less than or equal to 3. Condition is true. Printf percentage d comma c. What is C value? 6. 6 will get printed. Next to C plus plus. Next to C will become 7. Next to J plus plus. J will become 4. 4 less than or equal to 3. False. So whenever this condition is false, then the control comes out from this innermost loop. Printf slash n. So cursor will place us in the next line. So in the next line what will happen? 4 numbers will get printed. Okay. J value is 1, I value is 4. 1 less than or equal to 4, 2 less than or equal to 4, 3 less than or equal to 4, 4 less than or equal to 4. What is the value here? 7. So from 7 to 10, 4 numbers will get printed. Next, what will happen? Next, count value will become 11. Next, I value will become 5. So from 11 to 15, 5 numbers will get printed. 11, 12, 13, 14, 15. Okay. Suppose if n value is 6, then what will happen? From 16 to 6 numbers will get printed. So in this way we will display Floyd's triangle. In the next video we will see some more patterns. In this video we are going to discuss about these 3 pattern programs or pyramid programs. So here we have one here, next 1 2, 1 2 3, 1 2 3 4 4, 1 2 3 4 5. So if n value is 5, then we have to display output like this. Okay. And what is the second example? Second row contains 2 2, third row contains 3 3 3, fourth row 4 4s, fifth row 5 5s. Last example, in place of numbers we have to print stars. Okay. Let's see how we can do that. Here the value of n is 5. If n value is 10, then we will get 10 rows. And what is the last row? From 1 to 10 we have to get the output. Okay. Here the logic is very simple. We know that in order to display any pattern program or pyramid program, we have to use a nested loop. It is better to use nested for loop. Nested for loop means writing a for loop inside another for loop. Okay. Here totally we require 3 for loops in order to perform operations on the row. We have to use a loop whose variable is I. Next, here we have to print some spaces. In order to print the spaces, we have to use a for loop which contains a variable called s. Next, for column repetition, if we consider second row, then we have to display 1 and 2. So these two are nothing but columns. If we consider third row, then we have to display 1, 2, 3. So in order to perform operation on the column, we have to use a for loop which performs operation on j variable. So first let us write that, then after that we will see the logic. Next, to perform operations on the rows, we are using I loop. Next, so first we have to print spaces. After printing the spaces, we need to display the corresponding columns, the corresponding numbers. So in order to display the spaces, we are using a for loop. Here we are using S. S stands for space. Next, in order to display the result, we are using J loop. This J, this for loop. Next, we have to perform some printing statement. We will discuss which value we have to print later. So this is nothing but this for loop closing, this for loop closing, and this for loop closing. Okay. In the first for loop, in the first row, how many spaces we have to print? Let us observe that one. So this is the first space, second space, third space, fourth space. So in the first iteration, we have to display first space, second space, third space, fourth space. So in the first iteration, we have to display 4 spaces. Here when I is equal to 1, it is the first row. When I is equal to 2, it is the second row. When I is equal to 3, it is the third row. Okay. So when I is equal to 1, we have to display 4 spaces. When I is equal to 2, how many spaces are required? This is the first space, second space, third space. When I is equal to 2, 3 spaces are required. Next, when I is equal to 3, so 1, 2, 2 spaces are required. Next, when I is equal to 4, 1 space is required. When I is equal to 5, 0 spaces, no need of any spaces. So for that we have to write the logic. Okay. So here the initial value of the I is 1. Why? Because in the first iteration we have to display only 1. In the second iteration, I value should be 2. In the third iteration, I value should be 3 because we have to display 3 numbers. Fourth iteration, we have to display 4 numbers. So the for loop is for I is equal to 1, I less than or equal to n. Why? Because how many times we have to perform the repetition? N times. Here we have 5 rows, so that's why we are repeating 5 times. Next, after 1, in the second iteration, we have to repeat for 2 times. In the third iteration, 3 times. So every time we are incrementing this value. So I plus plus. Okay, this is the loop here. Let's focus on the spaces. So how many spaces we have to print down? How many spaces are required here? Okay. So for that we have to write the logic. So when I is equal to 1, how many spaces are required? 4 spaces are required. What is n value here? What is n value? Here the value of n is 5. The value of n is 5. When I is equal to 1, 4 spaces are required. So 5 minus 1 is nothing but 4. When I is equal to 2, 3 spaces are required. So this 5 minus 2 is nothing but 3. So the logic is very, very simple. For s is equal to 1, s less than or equal to this n minus I. S less than or equal to n minus I, s plus plus. This for loop contains only one statement, that is printf within the double quotation, one blank space. Okay. Here we uses the same logic if you want to develop the program in any programming language. Okay. Here I am writing in C language, so that's why I am using printf function. Okay. So printf within the double quotation, within the parenthesis some empty spaces. Okay. So that the corresponding spaces will get printed. We will discuss the tracing later. So spaces are printed. Next we have to focus on the numbers. Okay. So in the first iteration we have to display 1. In the second iteration 1, 2, 2. In the third iteration 1, 2, 3. In the fourth iteration 1, 2, 4. So every time here what we are doing? Here we are changing the number. So 1, 2. Next 1, 2, 3. So here the number is changing. So that's why we have to display this innermost loop value. Suppose if the number is not changing like this, second row contains the same number 2, 2. Third row contains the same number 3, 3, 3. In this occasion we have to use outermost loop value. But here the value is changing. So which value we have to print? Here we have to print j value. So printf percentage d comma j. We have to print j value. Okay. Next, let us focus on j loop. So here in every row, the first value which we are printing is 1. So the initial value of j is 1. So in the first iteration we have to display only 1 from 1 to 1. In the second iteration 1 to 2. In the third iteration 1 to 3. This 1, 2, 3, 4, 5 are nothing but the values of I. So the condition should be j less than or equal to I. So we have to continue up to that I only. Second iteration up to 2. 2 means I value. Next to j plus plus. Okay. Now let's check whether our logic is correct or not. Let's check whether our logic is correct or not. So first I is equal to 1. I less than or equal to n. What is n value? 5. So 1 less than or equal to 5. Condition is true. So the body will get executed. Okay. Next for s is equal to 1. Next s less than or equal to n minus I. So 1 less than or equal to n minus I. N value 5. I value 1. 5 minus 1 means 4. So 1 less than or equal to 4. 1 blank space will get printed. 1 blank space will get printed. Next s plus plus. S will become 2. 2 less than or equal to 4. Condition true. Second blank space. Next s plus plus. S will become 3. 3 less than or equal to 4. Third blank space. S plus plus. S will become 4. 4 less than or equal to 4. Another blank space. S will become 5. 5 less than or equal to 4. Condition is false. Okay. Condition is false. So the control comes out from this for loop. Okay. Here this for loop contains only one statement. So that's why curly braces are optional. If you use curly braces, then this loop contains only this statement. Okay. Next, condition is false. So the control comes out from this for loop. So this loop will get executed. Here also curly braces are optional. Why? Because this loop contains only one statement. Okay. For j is equal to 1, j less than or equal to I. So j value 1, j less than or equal to, what is I value? 1. 1 less than or equal to 1. Condition is true. Printf percentage d comma j. What is a value? What is a value? 1. So 1 will get printed. So next j plus plus. J will become 2. 2 less than or equal to 1. Condition is false. So the control comes out from the for loop. But we have to display this one in the next row. This 1, 2 in the next row. So we have to use this slash n now. We have to use this slash n now. So printf slash n. Okay. Here there is no need of any curly brace. Why? Because this loop contains only one statement. This loop also contains only one statement. This curly brace is for this for loop. Okay. Printf slash n. So the cursor will place us in the next line. Okay. So next, this for loop execution is over. Next I plus plus. I will become 2. Now I will become 2. 2 less than or equal to 5. Condition is true. Condition is true. So the body will get executed. For s is equal to 1, s less than or equal to n minus I. What is n value? 5. What is I value? 2. 5 minus 2 means 3. So 1 less than or equal to 3. 1 space. Next s plus plus. S will become 2. 2 less than or equal to 3. Second space. S plus plus. S will become 3. 3 less than or equal to 3. Second space. Third space will get printed. S will become 4. 4 less than or equal to 3. False. So the control comes out from this for loop. Next j loop. J is equal to 1. J less than or equal to I. What is I value? 2. 1 less than or equal to 2. Condition is true. So j value will get printed. What is j value? 1. So 1 got printed. Next j plus plus. J will become 2. 2 less than or equal to 2. Condition is true. Now what is j value? 2. So 2 got printed. Next j plus plus. J will become 3. 3 less than or equal to 2. Condition is false. So the control comes out from this for loop. Printf slash n. So the cursor will place us in the next line. Let us see this iteration also. Next I plus plus. I will become 3. 3 less than or equal to 5. Condition is true. So what will happen? Body gets executed. S is equal to 1. 1 less than or equal to n minus I. N means 5. I means 2. 3. 5 minus 3 means 2. So 1 less than or equal to 2. 1 space. 2 less than or equal to 2. 2 spaces. So 2 spaces got printed. Next j is equal to 1. J less than or equal to I. Now I value is 3. I value is 3. So 1 less than or equal to 3. 1 space. 2 less than or equal to 3. 1 less than or equal to 3. So 1 got printed because j value 1. Next j will become 2. 2 less than or equal to 3. Condition true. So 2 got printed. Next 3 got printed. So if he arranges these spaces, if you remove these blank, these dashes, then we will get the output in this format. So this is the format which we have to get. Now let us see the second program. The only modification between this program and this program is, in this program, instead of j, we have to display I value. We have to display I value. So in the first iteration, what is I value? 1. So 1 will get printed. In the second iteration, what is I value? In the second iteration, I value is 2. So 2 will be repeated 2 times. In the third iteration, what is I value? 3. So 3 will be repeated 3 times. Here the logic is same only. If we consider the third row, j is equal to 1, j less than or equal to I. So j value 1. In the third row, what is I value? 3. So 1 less than or equal to 3. Condition is true. But what is I value? I value 3. So 3 gets printed. Next to j plus plus. J will become 2. 2 less than or equal to 3. Condition is true. But what is I value? I value is 3. So I will get printed. So that is the only change here. Here if the value is same in the corresponding row, then we need to display I. Whereas if the value is changing, then we have to display this j value. And what is the last one? Same logic. In place of percentage d, here simply we have to display star. So if you display star, what will happen? In the first iteration, what will happen? 1 less than or equal to 1, condition is true. So 1 star will get printed. Next 2 less than or equal to 1, false. So control comes out from this for loop. In the second iteration, I value will become 2. So in the first iteration, what will happen? We will get same logic. So 4 spaces. So 1. So 4 spaces will get printed. Okay. So 1, 2, 3, 4. So 4 spaces will get printed. In the second row, 3 spaces. In the third row, 2 spaces. In the fourth row, 1 space. Okay. In the last row, 0 spaces. Same logic. Here in place of the numbers, we have to display star. So in this way, we have to develop these 3 programs. In the next video, we will see some more. In this video, we are going to discuss about these 2 pattern programs. If n value is equal to 5, then we have to display an output like this. First row contains 1, 2, 3, 4, 5. Second row 1, 2, 3, 4. Third row 1, 2, 3. Fourth row 1, 2. Last row 1. Example 2. In place of these numbers, we have to display stars. So first row 5 stars. Second row 4 stars. Third row 3 stars. Fourth row 2 stars. Fifth row 1 star like this. If n value is 5, then we have to produce output like this. Suppose if n value is 6, then the first row should contain the numbers from 1 to 6. Okay. So in order to write these types of pattern programs, we have to use a nested loop. We know what is nested loop. Nested loop means defining a loop inside another loop. It is better to use nested for loop. Nested for loop means defining a for loop inside another for loop. Okay. So the first for loop is outermost for loop. To perform operations on the outermost for loop, we are using a variable called I. Next, to perform operations on these columns, every row contains some values. These values are nothing but some columns. Okay. First row contains 5 columns, second row 4 columns, third row 2 columns, like that. Okay. So this is what? First column, second column, third column, fourth column, fifth column. So in order to perform operations on the columns, we are using J. So this J loop is nothing but innermost loop. Here we are changing the value. First we are displaying 1, next we are displaying 2, next we are displaying 3, next 4, next 5. If the value is changing, then we have to display J value. If the value is changing, then we have to display which value? J value. So printf, why? Because in the row, J value will be changes every time, but I value won't changes. Okay, I value will be same in the entire iteration. So printf %d comma j. Whenever the condition is false, then we have to print the new line. Here the logic is same irrespective of the programming language. We uses the same logic for C or C++ or Java or C# or Python or PASCAL or PHP. In any language, the logic is same only. Okay. So here, let us observe the logic here. So each row, here each row is beginning with 1. So first row is beginning with 1, second row is beginning with 1, third row is beginning with 1, fourth row is beginning with 1. So every row is beginning with 1. So J value is 1. J value is 1. Okay. Next, first row, we have to continue from 1 to 5. Second row, we have to continue from 1 to 4. Third row, we have to continue from 1 to 3. So in the first row, we have to continue up to 5. So that 5 is nothing but I value. So in the first iteration, what is I value? 5. In the second row, we have to continue the loop up to 4. So that 4 is nothing but I value. So in the second row, I value has to become 4. Third row, I value has to become 3. So what is the initial value of I? 5. So 5 is nothing but n. Next I value 4. Next I value 3. Next I value 2. So every time we have to perform decrementation. I minus minus. Okay. Next, how long we have to perform the repetition? So up to 1. So I greater than or equal to 1. Greater than or equal to 1. Next, for j is equal to 1. So we have to continue up to 5, up to 4, up to 3. So that 5, 4, 3, 2, 1 are available in I value. So j is less than or equal to I. Next, after 1 we have to display 2. After that 3. So every time we have to perform incrementation, j plus plus. Now let's check whether our logic is correct or not. So for I is equal to n, what is n value? 5. So for I is equal to 5, 5 greater than or equal to 1. So 5 greater than or equal to 1, condition true. So this body will get executed. J is equal to 1, j less than or equal to I. What is I value? This 5. So 1 less than or equal to 5, condition true. So print of percentage d comma j. What is j value? 1. So 1 will get printed. Next to j plus plus. J will become 2. 2 less than or equal to 5. 2 will get printed. Next to j plus plus. J will become 3. 3 less than or equal to 5. Condition true. So 3 gets printed. Next to j plus plus. J will become 4. 4 less than or equal to 5. Condition true. So 4 will get printed. Next to 5 will get printed. Next to j will become 6. 6 less than or equal to 5. Condition is false. So the control comes out from this for loop. We have to display the next row in the next line. So that's why here we have to use a slash n. So whenever we use a slash n, then the cursor will place us in the new line. So next what will happen? I minus minus. Previously I value 5. Now I value will become 4. 4 is greater than or equal to 1. Condition is true. Condition is true. Okay. So body will get executed. For j is equal to 1, j less than or equal to I. So 1 less than or equal to 4. Condition true. So 1 will get printed. 2 less than or equal to 4. Condition true. 3 less than or equal to 4. Condition true. 3 gets printed. 4 less than or equal to 4. Condition true. So 4 will get printed. Next to j plus plus. J will become 5. 5 less than or equal to 4. False. So the control comes out from this j loop. Print of slash n. So the cursor will place us in new line. Okay. So likewise we will get the output. Okay. If the suppose let us assume that the numbers are same. If we want to display like this, first row contains 5, 5, 5, 5 5s. Second row contains 4 4s. Third row contains 3 3s. Fourth row 2 2. Fifth row 1. Here the value is same. If the values are same in each row, then instead of j, we have to display I value. Okay. In the first iteration, what is I value? 5. I value 5. 5 greater than or equal to 1. Condition true. J value 1. 1 less than or equal to 4. Condition true. But we are displaying which value? I. What is I value? 5. So 5 gets printed. Next 2 less than or equal to 5. Condition true. 5 gets printed. 3 less than or equal to 5. Condition true. 5 gets printed. 4 less than or equal to 5. Condition true. So 5 will be printed. 5 less than or equal to 5. Condition true. 5 gets printed. If the values are same in a particular row, then we have to display I value. Whereas if the values are changing, then we have to display j value. Okay. If we want to display stars like this, then the only change is instead of I and j, we have to display star. So if you display star, then first row contains 5 stars, second row contains 4 stars, third row 3 stars, fourth row 2 stars, fifth row 1 star. Like this we will get the output. So in this way we will write the program in order to write the logic for these 3 programs. In the next video we will see some more patterns. In this video we are going to discuss about these 2 pattern programs. If n value is 5, then we have to display output like this. First row contains 1 2 3 4 5. Second row contains a space 1 2 3 4. Third row contains 2 spaces 1 2 3. Fourth row contains 3 spaces 1 2. Fifth row contains 4 spaces 1. Second example, in place of the numbers we have to display some stars. In order to display pattern programs, we have to use this nested loop. Nested loop means writing a loop inside another loop. Here we are using the for loops. Here totally we have to use just 3 for loops. First for loop for performing operations on the rows. Second for loop for the spaces. Third for loop is for printing the numbers. Printing the numbers in the corresponding columns. Okay. Here we have first row contains what? These 4 columns. Second row contains 4 columns. Third row 3 columns. Fourth row 2 columns. In order to display the values, we have to use the third for loop. Okay. Let us start the logic here. So this is, here we are using I. So I for row repetition. Next we have to use S. S for spaces. Okay. S for spaces. Simply we have to display a space here within the double quotation space. Next we use J loop for displaying the data. Use J loop for displaying the data. Just we have to print some data. We will discuss which data we have to print. That will be discussed later. Okay. Let's see the logic here. Here we are closing this for loop. Okay. First row doesn't contain any spaces. Okay. First row contains what? 0 spaces. Second row contains 1 space. 1 space. Third row contains 2 spaces. Fourth row contains 3 spaces. Fifth row contains 4 spaces, like this. Okay. First, let us write the logic for J loop, and then we will see S and I also. So in each row, here each row is starting with 1. First row is starting with 1. Second row is starting with 1. Third row is starting with 1. Fourth row is starting with 1. Last row is also starting with 1. Okay. So J value must be 1. So after 1 we have to display 2, after that 3, after that 4, after that 5. So here the value is changing. If the values are changing in a particular row, then we have to display this J value. Whereas if the values are common, then we have to use this I value. Suppose if the first row contains all 5s, second row contains 4s, third row contains 3s, that means first row contains 5 5s, second row contains 4 4s. First row means what? Like this, 5 5s. Second row 4 4s. Third row 3 3 3. Likewise, if the output is like this, then we have to print I value. But here the values are changing, so we have to display J value. Printf %d comma J. Here the loop contains only one statement, so curly braces are optional, not compulsory. Okay. So J is equal to 1. So up to which value we have to display? Up to 4. So in the first iteration we have to display up to 5. In the second iteration we have to display up to 4. In the third iteration up to 3. So in the first iteration I value must be 5. In the second iteration I value must be 4. In the third iteration I value must be 3. In fourth iteration I value must be 2. So what is the starting value of I? 5. So 5 is nothing but n. In this example n value is 5. Okay. Next, after that 4, after that 3, after that 2. So every time we have to perform decrementation. I minus minus, I minus minus. Okay. How long we have to perform the repetition? Until 1. Okay. So the condition should be I greater than or equal to 1. Okay. Next, for J is equal to 1. In the first iteration we have to continue up to 5. Next up to 4, up to 3. So J value should be less than or equal to I. So every time we have to perform incrementation. 1, 2, 3, 4, 5, like that. So J plus plus. So this is the logic. Now let's see whether our logic is correct or not. I is equal to n. So n value is 5. So 5 is greater than or equal to 1. So 5 is greater than or equal to 1. Condition is true. So body will get executed. Okay. So first we have to display the spaces. In the first iteration, 0 spaces are needed. In the first iteration, 0 spaces are needed. So what is the condition here? S is equal to 1. Okay. Next, S less than or equal to, what is n value? 5. I value is also 5. So S less than or equal to n minus I. N minus I. S plus plus. S plus plus. Okay. S plus plus. Let us check whether this logic is correct or not. For S is equal to 1, so 1 is less than or equal to n minus I. What is n? What is n? 5. What is I? I value is also 5. So 1 less than or equal to 0. Condition is true. I'm sorry, 1 less than or equal to 0. Condition is false. So printf, this body won't execute. Okay. If the condition is true, then only the body will get executed. Here the condition is false, so no spaces will get printed. In the second iteration, what will happen? I value will become 4. So 1 less than or equal to 5 minus 4. 1 space. Yeah, our logic is absolutely correct. Let us trace this one once. So for S is equal to 1, 1 less than or equal to n value is 5 minus I value is 5. So 5 minus 5 means 0. 1 less than or equal to 0. Condition is false. So the control comes out from the J loop. This S loop. Next for J is equal to 1, J less than or equal to I. 1 less than or equal to, what is I value? What is I value? 5. 1 less than or equal to 5. Condition is true. So printf percentage d comma J. So 1 will get printed. J plus plus. J will become 2. 2 less than or equal to 5. 2 less than or equal to 5. Condition true. So J will get printed. 2 will get printed. Next to J plus plus. J will become 3. 3 less than or equal to 5. 3 will get printed. 4 less than or equal to 5. 2. 4 gets printed. J plus plus. 5 less than or equal to 5. Condition true. 5 gets printed. Next J plus plus. Next J will become 6. 6 less than or equal to 5. False. So the control comes out from this value. But we have to display the second row in the next line. So use /n. Here the logic is same in any programming language. Here I am writing in C, so that's why I am using printf function. So printf /n. So the answer will place us in new line. Next I minus minus. Previously I value 5. Next I value will become 4. 4 is greater than or equal to 1. Condition is true. Condition is true. So this body will get executed. For S is equal to 1, S less than or equal to n minus I. S value 1. 1 less than or equal to n value 5 minus I value 4. 1 less than or equal to 5 minus 4. 1 less than or equal to 1. Condition true. So one blank space will get printed like this. Okay. Next is J plus plus. J will become 2. 2 less than or equal to false. 2 less than or equal to 1. False. So the control comes out from the S loop. Okay. So we got one space here. Next for J is equal to 1. J less than or equal to I. What is I value? 4. So 1 less than or equal to 4. 1 will get printed. 2 less than or equal to 4. So 2 will get printed. 3 less than or equal to 4. 3 will get printed. 4 less than or equal to 4. 4 will get printed. So let us see this iteration also. Let us see one more iteration. So here, next what will happen? J plus plus. Next J will become 5. 5 less than or equal to 4. False. So the control comes out from the J loop. Printf /n. So the cursor will place us in the next line. All of you please listen. Please observe carefully. This iteration is very very important. Next I minus minus. I will become 3. 3 is greater than or equal to 1. Condition is true. So the body will get executed. For S is equal to 1, S less than or equal to n minus I. 1 less than or equal to n value 5 minus I value 3. 1 less than or equal to 5 minus 3. 1 less than or equal to 2. 1 less than or equal to 2. Condition true. 1 blank space will get printed. Next to 2 less than or equal to 2. Condition true. 2 blank spaces will get printed. Next S will become 3. 3 less than or equal to 2. False. So the control comes out from this S loop. Next for J is equal to 1. J less than or equal to I. 1 less than or equal to I value 3. So 1 less than or equal to 3. Condition true. 1 will get printed. Next to 2 less than or equal to 3. Condition true. 2 will get printed. 3 less than or equal to 3. Condition true. 3 will get printed. Next I will become 4. 4 less than or equal to 3. False. If you so in this way we can write this program. If we want to display output like this, here the values are same in a particular row, then instead of J we have to display I value. If we display I in the first iteration, what is I value? 5. Okay. So 1 less than or equal to 5. Condition true. But we are displaying I value. What is I value? In the first iteration, 5. So 5 will get printed 5 times. 1 less than or equal to 5. Condition true. So 5 will get printed. 2 less than or equal to 5 true. 3 less than or equal to 5 true. 4 less than or equal to 5 true. 5 less than or equal to 5 true. Okay. Next in the second iteration, I value will become 4. So 1 less than or equal to 4. 2 less than or equal to 4. 3 less than or equal to 4, 4 less than or equal to 4. So before that already we have written the logic for spaces. This is same only. Okay. If we want to, in place of numbers, if we want to display the stars, then what we have to do? Here we have to display, we have to use star. Then instead of numbers, these stars will get printed. So in this way we have to write these 3 programs. In the next video we will see some more pattern programs. In this video we are going to discuss about Pascal triangle program. First let's see what is a Pascal triangle. Pascal triangle starts with 1. So the first row contains only one digit, that is 1. If we consider the second row contains 2 digits, they are also 1 1. So second row starts with 1, ends with 1. It contains only 2 digits. If we consider third row also contains 3 digits. Third row contains 3 digits. It also starts with 1, ends with 1. And the middle digit is the combination of, it is the sum of its upper 2 digits. So 1 plus 1 means 2. So this is the output. Next, if we consider the fourth row. So fourth row is also starts with 1, ends with 1. And the next digit is nothing but the sum of its upper 2 digits. So what is 1 plus 2? 3. Next, what is 2 plus 1? 3. So this is the sum. Okay, 3. If we consider the next row, so the next row also starts with 1, ends with 1. So what is the digit here? The sum of its upper 2 digits. So 1 plus 3 means 4. Next, 3 plus 3 means 6. 3 plus 1 means 4. So this is the Pascal triangle. So each row starts with 1, ends with 1. So first row contains only one digit, second row 2 digits, third row is also starts with 1, ends with 1. 2 is nothing but sum of 1 and 1. Next, fourth row contains 4 digits. So 1 plus 2 means 3, 2 plus 1 means 3. So last row also starts with 1, ends with 1. Last row contains how many digits? 5 digits. So 1 plus 3 means 4, 3 plus 3 means 6, 3 plus 1 means 4. Okay. So for this we have to write the program. So in this example we need to have totally 3 for loops. In the first for loop, let us use a variable called I. In the second for loop, let us use a variable called S. S stands for spaces. In the next for loop, let us use a variable called J in order to print the data. Okay. Let us start the program. So parallelly we will discuss the logic also. Okay. So here how many rows are needed here? This is the first row, second row, third row, fourth row, fifth row. Okay. So first we have to read n value. Let n value is equal to 5. So if n is equal to 5, then we have to produce output like this. So n value is 5. Okay. So let's start the program. So for let the initial value of I is 0. So for I is equal to 0. So here n value is 5. So totally 5 rows are needed here. So for I is equal to 0, I less than n, I plus plus. So here 0 means first row, 1 means second row, 2 means third row, 3 means fourth row, 4 means fifth row. So likewise totally we will have 5 iterations. Next, for the spaces we are using a variable called S. Here how many spaces are required here? Let us observe here. So this is the first space, this is the second space, third space, fourth space. So 1, 2, 3, 4. So what is the I value here? In the first iteration I value is 0. If I is equal to 0, 1, 2, 3, 4, 4 spaces are needed. When I is equal to 0, 4 spaces are needed. Next, when I is equal to 1, 1, 2, 3, 3 spaces are needed. When I is equal to 1, 3 spaces are needed. When I is equal to 2, 2 spaces are needed. When I is equal to 3, 1 space is needed. When I is equal to 0, no spaces are required. Okay. So for that we have to develop the logic. For the spaces we are using a variable called S. Let the initial value of S is 1. So when I is 1, When I is 0, how many spaces are required? 4 spaces are required. But what is n value? N value is 5. So 5 minus this I, okay? So S less than n minus I, S plus plus. Printf within the double quotation, display one blank space, okay? Display one blank space. Here we have to display one blank space, okay? So now what will happen? S value is 1. So 1 less than n value is 5. So 5 minus 0 means 5. So 1 less than 5 means what will happen? 1 less than 5, 1 space. 2 less than 5, 2 spaces. 3 less than 5, 3 spaces. 4 less than 5, 4 spaces will be printed. So next, in the next iteration, I value will become what? In the next iteration, what is I value? I value will become 1, okay? Then what will happen? 1 less than, S is equal to 1, S less than n minus I. So n value is 5, I value 1. So 1 less than 5, 2 less than 4, 1 less than 4, 2 less than 4, 3 less than 4. So 3 spaces will get printed, okay? So our logic is correct. Next we have to print the corresponding values. In order to print the values in a particular row, we are using a for loop. Here the variable name is j, okay? For j is equal to 0. In the first iteration, how many values we have to print? One value, okay? In the second iteration, 2 values are printed. In the first iteration, what is I value? 0 is I value, okay? Whereas what is j value? J value is also 0. So 0 less than or equal to 0. One value will get printed. In the second iteration, I value will become 1, okay? Then what will happen? 0 less than or equal to 1, 1 less than or equal to 1. 2 values will get printed. So here the condition is very, very simple. J is less than or equal to I, J plus plus. J is less than or equal to I, J plus plus, okay? So in this for loop, just we have to write the logic, okay? Here the logic is very, very simple. If either I value is 0 or j value is 0, then we have to display 1, okay? If I is equal to 0 or j is equal to 0, here let us use a variable called c is equal to 1, and after that we will display c value. Else here, in order to calculate this sum, 1 plus 1 means 2, 1 plus 2 means 3, 2 plus 1 means 3, we have a formula. Just simply remember that formula. C is equal to, numerator is C into I minus j plus 1. C is equal to C into I minus j plus 1 by j. So this is the formula here. C is equal to, numerator is C into I minus j plus 1. This is an expression. So enclosed in parenthesis. This is numerator enclosed in parenthesis by j, okay? Now if either if or else one condition will be evaluated, then display that value. So printf %d, after displaying %d, give one blank space so that one space will be printed. Give one blank space, comma, display c value, okay? Next close the for loop, okay? Close this j for loop. Next use /n so that the cursor we places in the new line. After first row, we have to places the cursor in the second line, like that. Next close the for loop, okay? So this is the program. Now let's check whether our program is correct or not. Here let n value is 5. What is n value? N value is 5. So let's see the first iteration. In the first iteration, we have to produce an output like this, okay? For I is equal to 0, I less than n. So 0 is less than, what is n value? 5. 0 is less than 5, condition is true. For s is equal to 1, s less than n minus I. What is s value? 1. 1 less than, what is n value? 5 minus what is I value? 0. So 1 less than 5 means 1 space. 2 less than 5 means 2 spaces. 3 less than 5 means 3 spaces. 4 less than 5 means 4 spaces. Next, s value will become 5. 5 less than 5 means false. So totally we will get 4 spaces. So totally we will get 4 spaces. So 1, 2, 3, 4. 4 spaces will get printed. Okay. Next, for j is equal to 0, j is less than or equal to I. What is j value? The initial value of j is 0. So 0 is less than or equal to, what is the initial value of I? 0. So 0 is less than or equal to 0. Condition is true. Okay. So body gets executed. If I is 0 or j is 0, I value is 0, j value is 0. Okay. Logical error means if one of the condition is true, then the entire expression will be true. Here both the conditions are true, so the entire expression will be true. So C is equal to 1. If body is executed, so else body won't execute. Printf percentage d space comma C. So 1 will be printed. 1 will be printed. After that, a space will get printed. Okay. Next, what will happen? The body of for is executed. Next to j plus plus. J will become 1. 1 less than or equal to 0. Condition is false. Condition is false. So this for loop is successfully executed. So printf slash n. So the cursor will places in new line. Next to I plus plus. Next I value will become 1. Next I value is 1. 1 less than 5. Condition is true. So the body gets executed. So next what will happen? For s is equal to 1. S less than n minus I. 1 less than n value 5. What is I value? 1. 1 less than 4, 1 space. 2 less than 4, 2 spaces. 3 less than 4, 3 spaces. So now 3 spaces will get printed. Okay. So next what will happen? 3 spaces. Next this for loop execution is over. So control comes to this j loop. For j is equal to 0, j less than or equal to I. So the starting value of j is 0. 0 is less than or equal to I. So what is I value? 1. 0 is less than or equal to 1. Condition is true. So this body will get executed. I is 0 or j is 0. I is 1 here, but j is 0 here. J is 0. So this condition is true. So the entire body will be true. So C is equal to 1. Okay. So else block won't execute. Printf percentage d comma C. So C will get printed now. 1 will get printed. After percentage d we have a space. So a space will get printed. Next j plus plus. Now j will become 1. 1 less than or equal to 1. Condition is true. So body will get executed. I is 0, j is 0. But I is 1, j is 1. Both two conditions are false. So the entire expression is false. So else block will get executed. C is equal to C into, already C is calculated. What is C value? 1. So C 1 into I minus j plus 1. I value 1. J value 1. 1 minus 1 means 0. 0 plus 1 means 1. So 1 into 1 means 1. 1 by 1 means 1. So now 1 will get printed. After that a space will get printed. Because after percentage d we have a space. Next to j plus plus. J will become 2. 2 less than or equal to 1. Condition is false. So the control comes out from the for loop. Printf slash n. So the cursor will places in new line. So let us check for 2 more iterations in order to have the perfect clarity. Next to I plus plus. I will become 2. 2 less than 5. Condition is true. So this body will get executed. For s is equal to 1. S less than n minus I. N value is 5. I value is 2. So 5 minus 2 means 3. So 1 less than 3, 2 less than 3. So 2 spaces will get printed. Next control comes to j loop. For j is equal to 0, j less than or equal to I. 0 is less than or equal to, what is I value? I value is 2. So 0 is less than or equal to 2. Condition is true. So this body will get executed. I value 0 false, but j value is 0 only. J value is 0 only. So one condition is true. So C is equal to 1. So printf percentage d comma C. So 1 will get printed. After that a space will get printed. So next j plus plus. J will become 1. Okay. J will become 1. 1 less than or equal to 2. Condition is true. I is 2. J is 1. Both are false. So else block will get executed. C is equal to C into. The initial value of C is 1. So 1 into I minus j. I value 2. J value 1. 2 minus 1 means 1. So 1 plus 1 means 2. So 2 by, what is A value? 1. So 1 into 2 means 2. 2 by 1 means 1. So now C value is 2. Now C value is 2. So the 2 will get printed. After that a space will get printed. Because after percentage d we have a space. Next to j plus plus. Next to j will become 2. 2 less than or equal to 2. Condition is true. I value 2, j value 2. So both the conditions are false. C is equal to C into. The previous value in C is 2. So 2 into I minus j plus 1. I value 2. J value 2. 2 minus 2 means what? 0. 0 plus 1 means 1. So 2 into 1 by, what is j value? J value is 2 only. So 2 into 1 means 2. 2 by 2 means 1. So 1 will get printed. After that space will get printed. Next to j plus plus. J will become 3. 3 less than or equal to 2. Condition is false. So the control comes out from the for loop. Okay. So here the logic is very simple here. Here this is for number of iterations. So 5 rows are there here. So 0 less than 5 first iteration, 1 less than 5 second iteration, 2 less than 5, 3 less than 5, 4 less than 5. So 5 iterations. Next for the spaces, this is the logic. S less than n minus I. Okay. Next in the first row we have to display only one number. So 0 less than or equal to 0. In the second row we have to display two numbers. 0 less than or equal to 1, 1 less than or equal to 1. In the third row, 3 numbers. In the fourth row, 4 numbers. In the fifth row, 5 numbers. So for that we have written this logic. The logic is very simple. If I value is 0 or j value is 0, we need to print c value. Otherwise, this is the formula here. Okay. Simply we have to remember this point. Next to I plus plus. Let us see the last iteration. I plus plus. Now I value is 3. So s is equal to 1. S less than n minus I. N value 5. I value 3. So 5 minus 3 means 2. So 1 less than 2. Only one time condition is true. So only one blank space will get printed. Next for j is equal to 0. J is less than or equal to I. So 0 is less than or equal to I value is 3. So 0 is less than or equal to 3. Condition is true. So I value 0, j value 0. So j value is 0 only. So condition is true. So what will happen now? C value will become 1. Display that value. So after that a space will get printed. Okay. Next j plus plus. Now j will become 1. 1 less than or equal to 3. Condition is true. I value 0, j value 0. I value 3, j value 1. Both the conditions are false. So else block will get executed. C is equal to C into. The previous value of C is 1. So 1 into I minus j plus 1. I value 3 minus j value 1. 3 minus 1 means 2. 2 plus 1 means 3. So 3 by, what is j value? 1. So 1 into 3 means 3. 3 by 1 means 3. So 3 will get printed. Next space will get printed. Next j plus plus. Next j value will become 2. 2 less than or equal to 3. Condition is true. So this is the formula. C is equal to C into. What is the previous value of C? 3. So 3 into I minus j plus 1. I value 3. 3 minus, what is j value? 2. 3 minus 2 means 1. 1 plus 1 means 2. So 2 by j. What is j value? 2. So this will be cancelled. So 3 will be the result. So 3, after that a space will be printed. Next to j plus plus. J will become 3. 3 less than or equal to 3. Condition is true. So body gets executed. C is equal to C into. Because both these conditions are false. So S block will get executed. What is the previous value in C? The previous value in C is 3. So 3 into I minus j. I value 3. J value 3. 3 minus 3, 0. 0 plus 1, 1. So 1 by, what is j value? 3. So 3 into 1 means 3. 3 by 3 means 1. So 1 will get printed now. So if you observe this one, if we arrange these spaces, then the first row contains 1, second row 1, 1, third row 1, 2, 1, fourth row 1, 3, 3, 1. So in this way we can display Pascal triangle program in any program. Now let's see about pyramid program. Let's see what is a pyramid. Pyramid always starts with 1 here. Next, if we consider the second row, what is the next number? After 1 we have 2. So 2, 3. Next, the next digit is nothing but the reverse of this combination. If we reverse 2, then we will get 2 only. So next, after that, after 2 we have 3. So 3, 4, 5. And this one is nothing but reverse of 3 and 4. So 4, 3. Next, if we consider the next combination, then after 3 we have 4. So 4, 5, 6, 7. And here we have to write the reverse of 4, 5, 6. That is nothing but 6, 5, 4. Okay. So likewise we can have 5, 6, 7, 8. Next reverse of these numbers. Okay. So this is nothing but pyramid. If n value is equal to 4, then we have to display an output like this. So for that we have to develop the program. Let's see the program here. Here we need to have 3 for loops. In order to perform operations on the rows, let us use a variable called I. Next, in order to display the spaces, let us use a variable called S. In order to print the particular numbers, we use some other variable. So let us start the program now. So for I is equal to 1, I less than or equal to n I plus plus. So why we are using this for loop? Here what is n value? 4. So how many rows are needed? First row, second row, third row, fourth row. So 1 less than or equal to 4 first row, 2 less than or equal to 4 second row. This is third row, this is 4. This is the fourth row. So for that purpose we are using this condition. Next for spaces. Here before displaying this one, how many spaces we have to print? Let us calculate that one. So 1, 2, 3. So when I is equal to 1, then 3 spaces are needed. When I is equal to 2, 2 spaces are needed. When I is equal to 3, 1 space is needed. Okay. So when I is equal to 1, 3 spaces are needed. When I is equal to 2, 2 spaces are needed. What is n value? 4 is n value. So 4 minus 1 is nothing but 3 spaces. So the formula is 4 s is equal to 1, s less than or equal to n minus I, s plus plus. Display the spaces. Printf within the double quotations, give one blank space. So here we have to give one blank space so that we will get the corresponding spaces that we will discuss later while tracing. Next we have to print the numbers. In the first row, how many numbers we have to print? Only one number. So in the first iteration, I value 1. In the second row, here we have to print starting the number from 2 onwards. So I value is 2 only. In the third row, we have to print the numbers from 3. I value is 3 only. In the fourth row, we have to display from 4. I value is 4 only. So that's why we have to store I value in a variable called k. Okay. And after that display the corresponding value in the for loop. Here totally we have to use just 2 for loops. So this one is for displaying this pattern we have to use one for loop, and for displaying this one we have to use another for loop. So if we consider this one, so when I is equal to 1, we have to display one number. Next, when I is equal to 2, we have to display 2 numbers. When I is equal to 3, we have to display 3 numbers. Okay. So here every time the logic is very simple here. For let the loop variable is j is equal to 1, j less than or equal to I, j less than or equal to I. So when I is equal to 1, the loop will be repeated only once. When I is equal to 2, loop will be repeated for 2 times. When I is equal to 3, loop will be repeated for 3 times. J less than or equal to I, next to j plus plus. So here what is the output here? So what we have to do? Every time we have to perform the incrementation. So 2, 3 incrementation, 3, 4, 5 incrementation, 4, 5, 6, 7 incrementation. So k value is I here. Initially k contains I value. Let I is 2. So first 2 will be printed. Next we have to perform the incrementation. So for that purpose k plus plus. So perform the incrementation here only. So 2 will be incremented. 2 will become 3. This is post increment. Okay. Next after that perform the decrementation. K is equal to k minus 2. K is equal to k minus 2. Then after that here in this here we have 3 numbers, but here we have to display only 2 numbers. Here we have 4 numbers, but we have to display here 3 numbers only. Here we have 2 numbers, but we need to display only 1 number. So in this triangle we have to display 1 lesser. Okay. So that's why for j is equal to 1, here we have to use j less than I. There is no need to use less than or equal to. Okay. Next to j plus plus. Next to printf percentage d comma, perform the decrementation, post decrementation, k minus minus. Okay. K minus minus. Next printf k minus minus. After that we have to places the cursor in the new line. So for that purpose here use printf slash n, so that the cursor will places in the new line. Now let's check whether our logic is correct or not. So here n value is 4. So 1 is less than or equal to 4. Condition is true. So body will get executed. Next for s is equal to 1. S less than or equal to n minus I. So 1 less than or equal to 5 minus, what is n value? 4. 4 minus 1 means 3. So 1 less than or equal to 3, 1 space, 2 less than or equal to 3, 2 spaces, 3 less than or equal to 3, 3 spaces. So now 3 spaces will get printed. Next k value is I. What is I value? 1. So now k value is 1. For j is equal to 1, j less than or equal to I. Here what is j value? 1, I value 1. So 1 less than or equal to 1. Condition is true. Printf percentage d comma k plus plus. Okay. Printf percentage d comma k plus plus. So what is k value? The initial value of k is 1. This is post increment. What is post increment? First the value will be printed. After that incrementation will be done. What is k value? 1. So first k value will be printed and then incrementation will be done. Now k value will become 2. Next to j plus plus. Now j will become 2. 2 less than or equal to 1. Condition is false. So the control comes out from the for loop. Next to k is equal to k minus 2. K is equal to k minus 2. What is k value? 2. So 2 minus 2 means what? 0. Next for j is equal to 1. J is less than I. So 1 is less than, what is I value? What is I value? 1. So 1 is less than 1. Condition is false. So nothing will get executed here. Why? Because after 1 there is no need to print anything. So condition is false, nothing will get executed. Printf slash n. So the cursor will place us in new line. So now the cursor is here. So here we have the first row like this. Okay. Next to I plus plus. Now I value will become 2. I value will become 2. 2 is less than or equal to 4. Condition is true. So the body gets executed. S is equal to 1. S less than or equal to n minus I. So 1 is less than or equal to n value 4. 4 minus 2 means 2. So 1 less than or equal to 2. 2 less than or equal to 2. 2 spaces will get printed now. 2 spaces. Next, k is equal to I. What is I value here? In this iteration I value 2. So k is equal to 2. Next for j is equal to 1. J less than or equal to I. 1 less than or equal to 2. Condition is true. Printf percentage d comma k plus plus. This is post incrementation. So first k value will be printed. After that it will be incremented. Now k will become 3. Next j plus plus. Next j value will become 2. 2 less than or equal to 2. Condition is true. K plus plus. This is post incrementation. First value will be printed and then incrementation will be done. Okay. Now k value will become 4. Next j plus plus. J value will become 3. 3 less than or equal to 2. False. So control comes out from this loop. K is equal to k minus 2. So 4 minus 2 means 2. So now k value is 2. Okay. Next for j is equal to 1. J less than I. So what is j value? Here what is j value? 1. 1 less than, what is I value? 2. So 1 less than 2. Condition is true. Printf percentage d comma k minus minus. This is post decrement operator. So first value will be printed and then decrementation will be done. Okay. So that's why here we decremented with 2. Okay. So now we have 2 got printed. Next k value will become 1. Next j plus plus. J will become 2. 2 less than 2. Condition is false. So the control comes out from the j loop. Let's see this iteration. Next I plus plus. I value will become 3. 3 less than or equal to 4. Condition is true. Okay. Next s is equal to 1. S less than or equal to n minus 5. 5 less than n value 4. 4 minus 3 means 1. So 1 less than or equal to 1. Condition is true. So what will happen? One space will get printed. Next k is equal to I. What is I value? 3. So k value is 3. Okay. Next j is equal to 1. J less than or equal to I. So 1 less than or equal to, what is I value? 3. 1 less than or equal to 3. Condition is true. Okay. Printf percentage d comma k plus plus. This is post increment operator. Okay. So what is the previous value in k? 3. So first 3 will be printed. After that incrementation will be done. Now k value 4. Okay. Next to j plus plus. J will become 2. 2 less than or equal to 3. Condition true. So first k will be printed and after that incrementation will be done. Next j plus plus. J will become 3. 3 less than or equal to 3. Condition is true. So first k will be printed. After that incrementation will be done. Okay. First k will be printed. After that incrementation will be done. So k is equal to 6. Here an extra incrementation was done. So that's why we have subtracted with 2. Okay. Next j plus plus. J will become 4. 4 less than or equal to 3. Condition is false. So control comes out from the j loop. K is equal to k minus 2. 6 minus 2 means 4. Now k value is 4. Next j is equal to 1. J less than I. 1 less than, what is I value? 3. That means we have to print only these two numbers. 1 less than 3. Condition is true. Printf percentage d comma k minus minus. So first what will happen? First this 4 will be printed. First this 4 will be printed. After that this is post decrementation. After that decrementation will be done. So now k will become 3. Next to 2, 2 less than 3, condition is true. So first 3 will be printed and after that decrementation will be done. Next it will become 3, 3 less than 3, condition is false. Okay. So the control comes out from the J loop. Okay. Print up /n. So that cursor will place us in new line. Okay. So the logic is very simple. This is for row repetition and this one for displaying the spaces. And k is equal to I means what is happening. In the first iteration k value 1, in the second iteration k value 2. So from 2 onwards we will get the output. In the third iteration k value 3, in the fourth iteration k value 4. So likewise we will get the output. Okay. If you write a statement like this, k is equal to 1, then what will happen is, in the first iteration we will get 1 as the output. In each iteration it starts with 1 only. Okay. In the second iteration also it starts with 1. So 1 to 1. In the third iteration also it starts with 1. So after 1 implementation 1 2 3 2 1. After that 1 2 3 4. What is the reverse? 3 2 1. So likewise we will get the output. So if we do this minor modification, we will get output like this if n value is 5. If n value is 5, then 1 2 3 4 5 4 3 2 1. So likewise we will get the output. Okay. So this is about pyramid program. In the next video we will discuss some more patterns.